Hi all. Hello.
Hello,
Yeah, am I audible?
how are you?
Yeah, hi Dr. Davis. How are you?
Very well, and you? There's a
Yeah,
question. Who will pass the slides, my slides, you or me?
yeah, you can share your slides. If you face any difficulties, I will share on behalf of you, okay?
I send to you all the slides. Then you
Yeah,
can
then I
look.
will share, okay? If you face
Yeah,
any
yeah. Okay,
Yeah, can I share your slide now?
yes. I can tell you slide number one, slide number two. You post the slides. It's okay.
Yeah, it's okay. Perfect. I will do it, okay?
Okay,
Yeah,
good.
we'll start with our introduction, okay?
Okay.
Yeah, a very cheerful morning to all the honorable guests, speakers, delegates, students, and all participants present here. Coming to our past conference report, HK Conferences organized a second global webinar on artificial intelligence and data science on August 17 and 18, 2024. It's my honor and a great privilege in welcoming you to third global webinar on artificial intelligence and data science. Myself, Kiran, it's my pleasure to be a moderator for this conference today. On behalf of organizing and scientific committee, first of all, I would like to thank you all for finding time from your busy schedule to be here today. Today marks a major activity in the brief existence of Artificial Intelligence and Data Science webinar, a moment where we are interacting, sharing experiences, and reflecting on various areas. In this occasion, we shall have outstanding presentation from our prominent presenters, whom I believe shall enrich our insights and knowledge. Artificial Intelligence and Data Science 2025 program will focus on currently employed technologies, disruptive innovations, and the application of recent progress and evidence-based data. The webinar experience is for everyone involved in the delivery, development of artificial intelligence and data science, as well as those who are actively involved in participating in educational programs. The conference particularly welcomes contribution from faculty, researchers, industrialists, and students, etc. We highly appreciate each and everyone for their participation and also the chair and co-chair, namely Oluvol Fagbohan from UHOC UK and Professor Francisco Ayalori, Italy. We hope you enjoy the conference and your participation will contribute to our professional development and relationships. Yeah, without any delay, we'll start with our presentations. Our first speaker is Dr. Jose Miguel Jaldo. Dr. Jose is a seasoned professional with extensive expertise in business transformation, artificial intelligence, and fostering competitiveness in Africa. As a founder and president of UNL 3000 Associates SL, he has led investments and technology initiatives since 1987. He currently serves as a CEO of Devol Africa, where he is promoting AI-driven process automation in Africa. He is a partner of First Wind Group, where he is advancing renewable energy solutions across Morocco and Africa, among other projects. His specialty is developing Africa successful business in other countries. Previously, Jose held pivotal roles, including chairman and president of Tavex Group, where he led an MBO and senior advisor at Blackstone's Vistara Energy and McGraw Hill Professional, where he shaped strategies in energy and education. His academic background features a PhD in artificial intelligence and from Dutch Business School and executive training at Harvard University. Josie is also a prolific coder and speaker on AI, employment, and Africa's economic integration. Decorated with Wissam Alloy by King Mohammed VI, he continues to bridge industries and cultures. Please join me in welcoming our plenary speaker, Dr. Jose Miguel Jaldo.
Hello, how are you? Everybody listen to me?
Yes, we can hear.
Yeah, you can hear me. Okay. Then can I start?
Yeah, one minute. I will ask my colleague to share the PPT slides for you, okay?
Okay. Bon, right. As you know, my intervention is about the most practical application of artificial intelligence in companies and institutions and their effects on competitiveness and employment. Yes, good morning or good afternoon or good evening to everybody. That depends where you are. I am in Spain now, in Madrid. And then here is 9 o'clock in the morning. Before starting, I want to remember that still it is a big discussion in the world about how many people believe that AI is taking away jobs and how many believe that artificial intelligence is creating new jobs. Still, both perspectives are valid. I will explain that AI can be used positively or negatively, human-centered or non-human-centered. That doesn't depend of AI to create or destroy employees, depends of us, depends of people applying it. I will try to explain all my research and all my experience about this matter. Then,
Dr. Jose, we have
uh,
your PPT. Okay.
okay. Then please put the slide number 1.
Yeah. Yeah, you can check here. Okay.
Okay. Uh, you don't have the slide number 1?
Yeah, it is side number 1.
Okay. No. It's the other one. Sorry. Go to the one before. Okay. There's the introduction. This. My name is. It's not the one. It's the other one. The previous one, please. The previous one. My name is, as you know, Dr. Jose Miguel Zaldo. I am a senior engineer and hold a PhD in economics, specializing in the effects of artificial intelligence on competitiveness and employment. I also hold several master degrees in management, marketing, finance, sociology, artificial intelligence, metaverse, human relation, and others. I have many years of experience in business management and applying artificial intelligence and other disruptive technologies. I have focused on boosting competitiveness and efficiency in both companies and institutions. When I conducted a doctoral research on the effects of artificial intelligence on competitiveness and employment, few people were discussing about artificial intelligence, as it was not yet a popular subject. Therefore, I first had to understand what artificial intelligence truly was and where it could lead us. To predict the impact of the artificial intelligence, I drew analysis from the historical effects of previous technological advancement. Once I understood AI, I forecast that it would revolution everything, but I expected this transformation to occur around 2030. However, advancement in artificial intelligence have exceeded my expectation in terms of timing, though not in magnitude or potential. Remarkably, my thesis conclusion remain fully valid, as I have confirmed through the numerous practical AI applications I have participated in. Today, I will discuss the most practical application of AI in companies and institutions, emphasizing their impact on competitiveness and employment, all while underscoring the importance of ethics. Ethics is a fundamental element in all human activities, especially those that affect large number of people, such as decisions made by politicians, decisions made by corporate leaders, and decisions made by institutional managers. AI is transforming industries worldwide, offering unprecedented opportunities to optimize processes, improve decision-making, enhance transparency, and promote ethics. These advancements contribute to making the world a better place and improving the quality of life, particularly for the most vulnerable population. My goal is to present a balanced perspective on how AI enhances efficiency, fosters job creation, and improves overall quality of life. This presentation will primarily focus on the automation of tasks through robotic process automation, RPA, and artificial intelligence, AI, which I believe represent the most widespread and immediate application of AI. However, the influence of AI extends far beyond automation. It can revolutionize any task requiring intelligence. For example, I have recently explored how AI can radically improve competitiveness in diverse fields such as diplomacy, retail, and sports betting. In my opinion, there is no sector or activity where AI cannot be used to improve quality, speed, fairness, and cost effectiveness. Please, slide number 2. Please put the slide number 2. Please. Slide number 2.
Yeah, one.
Okay, it's okay. Slide number 2, as you can see, is the key concepts. Before exploring a specific application, let's clarify some key concepts. Robotic process automation with artificial intelligence means RPA, robotic process automation, automates repetitive tasks or any activity governed by protocols, rules, or laws, especially common, as you know, in public services. When integrated with artificial intelligence, RPA evolves into intelligent automation capable of handling complex processes with human-like accuracy, in my opinion, very often surpassing it, while operating faster without errors, bias, or corruption. Public versus private sector application. Public sector. Most government tasks guided by laws and regulations are prime candidates for automation. AI can significantly increase efficiency, reduce public spending, and eliminate corruption, ultimately fostering a more competitive and equitable economy. Despite its potential to improve quality of life, AI remains underutilized in the public sector, with some notable exceptions that we will highlight later. Private sector. AI drives efficiency, business growth, and innovation in products and services. While some jobs are displaced, new, higher quality roles emerge, and today's competitive landscape, and even so in the future. Using AI, will be essential for success. Professionals often fear losing their jobs to AI, but the real concern should be losing opportunities to peers who leverage AI more effectively. This shift is already happening, and understanding it is critical for all of us. Please, slide number 3. Application in companies. RPA with AI offers transformative application in business. The key areas include efficiency. AI reduces operational cost. For example, a logistic company using AI for route optimization significantly reduce fuel consumption and delivery times. Most companies can automate about 50% of tasks, freeing human talent for higher value activities and improving products, services, cost, and trust. Let me share a personal experience. A large company I work with had over 50% of its sales team collecting market data instead of engaging clients. By integrating AI-driven automation, we transform their roles, enabling them to focus on customer relationship. The result? A measure increase in sales and client satisfaction without a single job lost. This decision to retrain and redeploy staff rather than replace them was not only the best economic choice, but also the most human one, demonstrating that ethical AI use benefits both business and people. Innovation. AI accelerates innovation by predicting market trends and generating new ideas. It assists with brainstorming, research, summaries, prototype design, and coding. For instance, imagine using a very well-known application called GitHub Copilot to reduce development time by 40% or more, or to use Miro AI to organize 100 brainstorming ideas in seconds. Another one point is competitiveness. AI drives competitiveness by lowering costs, improving products, and enhancing customer experience. For example, a retail chain using AI chatbots for 24/7 support increase satisfaction, loyalty, and sales, fueling growth and job creation. RPA and AI tools also enhance hiring, competitor analysis, customer service, cybersecurity, and fraud prevention. Impact on jobs. While AI automates tasks, it creates more jobs that it displays by transforming roles toward higher value activities. Employees shift from repetitive tasks to creative and strategic functions, driving business growth. Moreover, AI fosters reskilling, providing tools for personalized training, career matching, and internal mobility. Let me share another experience that deeply impacted me and reaffirming my belief in balancing innovation with humanity. In a company of 400 employees in a small Spanish town, I was the president, and I automated an entire section, displacing 100 workers from their roles. While automation was essential for competitiveness, it was even clearer for me that I could not simply leave 100 hardworking people unemployed. Then I reached an agreement with the trade unions and local government to keep these employees on full salary while they underwent training, with a commitment to create new roles for them within 2 years. We achieved this in just over a year, thanks to business growth, driven not only by the new technology, but also by the employees' positive engagement and dedication. This experience touched me deeply and confirmed my belief that we must adopt new technology as soon as possible, but always while seeking human-centered solutions for those displaced. It is a very, very important point for getting the best of AI. Slide number 4, please. Slide number 4 is about application in public administration. AI can significantly enhance government operation by driving efficiency and improving public services. Key areas include streamlining bureaucracy. Governments should harness AI to automate routine tasks, especially those governed by strict protocols, laws, and regulations, as these processes are the easiest to automate. Benefits: increase efficiency, lowers cost, enabling tax reduction, and improve public services. Challenge: adoption face hurdles such as resistance to change and ethical concerns regarding transparency. For instance, in Europe, AI could mitigate issues like excessive public spending due to inefficiencies and absenteeism. However, resistance from trade unions and lack of political will often slow progress. We have many examples of AI tools to be applied in public administration. For example, a 24/7 automated public service information, virtual assistants handle citizen inquiries around the globe. We have also automatic document processing for reducing processing times for permits, licensing, forms, and invoices. We have public safety solutions. AI-powered tools detect gunfire incidents via IoT and predict traffic collision to prevent accidents. We have healthcare service, very important. AI-powered apps provide remote medical consultations. We have fraud detection, who identifies anomalies in government transactions to prevent financial misconduct. We have budgeting and transparency. Cloud-based software offers budgeting, reporting, and real-time public transparency. We have also disaster preparedness. AI-driven weather forecasting helps authorities respond to extreme events effectively. One notable example in Europe is Estonia, where 99% of public services are digital, saving the country at least 2% of its GDP annually. Estonia's model highlights how AI-driven digitalization can deliver more efficient, cost-effective, and citizen-centric public services. Slide number 5, please. Effects on employment. AI impact on employment is often misunderstood. Let's address some common misconceptions. Dispelling first. Automation does not equate to job losses. It shifts roles toward higher value tasks. Creating better jobs. AI creates opportunity opportunities in emerging fields such as data science, AI ethics, and automation management. Personal insight from experience. In my experience, AI application in the private sector only led to job losses when they are used with the intent to cut jobs, often due to the lack of confidence from managers and business owners in their ability to drive growth and competitiveness. When applied with vision and responsibility, AI creates new opportunities and drives business success. Public sector employment. While AI may eliminate redundant administrative roles, it allows governments to reallocate resources towards innovation and citizen-centric services, increasing value while lowering cost. In the medium term, this will make public services more efficient, faster, and cost-effective, ultimately improving public satisfaction and enhancing national competitiveness. And what if future vision? Imagine a world where AI helps governments cut unnecessary costs, reduce corruption, and deliver highly efficient public services. Imagine businesses thriving, workers transitioning into more meaningful roles, and entire economies becoming more competitive. This is no science fiction. It is already happening in countries leading AI adoption. The question is, are we ready to embrace this change and lead the way? Countries currently leading the way in using AI to really transform public sector include Estonia, Singapore, Taiwan, and in some way also United Kingdom. Others, they say they are applying, but just to simulate they are doing something, but not really to improve the quality of life of people. Slide number 6. Economic and competitive implication. The adoption of AI offers substantial economic advantages, including better products, AI-driven innovation enhances product quality and accelerates development. Faster, improved services. AI optimize customer experience, enable faster, more efficient service delivery. Cost savings. By reducing operational expenses, AI helps business and economies become more competitive. Increased trust. AI enhance transparency and supports data-driven decision-making, building consumer and stakeholder confidence. A stronger global competitiveness. Countries that effectively integrate AI gain a strategic edge, positioning themselves as leader in the global market. Slide number 7, please. Okay, challenge and ethical consideration. A very important point. AI adoption presents challenges that must be managed responsibly. Training and upskilling. Employees must be retrained to adapt to AI advancement, ensuring they transition into higher value roles and preventing unnecessary unemployment. Successful AI implementation requires highly skilled professionals, making continuous learning essential. Additionally, workers displaced by AI must be supported with training to take on new, more valuable tasks. Ethics and transparency. Issues such as data privacy, algorithmic bias, and accountability must be addressed. However, it is crucial to recognize that ethical concerns stem from human behavior, not from AI itself. In fact, AI can serve as a tool to enforce ethical standards in human activities. AI can act as a watchdog, ensuring ethical conduct in politics, business, and governance. For example, in Spain, political leaders often break campaign promises, sometimes with irreversible consequences. AI could track and report deviations from ethical commitments in real time, holding leaders accountable. Another critical area for AI oversight is public spending. Many European countries struggle with inefficiency resource allocation, contributing to excessive national debt. AI can promote fiscal responsibility by detecting inefficiencies, reducing waste, and preventing corruption. In summary, while AI introduces challenges, it also offers solutions to address many of society's most pressing ethical concerns, provided it is applied responsibly and with human-centered approach. Slide number 8, please. Conclusions. To conclude, AI and RPA offer immense potential to enhance efficiency, competitiveness, and meaningful employment. When applied responsibly, these technologies can unlock unprecedented benefits for society. Countries, business, and institutions that embrace AI effectively will achieve sustainable economic growth, reduce or even eliminate corruption, eliminate unemployment through job transformation, reduce or eliminate public debt, deliver more efficient public services, lower corporate and personal taxes, push transparency and fairness, set a global benchmark for ethical and responsible AI adoption. However, to fully realize these benefits, especially in Europe, we must abandon outdated beliefs such as one of the beliefs is public money belongs to no one. Believe me that it is said very often in many European countries, especially in Spain. As you know, that public money belongs to the people who have the right to demand transparency and eliminate wasteful spending. Another belief very often listen here in Spain and in other, not only Spain, but in other European and South American countries, is we must maintain or increase taxes to fund public expenses, when our goal should be to improve services, not spending, not simply preserve spending levels. Another belief is that reducing public spending is harmful, always is negative. Everybody says, no, reducing public spending is always negative. When you know that with new technologies, especially with AI, we can drastically lower cost while significantly improving public services. Other belief is private companies should not profit from public services, when in reality, well-managed private companies very often deliver superior services at lower cost, even while making a profits. Bon, to finish, at this moment, I have decided to dedicate all my experience to Africa, because fortunately, in Africa, still you don't listen in general. I mean, no, in all countries, many countries in Africa, you don't listen this, in my opinion, stupid beliefs. They are more open to apply the new technology. And I think that applying properly artificial intelligence and all the tools based in artificial intelligence in many African countries, we can obtain a much better health, very fast, very cheap, much better formation, training, much better public services. And I advise that thanks to AI, in the countries managed by people with humanity, we will see that they will have health, training, and public services much better than in Europe in very few years. Okay, I think it is enough. It is already 25 minutes. Thank you very much for your attention, and I welcome any questions you may have. Thank you. Thank you very much. Is okay the time?
Yeah, it's okay, Dr. Jose. Are there any questions? Yeah, thanks for your great presentation, Dr. Jose. Yeah. Our next speaker is Dr. Noha Salib. Dr. Noha Salib is an associate professor in creative digital technologies and construction at Middlesex University. She is a program leader for the MSc Building Information and Modeling Management programs at the university. She is providing consultation for both industry projects and organizations in sustainable design, construction, and digital transformation, BIM, digital twins, AI, and on-site project management. She is an advisory board of CIOB, BIM for Heritage, London Digital Twin Center, as well as director of BIM Africa Report and business development lead. She is an editor in chief of Smart Infrastructure and Construction Journal, with many contributions as a keynote speaker and publications in the area of sustainable construction technologies, such as digital twins and AI. She led multiple industrial and council funded grant projects with over 100 journals and conferences, industries, and book chapter publications. She has achieved several national and international awards for her expert work in the area of sustainability, digital twins, heritage, BIM, and construction innovation. Please join me in welcoming our plenary speaker, Dr. Noha Salib.
Thank you very much, Karen. Can you hear me? And can you see my screen?
As we can hear you.
Can you see my screen?
Yes, I can see you.
Thank
See
you
you.
very much. So thank you very much for the introduction. I guess that saves me a lot from my first slide. I would just like to thank everybody for being here today, and I'm very happy to be talking to you today about the topic that is related more towards usage of AI specifically in the construction industry, and specifically in something that we call life cycle analysis. So just to go on from the introduction about me, I have been very fortunate to be working in both academia and academic hat and in industry as well. And that has really solidified this merge between development in technologies like AI that I was very fortunate to be in, and applying it directly into industry. So if I may go forwards, I would like to talk today about three parts to my talk. First of all, what is life cycle analysis? What are the challenges that we have in the built environment? And then how do we generically use AI in the built environment at the moment? And then finally, I will go a little bit into more detail about using machine learning algorithms specifically for life cycle analysis of buildings. And happy, of course, to take questions afterwards. So regarding the challenges that we have in the built environment and what is life cycle analysis, of course, this is very familiar to everybody. We have huge problems worldwide when it comes to construction and regarding the built environment, from very poor quality buildings, slums, very poorly planned neighborhoods, which induce crime and induce all sorts of diseases and all sorts of problems. We have the climate change problems with wildfires and glaciers now melting and the soil drying up, which causes us problems. We have the pollution that is coming out of the buildings, which causes even more pollution to the soil and the earth and water, as you can see in front of you. All living conditions which are unlivable, unmanageable. So this is globally. But if we take a few statistics, they are pretty horrifying. So if we know that the built environment or the construction is responsible for consuming 50% of the world's raw materials, it is responsible for 40% of the world's energy consumption, 30% of the world's carbon emissions, and 30% of waste that comes out of it. Most of it goes to landfill, unfortunately, and not even reusable. This is pretty horrifying picture, and I think it needs a very pertinent solution to it. Our discussion today will be how AI can help with that, or is it helping, and how can it help forwards? If I go even a little bit deeper into the statistics of the energy consumption, well, in this chart it says 35, here it says 40, but they're very close. You can see the division between non-residential, residential buildings. Residential buildings is quite a problem, actually, and the construction. So just constructing itself is not that big of an issue, but it's operating the buildings that is the biggest problem. And this is where life cycle analysis comes into place, which I will talk about later. Same thing for emissions as well. As you can see here, it is divided up into the non-residential, residential, and so on, and construction is only part of it. Okay. This goes into a bit more deeper regarding the analysis of buildings. And this is what life cycle analysis is. It analyzes the different components of the buildings. And this is a statistical analysis that I performed on my own projects, our buildings that we have been managing. And if you look at the blue line up here, which is basically the benchmarks that are required by the European Union, for example, since I'm in Europe at the moment. Sorry. And the red line shows you how efficient current buildings are in comparison to the benchmarks that the EU require in carbon and energy, in indoor climate conditions like U values and air tightness and daylight and lightning and temperature and so on, water quality, air quality, pollutants, and wastes and costs. You can see yourselves how inefficient buildings currently are. Okay, so much talk about problems. So where does life cycle analysis come into place? Life cycle analysis is basically a method that we use to evaluate the environmental impacts that our buildings have at different life cycle stages. So what is the current impact on the environment that the building has, and how we can improve it in terms of what I just showed you, in terms of reducing carbon emissions, reducing pollutants, reducing energy, improving indoor climate, improving water quality, and so on. All of this is part of what's called life cycle analysis. Sorry. The important thing is that this wheel here shows you what aspects of the life cycle we can take into consideration to improve. So can we improve the way that we extract raw materials to reduce carbon and energy, let's say? Can we improve the way that we transport so that it is more local and we reduce carbon and energy in doing so? Can we improve the manufacturing process and transporting to construction sites so that, again, we reduce these things? While we are constructing, can we do the same? And then let's go on to the next phase of operations. The emissions themselves from the buildings. When you come to maintain it or repair it or renovate it or replace objects or just generally use the buildings, can we improve our behaviors? Can we do better installations, better materials in order to reduce the impact on the environment? If then we need to disassemble the building or demolish it, does it all go to landfill, or do we account for reuse of the materials, and in the disassembly we don't emit a lot of carbon? Or transport to waste disposals and so on. So all of this has an impact in what's called LCA. So please allow me to use the word LCA from now on. There are more devastating actions. I'm sorry, I'm still going on with the problems, but it is essential because the solutions after that will show that this is very pertinent. The final problem that I want to allude to is the effect on the environmental impact factors. Those of you who might be aware of them, we have 16 main ones, which look, I don't know, does that really connect to construction? I mean, toxicity, eutrophication, acidification, ozone. How does that connect to construction? Actually, it does. I'll give you a simple example. Did you know that the alarms, fire alarms that we have in our indoor spaces, if they are damaged, they can actually produce ionized radiation? That is just one example of it. So definitely unhealthy, causing human toxicity, could be cancerous, and other problems. Eutrophication is known as having a layer of greenery on top of our water sources, which prevents oxygen going down to underwater organisms and life. How does that connect to construction? Very easy. All of the pollutants that seep from the construction sites into the soil and into the water allow the nutrients in it for algae and so on to grow to prevent oxygen from going down. So all problematic things. All right. So how can we use AI then in construction in general? Or how are we currently using it? So it has many, many different applications. So first of all, of course, in improving design. So you can have generative AI produce different options for design, which help you find solutions that would be more sustainable for the environment and better for the indoor climate and usage of the users. It can also be used to reduce construction wastes, construction logistic transport, health and safety, and so on. It can also be used for smart operations. So the building itself becomes very smart. It adjusts the temperature, it adjusts the lighting, and so on in order to be suitable for the users and not over consume with carbon and energy. Also in offsite manufacturing, how can we produce modular design or modular prefabricated items without too much carbon and energy consumption? Material design, structural design, so that it will be resilient. And of course, using circular materials so that we can reuse them later. AI is now currently being used for all of that to help designers, constructors, and operators to better function in that way. These are some pictures from things which are currently being used using AI. So of course, we've probably heard that AI can be used to detect structural failures ahead of time for predictive maintenance in order to make buildings more resilient. That is sustainability, by the way. To sustain something is to keep it alive. So that is part of it. Another usage is using AI in heritage. AI has been used, as you can see here, to detect different types, to first of all classify and group all of the stones in that particular building's facade, and hence identify a strategy for maintaining them, replacing them if need be, and the age of them as well, and their level of deterioration. That is an incredible usage of AI in heritage. It has also been used to detect health and safety issues on site. As I will talk later, you can classify just from images whether there is a hazard in health and safety on sites or not. You can also use it to survey very, very quickly the amount of soil that needs to be removed, extracted, how to do that, where to position your tractors in order to most efficiently do that. Also maintenance inside spaces, design of different options which are more sustainable. So these are all currently different applications that AI is being used for. Now, if I go a little bit strategic, globally wise, we are all aware, for example, of the global warming that we have had almost 2 degrees since the 1850s till today, in just 150 years. And this has a lot of impact on buildings and from buildings. So how can AI help with this more global agenda for the built environment? Well, AI can definitely globally detect the percentage of energy efficient buildings all around the world. Where are the hotspots of inefficiencies? Why this is so it can begin to connect to different environmental factors which are affecting why those buildings are inefficient. And then there could be planning for low emission materials. How is that possible to procure in different global areas around the world? How are the different behaviors, cultural, maybe traditions, presence of different equipment, design methods used in different areas around the world. How are these affecting the sustainability of the built environment? Transportation routes, like for example, the current wars in the Middle East are preventing a lot of transportation to be happening in the Suez Canal. This has a huge impact if ships are not able to take that shortcut and go around a continent, for example, in order to deliver materials. Again, this will help with disaster mitigation and prediction of what the climate could be. AI is definitely useful in all of that. It is also useful in the global picture regarding greenhouse gas emissions. In addition to what I just mentioned in the previous slide, AI can also detect globally where are the hotspots of wastes, the way that they are being managed, the problems with them, how they can be mitigated, maybe how different regions around the world can help with that. So collaboration between nations, circular economy, how this is happening worldwide. Are there any carbon capture technologies being used worldwide? Why are they efficient in others? Why they are not? AI, when trained on all of this, can definitely help find those relationships and help with this. Okay, and finally, I just wanted to show how current off-the-shelf AI tools are being used in the construction industry at the moment. I mean, we have tens and tens of off-the-shelf AI tools. Of course, we know like ChatGPT and Copilot, but there are others that can be used in the planning, design, construction, and operations. And there are many names here which you can see which are maybe familiar, but there are others which are not as familiar, but they are used in the construction industry. So this brings me to my third and final part of my presentation. And this is about what specific machine learning algorithms can be used for life cycle analysis in buildings. And this is where I go a little bit deeper into a practical application that we actually did. As part of a funded institutional links project that I did in collaboration with the Egyptian government, we were tasked to use digital twins and AI in order, not tasked, but this was our objective, in order to improve the renovation of heritage buildings. And as we all know, Egypt has one of the wealthiest reserves of heritage in the world across different eras, from the ancient Egyptian, Roman, Greek, Coptic, Islamic architecture, and so on. So this was an example project that we were working on, a castle. I will not go into its details, but I will go into the AI aspect of what we were thinking about. So one of the questions, that's just one of them, that emerged when we were talking about renovation. If we want to renovate and use building materials with least embodied carbon in them. So this is a graph showing the different materials and their embodied carbon, okay? As you can see, the ones on the right here have lowest embodied carbon in them. However, there arose another question in addition to that. If we had the flexibility to choose which materials, and we were not to replace using specific materials, can we choose the ones which are also highest in recyclability impact? So they would be both low in carbon footprint and high in circularity. Can we do that? Well, the only solution to do that was to use AI to do this analysis. And this was one of the questions, just one of the issues that AI was able to be helpful in. If I just quickly review with us, and of course, this is all common knowledge to everybody here on the call, the different types of AI available. The one which I would like to focus on today is machine learning and its usage of different algorithms, specifically supervised, unsupervised, and reinforcement. These were the ones that we focused on the most in the project that I am alluding to, and I'll show you how. So if you allow me, I will just stay on this slide for a little bit because it contains the different solutions that we were trying to do, or that anybody can maybe try to use in their own projects. So as we know, of course, with supervised learning, if I start with supervised learning, it is about feeding the AI machine or agent with a lot of known inputs with known outputs. And this is how it learns to classify or group things based on these known inputs and outputs, or predict, which is another application that we call regression, of course. And that is prediction based on known parameters. So the AI learns to predict based on certain parameters. So how were we able to use that in our projects, or how can that be used in general? Okay. So these are examples of how it can be used and how we try to use it. For example, classifying the buildings or the materials in the buildings into low, medium, and high environmental impact. So that material or that building has a low, medium, or high environmental impact based on the data that we have on them. We can also use AI classification for diagnostics and forecasting, to forecast, of course, and that's one of the most logical one, the energy consumption patterns based on the legacy data or historical data that you're collecting from the building. You can also be able to use image classification, like just by looking at how things are implemented in the space, how the windows are fitted, maybe problems in the walls or in the fittings or the mechanical equipment or electrical equipment and so on. Immediately AI would be able to recognize where the inefficiencies are that could cause thermal inefficiencies, loss of heat across the walls, with types of insulation there, for example, the way that things are fitted that would cause more energy consumption to counteract for losses of heat and so on and so forth. So that is definitely something that image classification can help with. Also to classify wastes that are being produced, whether some of them can be reused, disposed of, and so on in a sustainable way. A fourth way is data validity and security. So the AI would be able to identify whether there are issues in the data that is being collected, especially if we are using IoT sensors, how that data can be cleansed, formatted, and reused in a better way. So all of this are examples of using classification of supervised learning. If we want to look at usage of regression or prediction, so I'll start with here. So we can predict the inventory that is useful for the building. So we can predict which materials, based on their carbon emissions and based on their embodied carbon, what would be the best to be used and which would be most circular, as I mentioned before. We can use it for process optimization. So predict what energy patterns we would have in future if we change certain behaviors in the usage of the space or install certain equipment or materials and so on, or change design. We can also estimate the expected life of the components or the expected life of the building itself, especially in heritage assets. It is also used for risk evaluation of what are the risks in case of using different types of transportation or different usage of the spaces. And something which is very odd is usage of it for market prediction. So what is the expected price of the of the asset in that particular area based on its energy consumption, for example. Now, if we go on to unsupervised learning is all about feeding data which is unknown. So maybe unstructured data, we don't know the outputs of the data, it's just inputs, and allow the AI to extract its own patterns and its own conclusions from the input data. So how can we use unstructured data for life cycle analysis in buildings? We can use it for clustering and dimensionality reduction. Clustering is when you also predict, but it's not based on parameters, it is based on patterns that have been identified from unstructured data. Can that be used in life cycle analysis? Of course. It can group buildings with similar environmental profiles and maybe find a relationship between their profiles and their environmental impact, and hence try to identify where their problems are that need to be identified. For example, in large urban planning areas. It can also recommend systems to use, like software that can be used. It can also be used for talent acquisition. So it can maybe identify the best people in the teams to handle certain things based on the work that they have been doing and their levels of production. It can, regarding reduction or minimalization of the data quantities and finding best outputs out of them, it can be used to find anomalies in large data sets that are coming out of IoT sensor telemetry data. It can be used to identify best features in certain design or construction or operations inside buildings. It can be reduced to used to compress the amount of data in documents, maybe from the data that we have from agencies or from planning permissions or any data that we have on databases on buildings, and find structured relationships between them. And lastly, I would like to talk about reinforcement, because reinforcement learning is one of my favorites, actually. As we all know, reinforcement learning is all about trial and error. So you tell the AI whether this is working or not, and it improves its suggestions or optimization plans for you based on it. There are many uses for reinforcement. Most of the tools of AI that we have right now, even with ChatGPT and Copilot and others, they do use an element of reinforcement because they shape the solution that they give you based on your feedback. So this is definitely one of my favorites, and it can be used for dynamic decision making, optimizing the operations inside the buildings based on the user preferences from light and temperature and heat and so on, but also with taking into account least consumption of energy and carbon. It could be used for automation and robot navigation. So how do you drive the best way to work a robot? 3D printing, bricklayering, and so on, based on feedback that you give that robot. Design optimization, we mentioned that before. Even in gaming, you can use VR for building management systems in order to get user feedback, user preferences, and improve the indoor operations based on that. And lastly, we have been using it for future bid optimization. So how do you write a best bid for pricing, best building performance, and include that in the bid? So these are all things that can be done in life cycle analysis using AI algorithms. And in this next slide, I have written the names of the specific algorithms that can be used to enable that. Of course, I'm happy to share this with anyone who is interested in this, but this is some really effective research and applications that we have been doing and currently involving as well in some major projects across Europe. Funnily enough, Dr. Jose said in the previous presentation about roles and employability. I just wanted to allude very quickly to how that impacted our roles as well on our project, our heritage project that I just showed you. So ideally, when you think about what skill sets you need for a construction project, you are usually faced with these on the left here. Normal engineers and managers and building information modeling specialists and renovation specialists, environmental specialists, and so on. But what we realized is that with the introduction of AI, we needed even more skill sets, the ones on the right here, to employ or at least to make sure that our employees had them. So to reiterate what Dr. Jose was saying earlier, AI can actually open more opportunities for skill sets. It's not just about taking people's jobs away. It also opens many opportunities. I mean, even just looking here, you need a prompt manager, someone to manage what you actually put inside off-the-shelf solutions if you're using them, or if you're making your own bespoke solutions. You need, of course, coders and data mining analysts and visual analysts and trading analysts and predictive data analysts, so many different roles, and ethics as well, as also Dr. Jose mentioned earlier, in addition, of course, to security. So I just wanted to allude to that. This is an additional a few roles which I added here. I'm not going to go into them. If anyone is interested, I can, of course, share that with them. But to finalize my talk today, I just wanted to say that it's very interesting that we are doing all of these applications now, whilst we are still here, almost like between stage 1 and 2 of of artificial intelligence, the narrow and the general artificial intelligence. It scares me, but also excites me to think, what would the possibilities be if we go as far as super intelligence, which is what we see in sci-fi right now? What would the possibilities be in future in something like that? And with that, I am happy to take on any questions if anybody has any. I hope that this was interesting, and I hope you have a great day going forward.
Are there any questions? Yeah, there is a message for you, Dr. Rodolfo Valaka. Congratulations, Noha, for your presentations. Very interesting.
Thank you very much. And I'm happy to take any emails afterwards about this. Thank you.
Yeah, thank you very much for a great presentation, Dr. Noha. Our next speaker is Dr. Min Sang Yu. Dr. Min Sang Yu is a Chief Strategy Officer of Korean Representative Autonomous Startup with 10 plus years of research experience in legislating technical policy and law to enhance vehicle safety with the Korean government. He is a result-oriented leader who makes collaborations using interpersonal communication to obtain with 50 plus patents related in autonomous vehicle and 10 plus awards including the Korea Prime Ministers. Please join me in welcoming our keynote speaker, Dr. Min Sang Yu.
Hello, everyone.
Yeah, hi, Dr. Min Sang Yu.
Yeah, hi. My name is Min Sang, and I'm the Chief Strategy Officer of Autonomous A to G. Good evening, my time, and afternoon your time. Yeah, and thank you for your time today. I will be discussing the trends and prospects for the commercialization of autonomous vehicles. Can I start?
Yes, you can.
Yeah. Before diving into the contents, let me introduce myself. Given my background in the startup sector, I am excited to share some practical insight on the current trends in autonomous vehicles, providing a perspective from within the industry. I spent more than 10 years at Hyundai Motor Company, focusing on autonomous vehicle strategy. Now I'm using what I learned there to lead strategy at a leading startup here in Korea. My main role is to legislate technical regulation to ensure that new automotive technology, such as autonomous vehicle, can be applied in mass production. Let me tell you a little about our company. This will give you an idea of why I am speaking today from the perspective of the autonomous driving industry. Yeah, Autonomous A to G will live up to our name by delivering comprehensive solutions for autonomous vehicles, covering everything from A to Z. Our journey began in 2018 with a talented team of engineers from Hyundai Motor Company. And in just 5 years, we have established ourselves as a leader in autonomous driving solutions in Korea. In 2023, we earned the distinction of being the only Korean company to be ranked 13th by Guidehouse in their global evaluation of autonomous driving firms. This recognition is extremely meaningful to us, considering Guidehouse manages over 3 billion in annual revenue and has spent 7 years evaluating firms in our field. With such a solid foundation, I'm very excited to share our perspective on where the autonomous vehicle industry is going. Autonomous vehicle first grabbed the international spotlight at CES 2017. Google had already made waves in 2016 by unveiling cars without pedals and steering wheels. By 2017, other automakers shared their detailed plan for autonomous vehicles. Audi wanted to retrofit their A8 model with the Level 3 autonomous driving technology by the end of 2017, but faced issues with the regulations and system implementation roadblocks by 2018. So they pivoted to improving their infotainment system instead. And also, Honda unveiled a concept car with the Level 4 technology in 2020, named New but by 2021, they have only managed to produce 100 units of the Level 3 autonomous vehicle, the name is Legend, for government use. So Google's Waymo had tried to retrofit a Chrysler Pacifica into a Level 5 vehicle and had mass production plan starting in 2021. However, as of 2025, Waymo's operations are still limited to pilot projects in just 3 US cities: Los Angeles, San Francisco, Phoenix. So what about in 2024? 7 years later, Argo AI, the once a top autonomous driving company, shut down due to financial struggles despite the significant funding, which is approximately 3.7 billion US dollar. Argo AI struggles to turn on profit. After a failed deal with Amazon, the company closed its doors following 22 years of operation. Moving on to Neuro, known for building autonomous delivery vehicles, has recently had to make tough decisions, including layoff workers. Also, they haven't started mass production yet, even though they got exclusive authorization to produce Level 4 autonomous vehicle in 2020. Mercedes-Benz remains the only automaker with a Level 3 certification from KBA, a Germany's authority, which is Germany's government certification. Yeah. Also, Mercedes-Benz is holding exclusive leasing license only in Nevada and California since 2021. This clearly illustrates the slow pace of commercialization, even level 3 autonomous technology. What is causing the delay in bringing autonomous vehicle to market? The commercialization of autonomous vehicles face significant delays, primarily due to liability and legislative issues. Lawmakers are grappling with the regulation for AI-driven vehicles, such as UAM and robotics. In fact, it took 5 years just to draft the legislation for Level 3 autonomous vehicle. The United Nations projects that regulation for Level 4 autonomous vehicle and beyond could extend well past 2027. Initial discussions began in December 2017, so this will be the first case of legislation in the world. How to apply laws that apply to humans to AI is a big challenge and difficulty for legislators. Economic consideration also play a role. Tesla, for example, they have generated a significant profit from level 2 ADAS without advancing higher driving levels, showing that the financial risk currently outweigh potential gains. Safety is paramount in this industry because a car is not just a product. It's a product that carries lives. That's why extensive testing and cautious adoption are essential. Even with 99% safety assurance, the complexity and risks associated with autonomous driving technology slow down commercialization. Auto transmission and airbags, which we now take for granted, took 50 and 25 years, respectively, to become commercially available. Like an autonomous vehicle, how are going to be responsible if it shift gear autonomous and then it goes into reverse gear? Does it make sense to set up gunpowder in the car, even install it in the steering wheel in front of my face? Why would you do something so dangerous? The sentiment is very similar to the current distrust of autonomous vehicles. Moving to legislative hurdles. Legislative hurdles are significant. The United Nations is focusing updating rules for Level 2 autonomous vehicle. However, progress towards higher levels are taking it slow and steady. That's because the Level 3 regulation took 5 years to legislate, and even now, 4 years after it was enacted, only Mercedes-Benz is certified in the world. Will they be able to speed up Level 4 legislation under this circumstance? Probably not. And in the US, the approach is quite different. There are no strict laws, but just guidelines for autonomous vehicles. And it's been almost 8 years since then guidelines were introduced. This level of regulatory freedom has been a key in fostering innovations. However, Germany has put in place specific law, and these laws are boosting the local market, and they focus on public transportation and logistics through allowing B2B transaction. Let's dive into an intriguing question. What direction will the autonomous vehicle market take? Looking ahead, initial commercialization will focus on B2B transaction by 2030. Projections from consulting firms indicate that half of the shuttle bus market and a quarter of taxi market will transition to autonomous vehicle. Germany is leading with tailored legislation for early commercialization phase, and they are focusing on broader social acceptance and technological stability. Korea is also on this path, with plans to finalize its own B2B regulation within this year. So, who's going to dominate the level 4 market then? traditional OEMs are primarily focusing on level 2 and 3 of autonomous vehicle technology. Hyundai Motor Company, among these automakers, has announced its timeline for adopting level 3 autonomy. However, there hasn't been an official announcement from Hyundai regarding their plans for adopting level 4 autonomous vehicle. New entrants like Waymo, Cruise, and Mobileye are expected to lead in level 4 technology, shifting the market from traditional automakers to startups developing purpose-built vehicles for specific operations. This segment is largely about purpose-built vehicles, which are designated for specific low-speed operation and resemble boxcars on the wheels. We expected this to starting hitting the market around 2030. So the journey to commercialization has been slow and steady, focusing on public transportation and B2B sectors. However, rapid shifts are possible, similar to the transition of New York's Fifth Avenue from horse-drawn carriage to cars in just over 10 years. As we navigate this journey, it's crucial to remain adaptable and forward-thinking, ready to embrace rapid advancement. Conclusion, the autonomous vehicle market opened the B2B market for public transportation and logistics. And in history, we can find the same history when horse-drawn carriage to cars changed time in the early in the 19,000 years. So we have to monitoring this change like today. So why we the focusing the change in mobility era because it's very rapid change and radical shift. So continuous observation important of market changes. Yeah, thank you for your attention and for joining this discussion on the trends and the future of autonomous vehicle market. I look forward to any question you might have. And then if you have any question for longest word, please feel free to email me. Thank you.
Are there any questions? Yeah, thank you very much for a great presentation, Dr. Min Sang Yu.
Thank you.
Yeah, our next speaker is Ms. Bisola Kayode. Yeah, Ms. Bisola Kayode is a results-driven cybersecurity professional with a robust portfolio of skills and experience in incident response, security operations center management, and cybersecurity and transformation. As an AWS solutions architect, ISO 27001 lead implementer, and CISM certified expert, Bisola has significantly impacted organizations such as Deloitte and Prudential Zenith Life Insurance, She has led initiatives to optimize software development life cycles for security integration, implement advanced threat modeling, and drive compliance with global security standards. Her work has consistently balanced robust security frameworks with practical business needs, enhancing organizational resilience against cyber threats. In addition to her professional accomplishments, Bisola is an active contributor to the cybersecurity community. She volunteers with the Young CISO Network and Borderless Tech Sharing. Her expertise to inspire and mentor the next generation of cybersecurity professionals. Her publications on Web3 wallets and CIO CD pipelines further showcase her commitment to advancing knowledge in the field. Combining technical excellence with strategic foresight, Bisola is poised to offer valuable insights on the evolving cybersecurity landscape. Please join me in welcoming our keynote speaker, Ms. Bisola Tayode.
Okay, hi everyone. Okay, my name is Bishala, and today I'll be speaking on the state of AI-driven cybersecurity, the trends, challenges, and opportunities. So basically, I'm going to be making an introduction where I just talk about the motivation, the background to the presentation, and why AI, or why AI-driven cybersecurity solutions, and and also the motivation for the talk. So first of all, it's no news that AI is transforming every sector, and the cybersecurity sector is no exception. And some of the things that we now see in cybersecurity sector is that the traditional methods keep struggling, and AI over time, or as we see it now, has helped to improve threat detection, real-time analysis, and also incident response. Now, why AI? AI because AI models can help to process vast data, for early threat prediction and detection. And also, the machine learning algorithm continuously learn and improve security measures over time. Now, the motivation for the talk is that AI over time, strengthens cybersecurity as much as we look at it in terms of detection, prediction, and also real-time analytics. But just that it has also introduced some vulnerabilities, and so we must also look at this very carefully. Just as we have the advantages of having AI-driven cybersecurity solutions, we also have the disadvantages with the maliciously trained AI models. The current trends in AI-driven cybersecurity solution, and the focal point is going to be about enhanced threat detection. Now we see the trends we have today is AI models. They can analyze security logs and user behaviors. They've helped in terms of endpoint security to detect anomaly. And we also have the AI-powered security information and event management tool, which help to detect potential threats in real time. Now, when we look at it from the aspect of predictive analytics and automation, we can see that with the help of analytics and automation, AI-driven network monitoring continuously help to spot anomalies. Now, among all of this, there's been recent developments. We can see that some of the AI models, are maliciously trained by criminals, and also there's also been the increased adoption in cybersecurity initiatives concerning AI usage. So, back to the story, we want to talk about the evolution of cybersecurity from manual to AI-driven approaches. Now, the birth of cybersecurity in 1970s, where, the first computer one was introduced, the Creeper, and antivirus Reaper was also introduced or was created as it is. So we also have the 1980s where there's now the rise of commercial solutions for, in cybersecurity, such as antivirus and ethical hacking tools gaining traction. In the 1990s, we saw that there's now development of firewalls, the IDS, the IPS, there's the internet, there's now talk about internet security. And also in the 2000s, we can see that there's early adoption of machine learning. We are now looking at how do we train, how do we train the ML, for anomaly detection, data-driven detection, or looking at using known signature of, okay, this is how the threat is, or this is what makes a worm. And we are building that into our cybersecurity solutions to see, okay, if any of this condition is met, then this virus is a worm. This virus is a logic bomb, something like that. Then in 2000s, we can see that the integration of artificial intelligence, where we now have it in terms of malware analysis, deep learning, and so in the 2020s, such as a lot of things happened in 2020, and that has changed the perception of the world even till now. And the advanced AI and emerging challenges, where we now have federated learning for threat detection and a lot of adversarial machine learning challenges. Academic insight and key research papers. So while all of this is going on, there's also been various publications, because a lot of interest, a lot of people or researchers are beginning to pick interest in AI-driven cybersecurity, the impact on artificial intelligence, machine learning models, and cybersecurity. And a few of those, or very notable among, is the AI potentiality and awareness, the human AI teaming in cybersecurity. And also there's the AI-powered phishing detection, enhancing email security in enterprise, written by Sparker and also Shira. So from these papers, there's the findings that talk about, AI helping to improve threat detection and response significantly by reducing the false positive. So one of the major things in cybersecurity tools and solutions is that, when even because of some of the way how the solutions are built, there's bound to be high false positives, and also high false positive. But some of the findings we now have is one of the impact of AI or artificial intelligence in cybersecurity is that reduction in false positives and also enabling proactive security measures. Now, why this is also, this is very advantageous to the sector, we are beginning to see some challenges in terms of data poisoning, adversarial attacks, and even model update vulnerabilities. Now, AI models need constant training, that's for sure, so that to update, because cybersecurity threats or the threat in this sector is ever evolving, because we have people that are dedicated to creating new viruses, new malware. That's just what they do. So the threat is is ever evolving threat. It can never stop. And so AI models need constant training, updates to remain resilient against evolving cyber threats. And from the research paper, we can see that there's a need for, adversarially trained AI to counter sophisticated threats, and also the explainable AI to improve transparency, trust, and ethical AI deployment. Yeah, so in terms of the adversarial learning in cybersecurity, we can see that, so from what was said, from what I'd explained earlier, some of the examples of adversarial AI attacks in AI-driven cybersecurity. Now, looking at it from the angle of the disadvantages it has to the sector. Now, evasion attacks. Excuse me. So the evasion attacks involve malware that bypasses AI-based antivirus tools by altering the file structures or behaviors. Now, when you look at the evasion attacks, one of the examples to look at is the cyber ransomware, which used machine learning to, for evasion attacks. in terms of using invasion techniques to bypass AI-based detection systems. And the reason why it's able to do this, or the reason why this ransomware can do this, is because of the, employed polymorphic mode. So it's constantly changing its signature. So for AI-based detection system, it's going to be very difficult because of the polymorphic, or code that that it has. So making it very difficult for the traditional, even AI-based antivirus tools to detect. And one of also thing to look at the cyber attack is the multi-layered obfuscation technique in terms of, data segmentation, segment encryption to evade detection. And moving on to data poisoning. Now, very fundamental very notable among some of the disadvantages is data poisoning. Of course, data is good, that's what we say, yeah. So data poisoning attacks involve injecting malicious data to train AI models, incorrectly, and thereby creating whether security blind spots or creating a very, very offensive cybersecurity model. Like, for example, what happened in 2016? Excuse me. What happened in 2016 when Microsoft AI chatbox, the AI chatbox that Microsoft produced, was poisoned by malicious user. They fed it with racist and offensive content, and within 24 hours, the AI chatbots began producing highly inappropriate and offensive responses. So this incident has actually reinforced that, this is an aspect that we as cybersecurity professionals, or in this sector, the researchers in this sector, need to actually start paying attention to, because, excuse me, an AI that is maliciously trained, we always have, no matter the use of that AI tool or the use of that AI-driven cybersecurity solution, is going to be very offensive to people. If there's a backdoor in a cybersecurity or a solution, in a cybersecurity solution, then at the end of the day, the major use for that solution will probably not be used, or, even attackers can actually get as much data through backdoor or, through different cybersecurity attacks. So the backdoor attacks, really, one of the examples, like I was explaining, is the backdoor attacks that talks about introducing hidden cybersecurity, more like, backdoor as the way, introducing hidden cybersecurity in AI models, which can be exploited later, or creating a loophole in an AI model, so that maybe later the attacker can actually exploit that loophole and be able to maybe harvest data or create a malware, etc. And yeah, so moving on to the implications for cybersecurity research. A lot of research, as I say, that in this sector, there has to be a continuous and ever-evolving research in AI-driven, cybersecurity, the impact of artificial intelligence, machine learning in cybersecurity sector. And we can see that, the importance of this research, one of the things this research is going to do for us is going to enhance resilience against evasion attacks using more robust adversarial training methods, implement data validation strategy. Data validation checks is something that's very important in cybersecurity. So to detect and prevent data poisoning in AI models, and also strengthen the backdoor detection technique. So if there's a backdoor in an AI model, or even AI, cybersecurity solution, this can be detected on time. And also the use of explainable AI to help to improve transparency and trust in cybersecurity solutions. And of course, there's also some of the key papers, that are supporting this, written by Goodwill Fellow et al., Kalini and Wagner, etc. So the opportunities and advancements in cybersecurity, when it comes to the opportunities and advancements or the advancement that artificial intelligence, as we look at it, has had on cybersecurity, And when we look at it, we're looking at it from the aspect of the defense, from the blue team aspect. So in this case, the defense team, right? The defense cybersecurity subsector. That's the way to put it. And so we have the AI-driven behavioral analytics for insider threat detection and anomaly detection. In terms of, AI, we now have, with the help of AI, we are able to have behavioral analytics tool for insider threat detection and anomaly. Then also we have the automated SOC, which a lot of people are now beginning to say, we don't know how a security operations center can actually function, without humans, but we are beginning to see that play out. And also, there's also the AI-powered threat intelligence platform, that can help to analyze attack patterns and predict the future. Now, we have a lot of emerging technologies discussion that is, even in artificial intelligence or machine learning itself. But now, we now see that, we are beginning to see the impact in cybersecurity, the federated learning. Now, this will help to, or this has helped, or it protects data privacy, while improving cybersecurity insights across a large network. So that's the distributed network. Then there's the explainable AI, which, as we know, it increases transparency, accountability in AI-driven decisions. So when a model is making decision, there has to be a reason for it. It's not just AI say, okay, this is it, and that's fine. And no, in cybersecurity, there has to be a reason, because we are talking of protection here. And there has to be, because of how fragile the sector is. So there has to be transparency in terms of the solution. When solutions are built, there has to be transparency in the decision-making of that AI solution or the AI models. Also, there's the quantum safe encryption, ensuring that, AI-powered security systems, they remain resilient in the age of quantum computing, which, quantum computing is a very, very evolving, security, but it's going to have a big impact, on encryption in cybersecurity. And a lot of people are beginning to look at how the impact of this, even in various sectors. Yeah. So in terms of AI-powered phishing, so you just case in point, dwelling in just one of those phishing attacks. We know, like, phishing attacks is one of the major attacks because it has to do with human. And in cybersecurity, human beings are like the weakest link. So because we have emotions, we see things. Sometimes we make decisions. Only us can understand the decisions we make. And we are the weakest link. So for a solution, your input is what you get for output, right? So, but in cybersecurity, as in cybersecurity, human beings, we are actually the weakest link, and we're actually the most important asset. So at the same time, yeah. So phishing attack make up one of the 80% of, a very significant percent of the enterprise security incident, and continues to evolve in sophistication, right? So, but what we've seen is that AI models, with the help of AI models, we can now achieve 96.8% detection accuracy and outperforming the rule-based, detection system we have for phishing cybersecurity solutions. So, benefit of AI-powered phishing, detection in this case, there's real-time phishing identification. It helps to also reduce false positives, yeah, and also it also helps with NLP-powered analysis. It examines, so now with the airport, AI models can help examine the email headers, content, sender reputation for phishing patterns, which is something that, in this case, over time, even in the course of my career, I've done it. I've had to do this very, very manually, doing the email headers analysis, sending to see, okay, is this a pattern or is this not a pattern? Is this sender? If the sender, is this a real IP address, or the person is using VPN, to divert? These are the things. But if you have an AI model that can actually do this automatically, I think that will reduce the burden. And the future directions and global trends emerging research areas. Yeah, so a lot of involving discussion. So, it's something that we're looking at in terms of cyber threat intelligence. That's a subsector in cybersecurity. Yeah. So we have like enhanced real time. It helps to enhance real-time cybersecurity insights and automated response. Then there's also the advanced deception technology. So honeypot is like a deception technology that, when an attacker wants to enter like a network or, an IT environment, an organization can create like, something, a replica of that environment, and the attacker would think that, oh, that's the environment, or they've already gained access into that environment, but in the real sense, they've not gained access. So that's one of the deception technology that, we have in cybersecurity. And that would actually help the organization know the tactics of that cybersecurity attacker to say, oh, okay, so if you had entered our environment, this is what you would have done, this is what you would have done. And they look in the real environment, do we have controls? Do we have solutions that are helping us to guide against these tactics or these and techniques, these attackers' techniques? So they are able to do that. So, back to advanced deception technologies. We have AI-powered honeypot and decoy systems to trap cyber criminals. This would also help. And also, blockchain is one of the very, very interesting topic to talk about. And AI and blockchain integration would actually help, in terms of data security, and would also help in security in terms of the distributed ledgers. Yeah, so I know in terms of policy and global collaboration, a lot of people, I know a lot, even ISO, that's one of the cybersecurity organizations that help to, in terms of cybersecurity standards, that help, publish some of the cybersecurity standards. And, so now they're now beginning to address the AI governance in cybersecurity. So because there has to be an adoption. We can't just say, oh, because of these disadvantages, we don't want to use AI, in the sector, and say, oh, okay, no, there has to be. It's something that's come to stay. AI is not going anywhere. It's just looking to say, okay, if the risk, understanding the risk and also addressing the AI governance in cybersecurity, a lot of firms are now beginning to have, they have generative AI in this case. They have generative AI, even within firm, but just that they've trained these AI models, and they now have it privately within the firm. So, which is something interesting. So, and also the regulatory compliance. So, so in conclusion, right? Yeah, so no doubt AI has come to stay, just like I said. It's just in cybersecurity. Initially, there were discussions about, oh, are you sure this is not possible? Cybersecurity is a very, very fundamental to, information technology, and therefore AI cannot replace human beings. But as we see it, we can see that AI can actually be used in machine learning. AI can actually be used in different aspects of cybersecurity. And so it's something that we have to adopt. The revolution is here and has come to stay. Now, AI is revolutionizing cybersecurity by improving threat detection, response, and also predictive analytics in security. And challenges remain adversarial robustness, really. So in this case, is constantly training the AI models to actually, feed them with these evolving cybersecurity threats, the tactics, the techniques of the cybersecurity attackers, if the AI models are trained, so they are able to, help, for better threat detection. And also global cooperation is needed to enhance AI's responsible and effective use in cybersecurity through standards, policies, etc., that are also built into this cybersecurity solution. Yeah. So final thoughts, balancing AI-driven automation with human intelligence is very important to securing the future. Yeah. All right. Okay. Thank you very much. Am I supposed to stop sharing now? Ooh. Yeah, so if you have any question or anything. Oh, okay, interesting. Oh, yes, please go ahead. Sebastian.
Hi, thank you so much, Bisola, for this. Can you hear me?
Yes, I can, yeah.
Yeah, thank you so much for this timely presentation. I mean, it's called timely because over the weekend, I was reading on Sploker accounts for 2024 research report update on cybersecurity. And early last year, I started working on a project for European banks. which we started our first phase in October. And we are trying to build a system with the European Commission that will assist financial institutions across Europe mitigate DORA, that is Digital Operational Resilience Act, that focus mostly on building cyber resilience. Now, my meeting for the first phase of the project comes up next week. And based on my findings on the first pilot, one, the system we put in place, we discovered that AI starts generating its own attack strategy, surprisingly.
Oh,
Now,
interesting.
Two things. Then secondly, I discovered that the people that we are working with are seeing some of these regulatory frameworks as creating a false sense of security. So laying that foundation, first of all, you mentioned that there's a rule-based process for phishing detection that had 96%. I would like to connect with you after now to get that report and to also study or reach out to the authors to understand where that framework or the algorithm they use or whatever. Now, my first question will be, if AI can generate attacks autonomously, could we reach a point where cyber warfare is happening without human involvement? Because that is the question I'm trying to pose. In fact, yesterday, I had a list of 25 cyber experts that I want to have a roundtable conversation on to understand this for our next phase of our project. So could we reach a point where cyber warfare will be happening without human involvement?
Yeah, so because AI, I don't know, there's the buzz about AI. AI is actually just a computer, really. Is whatever you feed it with. So is a technology, and technology as we know it, they don't have their own mindset, right? So it's about whatever it is you feed it into, whatever you feed into it, that's what you're going to get. Now, but just that because AI is able to predict vast data, so you feed it with so much data, so from that data, they are not able to make decisions. So it's the amount of data that you feed it into. Now, you spoke about the solution about the tool that is making their own. Now, maybe there's a backdoor in that solution. I'm guessing there's a backdoor and somebody is trying to, play some stuff. But really, in the real sense, the reason why AI is okay, AI, really, even aside from generative AI, because what most people know is the generative AI aspect where, I can ask AI to make decisions for me, or ask AI, do you think this is right? Then AI will go through the internet, through the different vast of APIs and say, oh, okay, you know what? This is wrong, this is right, something like that. So that's what we know for generative AI. And if you want to be feeding, if you want our, now for, just to really summarize what I said, just to summarize that point, for a privately or like in some organizations or where I work, where we also have our own generative AI model, they are not as efficient as a typical ChatGPT. Why? Because of the amount of data that tool is exposed to, right? So they are not, if you ask questions, you say, sorry, I don't know this, I don't know that. So that's exactly, so for me, to your question that say whether AI can, there's going to be a cyber warfare, definitely that can be, it's something that can happen maybe in the future or depending, because this is an ever-evolving technology. Technology is ever-evolving. But we should know that whatever it is that we feed it with is what we are going to get. So if malicious users feed it with something that is very offensive, that's what we are going to get. Yeah. I hope that answers your question. And if not, we could connect after this.
Yeah, to be honest, it does, but I'm still confused in the sense that we did not feed the data because I was the one that built the model with a team of other experts. So, and we got license on the data we fed from in European institutions. So I think it came to a point because we were doing self-defense techniques where we'll just create some vulnerabilities and ask it to learn. And it gave us good accuracy, But along the line, when we're now deploying it, we now noticed that it now generates its own attack autonomously. I mean, it's mind-blowing and it's mind-boggling as we speak. So, but that's fine. I'm happy to have more dialogue on this. Now, can you speak more about regulatory frameworks? Can we say it's helping cybersecurity or it's just creating a false sense of security? Now, the reason why I'm saying this is based on the social experiment, the clients that we work with. And in fact, I've scheduled 7 posts to go out this week. One is live on my LinkedIn page based on my findings and trying to ask public questions to understand that. One is live on my page as we speak, and 7 of them will go out each day on this. So, what do you think about this regulatory framework? Because it seems that we are trying to police the policing, and it makes me now start to understand, is it that AI generated cyber attack is now sophisticated that they exploit vulnerability? So are we creating a false sense of security as regulatory frameworks in cybersecurity? What do you think based on where you sit in AI governance?
Yeah, so that's a very interesting question. So for me, yeah, there are, we have, the thing is, usually there are so many regulatory frameworks, there are so many policies, there are so many standards, but are they correctly being implemented? Really? So if there's incorrect implementation of standards or policies, then indeed there might be a problem and usually what we see with firms is even the GRC sector, right? That's like in this case, governance, risk, and compliance in cybersecurity, where we have people in that subsector, trying to. When you check across organizations, are they actually in charge of implementing? Are they actively implementing? Firms that say they are ISO 27001 certified. When you look at it, are they actually certified to the core? Of course, I know, it's about ticking the boxes and say, okay, this, that is done. But if you look at it, when you dig down into the implementation, they're actually not correctly done. They are just done on the surface. And this is one of the problem in, AI governance that people are now saying, see, because of the type of threat, or is it the quality of threat now, if there's any word like that, for the cybersecurity, right? In the cybersecurity sector, for AI models, we have to carefully look at how we can implement. So if you are saying there's encryption or some of our systems, so what encryption are you talking about? Are you talking about encryption in transit? Are you talking about encryption in what's it called, in database? Even within private networks, right? In terms of the file sharing, are you using encrypted protocol to even share files? So these are the little things that we want to look at it. But I would not say that regulatory framework or standards, cybersecurity standards and policy, they create a false. No, they don't do that. It's because of we humans. We don't implement this correctly. When I say we humans, I mean the firms. Yeah, we don't implement this correctly, and then when we attack, we now realize that we should have done this, we should have done this. Check for every cybersecurity attack, especially if it is not 0-day. Somebody has not implemented the control correctly because one, budgeting, one, different issues. Yeah, so this is why, so that's why that attack has happened. So just to answer your question in some way, that I don't think regulatory frameworks, they create a false sense of. If the problem is implementation, if it's not implemented correctly, then there's going to be a problem. Yeah.
Sorry for the interruption, Ms.
Thank
Bisola.
you.
Yeah, thank you.
Yeah, thank you very much for a great presentation, Ms. Bisola. Our next speaker is Mr. Othman. Mr. Othman is a seasoned IT entrepreneur, AI expert, and data science leader with over 25 years of experience. He has founded multiple companies and spearheaded global AI and data science initiatives. Othman is passionate about integrating AI into business solutions and is an active speaker at international conferences on AI, digital transformation, and smart cities. He combines his deep technical expertise with a unique focus on psychology, enabling him to design human centered AI solutions. Utman is also dedicated to coaching professionals to excel in the rapidly evolving tech landscape. Please join me in welcoming our keynote speaker, Mr. Utman.
Thank you very much for introduction. Let me double check if I'm audible. Can you hear me very well? Can you see my screen?
Yes, we can hear you, Dr. Uthman.
Okay. All right. Thank you very much again for attending, and very happy to and delighted to join this nice conference with this great people. We'll talk about AI. It's endless. We're talking about every day almost, and I wanted to deep dive a little bit about the cognitive part of AI, and in relation with data. So shaping the future of human-centric cities, from smart city to cognitive city. And I will try to explain the differences between that and walk you through those journey. Now, very short about myself after the great introduction. Nothing much to add. I'm a passionate IT entrepreneur and psychologist. Serial startups and companies in the past 25 years, started in my 16s. And I'm very passionate also at the academic world. Last 12 years, I've been honored to develop curricula for several universities in Europe and also in the MENA region. And I provided several coaching sessions and mentoring for the next generation. And like I'm doing today, I'm really happy to speak a speaker in several conferences worldwide about mainly smart cities, artificial intelligence, business, and governance. And today we will dive deeper on the smart city part. So after this introduction, I want to take you with me in the evolution from a smart city to a cognitive city, and we'll see what are the differences there. The very important integration of data science and put the human on the centric part and not the technical as a central. And then we'll check together the roadmap and the challenges about what's coming next and where we already in. First of all, smart or intelligent. So that's a definition that is used or misused sometimes. Something it's the same, but it's a real difference. Smart is just following rules and instructions, and intelligence is more than that. And I have done an example or a smart exercise in university, and I was told the ask the students in two groups. One of the groups, the goal was to put my phone to my home. And I didn't give any instructions to one team, and the other team, I gave them instructions where I live and what is the best route to follow. And they should be aware of traffic jam and all these instructions. So both teams followed the rules, but the other team, I didn't give them anything. I just told them that your goal is to put this phone and get it back in my home as soon as possible. So the first team followed my rules and instructions, and they did that very well and very practical, and they achieved the task. But that was smart of them to follow the instructions as good as possible, and being very alert of traffic jam or maybe things obstacles they can get on the way to my home. But the intelligent team, they didn't have any information, so they had to find and think and try and retry to even find out where I live, what is my address, how to get there, what is the best approach, what is the best transportation model. So dealing with all this, that requires intelligence, because you're then context aware. Where am I? Where do I have to go? What do I have around me? You should learn, because on the way you learn what is the best way to get to the home of the professor, taking a car, plane, bicycle, walk. You have to adapt, you have to forecast, there's raining on the way, we should take precautions. There's a lot of things you have to foresee before you start the journey. And during that journey, you're busy with collecting the data yourself. So that's why I make the difference here, because we're talking a lot about smart cities, but we want to go to intelligent cities. And that's why we call it also artificial intelligent and not smart artificial. So from smart cities to a cognitive city, in the traditional smart city, we collect data, we put applications above that data, and then we have like a system. So for example, we collect data of the traffic, and we use an application on that data like a smart traffic light, and based on that we can manage the traffic light on an automatic way. But if we go further in a cognitive way of going to a cognitive city, it is more of not only collecting data, but it is collecting data from different sources, pre-processed and prepared data. But the core here is to integrate these data, let data talk with each other, and the data and the system we're building should be context aware. We'll talk later about that, but the context awareness is very important to improve the decision making and to respond on what's going around, and not just if then else or the real based model of previous AI. In that way, we try to mimic human thoughts because humans have cognitive capabilities and capacities, and we try to mimic that. Then we come closer to act and make decisions more like a human brain and not just as a machine that's very abstract thinking. So when getting this together, so we collect, then we connect and give it context, and that's what when we have knowledge. And what we need is not only data, but we need knowledge. We need to know what is going around and how to adapt and forecast and be dynamic on what's happening around us, and not only processing data with collecting and processing and output. So when we collect and we connect and add the context around it, then we have knowledge, and that's where something becomes from smart to intelligent. So the role of the data and the core of data in this whole situation of smart and cognitive cities is that data is the foundation, like everyone knows here, of AI. Without any data, we don't have anything. If a person doesn't learn anything, he has no data, he doesn't learn or go to school or learn anything in life, then it's very difficult to be smart or to be intelligent and become knowledge or obtain knowledge. So that's the core. And we're dealing here with structured and unstructured data. We have structured data like data coming from several inputs, and we know what is the weather forecasting, what is the traffic forecasting, what is statistics data we have from the past, and we have some calculated data. But we have also a lot of unstructured data, like the previous doctor mentioned in machine learning. It is unsupervised learning. So there's not something that we already know, but something we are going to explore during the journey, and using several techniques like the previous doctor explained very well. The reinforcement learning, for example, is dealing with unstructured data, and when we get the data, we have to deal with it immediately and structure it, pre-process it, and turn it into knowledge. So what are examples of context-aware data? One I already mentioned is predicting traffic congestion and adjusting traffic signals accordingly. But another one is when we have like street lights are going on off based on the rule base. For example, when it's daylight, then the lights are going off, and when it's dawn or sun's going down, then the light is going on. But when we have context-aware data, then we know that at the end of this road, where there are the traffic lights, where are the street lights going on at sundown when the sun goes down. But we know today there isn't happening in that area. For example, let's say there's a major football match, or there's a major event going on in that day. And we know also that There will be the weather conditions will be different, so it may be more dark this night. There will be a lot of people going to that event. There is maybe security cameras around that needs more light, and all that context and all that data that is connected to each other. Then it gives us more quality of those traffic lights or the street lighting to go maybe on several in different times than the regular days, or it happens in Amsterdam, Barcelona. I've seen it also in North Africa, that these lights are going to shine more to help the CCTV cameras around to recognize people on that event, so that they are not allowed to go, and to do more with that with the quality of the light. So when we manage the different resources and connect them to each other, we get more quality data because it's contextualized, and then it will give us to a city that is not only smart but is intelligent, because it knows where it lives, and it knows what it's going on, and not just rule based on predefined actions. So I also do the comparison between HI and AI. Who is in control? Is human intelligence still in control, or is AI taking over? That's well, I won't say a battle, but that's something will go on for forever, I guess. AI started and still, in my opinion, mimicking the human intelligence. We're not there yet. And I don't know if we'll get there and if we want to get there, but it's always how is human acting, how is human thinking, and that's what AI try to mimic and try to do for sure better, faster, more enhanced, because it has maybe more capacity of data storage than human being, and analytics, and the speed is different, but it's still the human intelligence that AI tries to mimic, and not the other way around. So humans sets goals. We want to do something, and we have a goal, and that's what we want to achieve. We will talk later about ethical part, but we have that. We have emotions. We have ethical frameworks. We have a lot of more goals than the AI, which is a machine, and what we give it, it will give us back. When we talk about stages of AI, when you go maybe to the next stage of AGI or maybe super intelligence, there will be a different discussion. But now we are still in control. We are dictating what AI should do for us to make our life a better place, and to enhance and facilitate a lot of things we can do ourselves, or maybe we won't want to do anymore. So AI is very good at analyzing data, identify patterns, optimize the processes, recommend us what is the best thing to do, automate a lot of tasks we don't want to do ourselves anymore, and help us with making better decisions. So it is not going to take over at all and make the decisions for all. Sometimes we let it, but sometimes we will only use it as a very good and powerful tool to give us the possibility to make even better decisions. For sure, we always face technical challenges, like complexity of the data. We're getting more and more data, and the quantity is very much. So we will have like processing power getting more important, how to pre-process the data, clean up the data, because rubbish in, rubbish out. So the huge amount of data gives us the complexity how to deal with the data, and that's why because of AI and thanks of AI revolution, many other jobs coming up. We've talked, my previous colleagues talk about AI replacing jobs or adding more jobs. I still believe it will do them both, but it will shift the focus from some of the jobs maybe we are not good at anymore, and AI can do better. We have done that in the aviation years ago when introducing the autopilot in the airplanes. That is more powerful and more secure than having a pilot do everything manual for a flight of 12 hours. That will happen more and more in our day life. The cultural preservation is a challenge. We integrate the city with AI and with automation and with all this robotics taking over, but we should never forget and let go the cultural aspect of the city, the cultural heritage of the city, the atmosphere of the city, how a city feels, and the history of the city. That's something we should never get out of sight. And how are we going to preserve that using all these automated processes? And the interoperability is the seamless integration of AI across a lot of surfaces. That surfaces can be almost autonomous to use each other. So the winners, like we're talking this year is 2025. Most people call it the year of AI agents. We create agents for a certain task, but we create also agents that maybe create other agents or that trigger other agents, like colleagues working together. So we'll have AI agents working together, and the seamless integration of these agents or these different services that are driven by AI will be very key and challenging how to do that in a very correct way. So what about a lot of other stuff? Like my previous colleague said, security, ethics, privacy, trust. All these aspects are very, very important, because when we go very fast with the speed we are now developing AI, not only even say each day, but each hour something new come up, and other service, another possibility coming up, we could go too fast and use these aspects. But they are very, very important to keep AI helping us and not taking over the good stuff in our life, and AI taking over stuff maybe we don't do, we shouldn't do anymore as humans, to have more quality time for other things that really matter and that we won't be taken about over from AI. And what I just mentioned before, the cultural aspect, diversity, the values, inclusivity, fairness, that's something we should always be in control as humans, and have AI helping us do that better and better, and not just give AI to do everything and we just sit there and watch. We should use AI to the maximum to take over repetitive tasks, so we will have more time for this, for the cultural aspect and the ethics and the diversity and all this stuff. The security is very important. AI is a powerful tool and helper to give security and enhancement. For sure, it's a cat-mouse fight, using AI also for hacking, and it is also a powerful tool for that. But using the best of the tool for both aspects, making it more secure, having monitoring more better and better. And for sure, the other side will also use AI for the bad things, and that's, well, actually the act of life will always have bad and good things. Try to keep each other in balance. The privacy is a very sensitive and yet important aspect. We need data. We need to collect data to give more services in higher quality and better AI. But collecting this data and getting this data should be done in a very responsible matter, because we should never lose the privacy of our humans outside. And then I come to the last, but not at least one, and that's trust. This is all about implementing AI and embracing AI. Is about building trust of all these services and maybe machines around us that are there to help us. We only sleep in the plane because we trust that there is an autopilot, but we also trust there is a pilot that's very skilled and studied for years, and there are two of them keeping each other in sight, and they are keeping us safe. So if we don't have that trust into the system and into AI, we won't go sleep at the back seat of an autonomous car, or maybe put our kids in the car and just giving the destination via an app and trust the autonomous car to bring our kids to school. So it is not only technical aspect. We can go very, very far with technical innovations, but if we don't build the trust on those machines or on those solutions, we won't. So the autonomous city of the future, of actually, we are already in the future, or we're just today, so we're not predicting anymore like science fiction movies. We're living everything what science fiction movies just a couple of years ago were predicted, and more to come, and more is there already. So we are in self-regulating traffic, automated public services, autonomous cars is coming and are there already, driverless taxis, cabs. So we have a lot of things already going on, and it's now for us to embrace it or to go against it. Regulations try to block a lot of things. We're using regulations. We are in a fight to see the right balance, because we want these facilities and we want to embrace them, and they make our life easier. But at the same time, we have a lot of challenges, ethical considerations, like I told, security, privacy, trust. So the balancing control is the key here, that the human should stay in the center of all this, and not the technical driving us. And that's where sometimes goes lost, that we are having the technical innovation leading us, and forget that it's about us as a human. So I really going for a human-centric approach. So the prioritizing human well-being and quality of life. That's the goal. And AI development and everything what's around us is here to make it to make our life better. And it's not we are living to use AI and to produce AI and to go for and just make it faster and better and better and better. But we should always have the goal. It's about the human. So we are in control, and we are the people here want to do something to have other qualities that maybe we don't have now, because we don't have time to go for quality of life, and we have to do a lot of things ourselves, and to make a living, and we're working 20 hours a day to become better and better. But what about if we have like the assistance we get now, thanks to the innovations, to be real there to helping us take the boring task maybe, or the repetitive task, so we will have more quality of life. So to do that, we really have data governance. We really have we need again the building trust on what's around us, so we can stay in control. We can trust the new technology that is coming here to make our life better. So in summary, what is happening and already, and what is the future, the focus is we need first an infrastructure. If we don't have an infrastructure that really facilitates the upcoming technologies, then we don't have a solid base. The infrastructure should be like AI powered technologies, sources of data that is pre-processed, processed, and well collected, connected, contextualized. So we have real solid infrastructure of knowledge, not only the data. We shouldn't forget the regulations, so it should be clear, the legal frameworks, the urban environment, safety, liability, ethical concerns. That's a very important aspect as well. And then we'll have the public acceptance. So if we don't accept to give a little bit of our privacy for a better surface, if we don't accept the autonomous driving vehicles or the cabs, then technology will be useless. At the end, are we ready or are we already late? And the key takeaways I want to emphasize here is AI-powered cities in general must be human-centric. So we should not be technology-driven, but human-driven. Just the technology innovations and advancement of technology should lead us what we do, but what do we want to improve our lives. So always put the human in the central. Ethical part we should keep inside. Our values are very important. We should not be becoming like AI is mimicking the human, and if we don't, if we lose this aspect, there will be humans mimicking AI in the future. So we'll almost want also to become as good as AI, and AI should always try to be as good as us in the practical part, but the human part, the cognitive skills part of the human being should always be in the center. Collaboration, not only between AI agents and the systems and services and the data connections, but collaboration between the humans as well to make this a good way of living. And again, adoption. AI is here to stay. AI is here for a long time ago and will be there for the future for us. So we should adopt it and embrace it in a correct way. It's not against us. It's not threatening us. If we stay in the middle and stay in control, it will be the greatest thing happening to humans, because we will be embracing it and let AI take over the task AI can do better. So we will have more time for other things AI maybe not be able to do, or maybe we don't want AI to do that. So we can spend more time with our loved ones and have a quality of time, and not just being focused on working and producing and check out the checkbox of our to-do list daily. So the final thought is not if cities will become cognitive, but rather, are we ready for this transformation? Cities are becoming cognitive, and they are already cognitive. What I'm telling you here is already happening in worldwide, and it could be many examples of that. But we are here we are not late, but we should be ready. If we are not ready, then we are late. So we are here to embrace what's happening around us, and we are going to create this ourselves. So it is not the technical elite dictating what we should do and we should embrace and go for it, but it's a collaboration between technical innovation and the human part. Thank you very much for your time. I want to keep it short. If any questions, somebody.
There are no questions, I think.
Yes, thank you very much, Laurie. I'll be happy to connect with everyone offline, and we can have other discussions in another time. Thank you very much all for your attention.
Yeah, thank you very much, Dr. Putman.
Bye.
Bye-bye. Our next speaker is Mr. Balaji Sundara. Mr. Balaji is a coach, advisor, and a senior product leader with over 2 decades of experience in building secure, resilient, and scalable enterprise platforms. Balaji has led several product organizations in his career, including Cisco, Oracle, Dell Boomi, BMC, and Axway. He was a senior product leader of product management at BMC Software, where he led consolidation of service data with operational data for AIOps. His expertise lies primarily in engaging with clients and laying the foundation for technological transitions. He is currently leading Composio towards its value proposition of AI agentic systems with the use of LLMs, APIs, and RPA. Please join me in welcoming our keynote speaker, Mr. Balaji Sundara.
Thank you, Kiran. Can you hear me?
Yes, I can hear you.
If you can go to the first slide, then I'll start speaking about it.
Yeah, I will share. Yes, you can proceed now.
Thank you, Kiran, and thank you, everyone. I have a bit of a cold today, so I won't be in my topmost performance today. But I'll definitely try to do this as best possible in my way and impart the webinar in a way that you can understand it. Any questions that you folks might have, reach out to me. My email is available with Kiran and along with the presentation as well. So I'll be happy to entertain questions via email and answer those questions to you. So next slide, please, Kiran. Yeah, so the reason we are seeing this pictorial is the easiest way we can understand why we need tools. The reason we need tools is because as long as humans or animals have been alive, anthropologists and archaeologists have actually figured out that a tool makes an animal or a human more powerful. A monkey actually depicted in this picture used a tool to crack open a peanut shell and to consume peanuts from that peanut. Humans used two stones to strike with each other and create fire. So important discoveries came along the way after the discovery of fire. Similarly, humans who have been ever innovative and ever cognitive have figured out many, many different tools over their lifetime to make things easier for themselves and for the prosperity of the humanity in itself. So tools actually enhanced the capabilities of humans as well as animals. And human endeavor is always has been to create tools to make tasks easier for themselves. So if we have understood this very simple fact of why tools are used, it is the same principle that applies for agentic tools to make the task easier and make the task better for AI. Next slide, please. Yeah, so before we proceed into the tool discussion, let's talk about what really AI agents are. We have spoken, I mean, several other speakers today have spoken about AI agents and AI in general. The definition that I would like to put forward is a very simple definition for AI agents, which is very simply put, AI agents is nothing but a software that actually uses artificial intelligence, essentially LLMs, and tools to accomplish tasks and goals. Goals is what everyone is after, making life simple, making life more productive by using these LLMs and tools to accomplish tasks. In the process of using these tools and achieving goals, there is memory. So, very simply put, I will say that, humans, when they use tools, there is a function of memory. The memory is essentially our brain, which is actually telling us how to use those tools. Very similarly, an AI agent will actually need to use memory and an ability to remember how to use those tools across tasks and between the different states. So memory is very, very essential for an AI agent. The next thing that we look at is models, which is how do AI agents use the models? There are many different LLM models available today, and each LLM model has its own specialty and it has its own advantage for using a particular LLM. So which LLM to use and which model to use to accomplish the task by an AI agent? That's one of the underlying principles for using the AI models to complete tasks. And we'll see an example of this in this presentation. Tasks. What are tasks? Essentially, when it comes to an AI agent, a task is nothing but a function call. It's either like using ability to use an API, ability to use an iPaaS or integration platform as a service, or like RPA to accomplish the different tasks. So APIs have been set up for various software products. iPaaS is an integration platform as a service, which is integrating two pieces of software and those mechanisms are very useful for completing certain complex tasks that could be software to software interconnectivity that could be used by an AI agent to accomplish certain tasks. RPA is software created and written particularly for certain robotic processes, for certain software that do not have an API access. So you would need to use robotic process automation to accomplish those particular tasks. Once we have these particular tools, we can use any one of these methods, which and function call to these methods to accomplish the tasks by using API, iPaaS, or RPA. What is independence when it comes to AI agents? The ability to decide on their own on how to accomplish the tasks. So, you may have all these different tools, API, iPaaS, and RPA, but which tool to use at any given time is a decision that an AI agent makes to say that I need to use this particular API, let's say Google API, to write an email to a certain user from whom an email actually came to my inbox. So it can use the Google API to decide how do I respond to this particular email and send an email back to a certain user. And the last but not the least in this particular list of items is logged errors. Logged errors are very, very important for AI agents. Why is the reason? I can explain it right now, which is... Kiran, what's the disturbance on the line? Can we ensure everyone is muted, please?
Yes, they have muted.
Okay, thank you.
I think just now they have joined. Okay. Sorry for
Thank
the
you.
interruption. Okay.
Thank you, Kiran. So logged errors are very important for AI agents. I'll explain the reason why. In traditional, we have logged errors, which come out as like logs, error logs for software. Traditional QA and traditional customer service looks at the log errors and decides how to fix a particular problem in the software. And these are essentially referred to as bugs. Logs are very important for solving those bugs and for maintaining the software continuously. Similarly, AI agents learn a lot of things from logged errors. So it's just experience. So we are using an AI agent to accomplish certain tasks. Certain tasks might not be accomplished by AI agents, and that's what throws the logged errors. Logged errors are like a feedback loop for the agents. So using the logged errors, the AI agent can figure out what is the mistake I made and why the task was not accomplished or the goal was not accomplished. Using the logged errors, the AI agent can go back and say that this is the reason why this task could not be accomplished. Let me learn that from that particular experience. And the next time onwards, when the same task or a different task is told to the agent to accomplish, it goes back and does it in a systematic manner and does accomplish that particular task. And as you see, over time, an AI agent only gets better by looking at the logged errors and by looking at LLMs and by looking at what tasks to be accomplished and by looking at the same API and the iPaaS and the RPA mechanisms to do a goal-oriented task and keep everything done autonomously and intelligently and independently. Next slide, please. So then it comes to a big question that users may ask, which is, isn't this automation? Isn't this workflow? And what is the difference between automation, workflow, and AI agent? So I present it in a very simple manner here on this slide. There is fundamental differences between simple automation, AI workflow, and AI agent. In its core working mechanisms, a simple automation is nothing but a rule-based system. And AI workflow is nothing but a workflow with LLM calls. So it's looking at an LLM, learning from it, and providing the feedback. And essentially through the feedback, it's working in a workflow mechanism to accomplish a particular task. AI agent is completely autonomous and has reasoning because it's looking at the logged errors and reasoning from that and essentially accomplishing the goal. So it's fundamentally different from both automation as well as workflow. The learning mechanism for simple automation is nothing but script-based. Learning mechanism for AI workflow is nothing but retraining of the evolved data, meaning it looks at the data output, learns from it, and then puts that into the workflow mechanism to accomplish a goal and a task. Whereas an AI real agent is nothing but it's doing everything in real time and everything autonomously. Initially, what will happen is these AI agents will use human intervention, but later on, most of these AI agents will become fully autonomous and will be working in like full real-time mode. There are certain strengths and weaknesses for each one of these methods. In automation, it's nothing but we are using a script which is very easy to build and very fast to execute. It's directed. The weakness is it becomes inflexible, meaning that it will accomplish one task, but if you think of a simple automation to accomplish like a complex task, then that simple automation does not work and it becomes inflexible because it's a complex automation then. And with an AI workflow, what happens is the strength is it's knowledge-based workflows. So it works in a workflow mechanism and it uses predefined logic flow and it tends to be very high maintenance, meaning that if certain workflow items do not work, somebody has to go back, look at it, and fix that. So the maintenance becomes high because somebody has to be constantly looking at it and making changes to the workflow. AI agent is again, as I expressed before, autonomous decision making based on rules and based on LLMs. It's high cost because the complexity of an AI agent is very high because it's actually making decisions for itself, acting as fully autonomous and with reasoning, as a result of which an AI agent working in fully autonomous mode tends to be complex to maintain. Certain examples of each one of these methods, which is simple automation, you can think of it as a process which is as a goal of like completing, and when the process actually completes, some post-scheduler tasks need to be accomplished. Meaning, let's say a process completes and in a traditional scenario, you would have to have, let's say, an email or a pager alert go out. You could use very simple automation that when the task completes, trigger an automation to send out like a page notification to someone or to a group or to an email. AI workflow, the simple example is chatbot or answer bot that is typically used today with lots of different softwares as well as web pages, which will answer questions for people if they have underlying questions about knowing about what that particular software product or that website actually does for those users. AI agent, on the other hand, as I mentioned before, is, let's say, you get a lot of email asking for like calendar entries and allotting time for meetings with certain people. Now, this can be a human task where a human looks at all those emails, scans through all those emails, and organizes their calendar by saying there's a meeting at 8 o'clock, there's a meeting at 9 o'clock, so I need to allocate some time between 8 and 8:55 and then set up another meeting between 9 and 9:55 or so. Instead of a human doing the task themselves, an AI agent could take over that particular task and set up calendar appointments to like Gmail or to Outlook or any other email program. So you could use that agent as a beneficiary for yourself, allow the agent to do the task for you so that you get freed up from the task of organizing your calendar events, and let the agent do its work. Next slide, please. Now that we have known about what an agent is and what it can do, and that it is different from simple automation, the immediate question comes to mind is, why do we need to look at agents, and what is the prospect of using these agents in real life? Many people have actually evaluated the market for AI agents, and the current outlook stands at, and I think this slide is from Forrester. This AI agent market, they have analyzed it to be about billions of dollars, 52 billion, essentially between 2024 and 2030. So the market is huge for this. And we are sitting here in 2025. You can see that the market is anywhere between 5.7 and 22 and $12 billion in all the different fields. And these fields could be marketing, customer service, research and development, and data and technology, as well as healthcare and many other verticals. And it's growing at a rate of 45% combined annual growth rate. So the growth rate is huge, market is huge, many different verticals and many different aspects of technology can be used to put AI agents to work. In marketing, a simple example could be packaged goods delivery from point A to point B. Essentially, it's think of it as a supply chain, or think of it as selling goods in the market. And essentially what happens here is, think of a company writing blog posts for selling packaged goods in the market. And those blog posts could actually be done by AI agents, just by instructing and saying, go write a blog for me. And these agents would be taking on the goal of writing blog posts for you and reducing costs by 95% and improving the speed by about 50 times, because an AI agent is doing it and a human is just evaluating that blog post and publishing those blog posts. And at some later time, the AI agent themselves actually does these tasks under the instruction of other AI agents. Customer service, we have seen lots of customer service and customer experience agents where an AI virtual agent can interact with customers. And these things are in place today. There are certain companies who are using these agents today. And a simple example is a company called as Klarna, which has been using these agents to figure out how to interface with customers in order to lead for cost reduction in those contact center or customer contact centers by about 10 times. And if such dramatic improvement can be done in those customer contact centers, it's hugely beneficial for the company and hugely beneficial for the customers as well, because they're giving that customer experience to those customers. So there was a talk earlier today in terms of job losses. I don't consider this as a job loss, but I consider this as an improvement, because an AI is so much better in providing customer experience as opposed to employing more humans, training them, and helping them provide the best customer service for other humans. And of course, it will be a matter of time before everyone gets comfortable with virtual agents, speaking to virtual agents and getting help from virtual agents. Similarly, in research and development, AI agents can help in lead generation, reducing cycle time by 25 to 35% and resulting in time efficiency. And these can be done not only in for scientific purposes, but also for healthcare needs, where agents can evaluate, let's say, X-rays and MRI data, as well as look at drafting clinical reports and drafting clinical studies, helping doctors and nurses along the way. And I would definitely not put at the current time, I would definitely not put an AI agent to take on the tasks of a nurse or a doctor, because it is so much more important to have a nurse or a doctor interpret what an AI agent is saying and deliver that information to other humans who are seeking the help from nurses and doctors. And in terms of data and technology, think of like an IT department, which is using AI agents to modernize its legacy technologies, as well as increasing productivity. And the tune for this can be immediately visible in the task that I have done in my previous role, bringing customer service data with monitoring data together and using AI ops technology to do the operational work of an operational person who is currently working in some kind of an operational role in a data center or in a IT operations center. So all of these examples, we could use agents to reduce the task of humans, difficult task of humans, And AI agent is actually assisting the human while the human is completing the task. Next slide, please. Kiran, next slide, please. Thank you. The trajectory for tasks to goals is essentially we have used AI assistance in the past, which is a task-based explicit user prompts and responses, which is directed output. And those directed outputs lead to task automation for humans. Then comes the AI agent, which is goal-based, essentially saying, go do this task, and the agent actually goes and does the task automatically or autonomously. And it is nothing but decision intelligence. And that era, we are in that era currently, which is AI ops and using the data that was collected in the past to empower the agents to do the tasks that humans were doing in the past. And then finally, we will come to an era of agentic AI, which is systems of agents. How do these systems of agents work together and complete a goal or in an organization which is very dynamic? Think of like BPOs, think of like back-end processing by complex systems and complex tasks. So AI agents would be so much more important in those scenarios to achieve nothing but ROI in all of those systems. Next slide, please. All right, so this is essentially giving you a pictorial of the agent, which is essentially what an agent is. So here in this input, for inputs, we are taking inputs from structured data and unstructured data, which is essentially think of them as data that is important for those agents to act and accomplish a task. Agents, on the other hand, are using models. These can be many different models. And by model, I mean those LLMs. And it could use either, Anthropic, it could use either Gemini or like OpenAI or something. And use those knowledge within those LLMs, which is a superior level of knowledge to accomplish a certain task. And that accomplishing of the task is nothing but outputs that come out of those agents, which are actually scanning those LLMs based on the inputs and delivering those outputs. Next slide, please. Now, this is an example. It's a blurb of what Composio, the company that I'm advising, has built, which is we look at lots of different agent frameworks, which is towards the lower left-hand corner. And these frameworks could be from like a company called as Crew AI, which has a framework for developing an agent. It could be AutoGen, it could be Julep, or it could be like Lizard. All of them are open source models. And these frameworks could be used by Composio. We have integrated with all those frameworks. And Composio by itself eases the task of looking at the different LLM models, which is OpenAI, Gemini, Anthropic, and bunch of other models to make decisions. And that's what Composio is, the lightning bolt at the middle of this slide, to figure out which API or which kind of tool to figure out and use one of these tools to take action and deliver that particular action. So essentially, it's the description of the line that has been put in the top of the slide, which is Composio is nothing but a tool designed to streamline and optimize connection and interaction between your AI agents and LLMs and different APIs and services. So that's the blurb on Composio. Now, I won't talk about Composio, but let's talk about all the different aspects and tools that can be used by AI agents to become even more so powerful. And also one of the things that I want to lay down here is it's not essential to use Composio. The individual frameworks can themselves, through like coding and through like design, use a variety of APIs, a variety of IPaaS, and a variety of RPS. In this, you are doing your tooling on your own, meaning you're writing the code on your own. Now, maintaining that code is the aspect that people have to think about, meaning Are you going to maintain the tool yourself, or are you maintain that code yourself, or are you giving it to a tool company like Composio to manage the interaction between the agent as well as LLMs and as well as APIs, RPAs, and IPAs? So you would rather use the tool than develop on your own and maintain the code on your own. Next slide, please. So by using a tool, what can you accomplish? There is hallucination. It's a well-known fact that most AI and AI agents will definitely have hallucinations, meaning that it will deliver wrong results. And it is true today, and that's the state we are in right now. And that's the reason we are saying it should be human-centered, meaning a human should be in the loop, and a human should look at the reliable connection between the interaction made by an agent and an API. Inconsistency, meaning that some of those APIs suggested and used by those agents could be incorrect and could be not the right mechanism. And a tool actually solves that because a tool recognizes that first. You will experience this if you actually are writing the entire tool integration mechanism on your own. And you would have to make sure that it is not inconsistent, it's consistent and delivering the right results. Instead of that, use a tool and make life simple for yourselves. Several other concerns that were brought in previous presentations. We suddenly heard about ethical and bias considerations. An AI or an AI agent can make unethical and take certain biases to make a decision. And we should be very, very cognizant of this. A tool is definitely helpful in this area where it can recognize those unethical considerations and biased considerations to lead the AI agent to different conclusions. So prevent from that as well as make the right decisions is something that a tool can actually help you with. And besides writing the code from scratch leads to high development and maintenance cost. I actually alluded to that in the previous slide. You can actually prevent yourself from this issue and rely on a tool which makes the right decision for you and eases the high development costs. Scalability challenges. You will see further down in the presentation how this scalability challenge can be solved by a tool. And let's go to the next slide to understand that. Okay. Next slide, please. All right. So let's talk about AI agentic tools. What do these tools do for you? Okay. So we spoke about the tools in the very first slide. Why use the tools? So in the case of AI, you are actually using the tool to simplify managing authentication and authorization. You are using the tool for managing compliance and security. You are using the tool for managing APIs, RPAs, and IPAs. We have spoken about that before. You're using the tools for triggers, webhooks, and other eventing systems that can make life very simple for you. All of these triggers, webhooks, and eventing systems are there in traditional software today, and companies are using all of these methods within traditional software to make those software even more powerful. A tool can actually do that as well, which is plug into those triggers, webhooks, and eventing systems, and make life simple for anyone to use agents in the current mechanism and the current software status quo in the industry. A tool can also be used for managing long and short-term memory. We saw that earlier, that agents do need memory, and we'll see that further in the presentation, how agents actually use both long and short-term memory. And furthermore, a tool can simplify JSON structures and also with error handling. And we saw that earlier, error handling is so much more important for AI agents. And what do all these things, what do the tools actually accomplish? The tools will reduce the code complexity, making it simple. What we have seen with Composio is you could actually write the task and the function calling mechanism for an AI agent in as little as 100 lines of code. The tools actually make it really simple for you to understand APIs and picking the right APIs. Meaning the the LLM actually goes and reads the documentation for those APIs, understands from the documentation, and says, this is the API you need to use in order to accomplish that particular task and the goal. Instead of you doing the work, the AI is doing the work for you. Simplifying the action pattern. In traditional APIs, there are many different parameters, there are many different attributes. All those attributes actually help you to accomplish the task and the goal. Do you need to use all those attributes? Probably not. So the AI makes the decision and says what attributes to use for which function call and how to use those attributes to accomplish that particular goal. Furthermore, as we have mentioned, the memory use, we'll see that in the future slides as to how that memory can be simplified for each agentic tool. And we are seeing in the pattern of making the decisions. And again, all of this summarizes down to what Steve Jobs actually said very early on, which is start with the UX. An iPhone was created with the UX, meaning a human is using the UI and can very easily figure out how to use which tool within that particular UI to accomplish a particular task. And that's what we do today. We pick one of those, tools on our smartphones and to get to whichever action, which is, do we need to go look at our bank account? Do we need to go look at a travel agent website, set up like a travel pattern and set up like a flight plan and, so on and so forth. So start with the UX and then work backwards to the technology. A tool is doing exactly the same thing, which is looking at how to accomplish the goal, working backwards and, doing all the tooling to make your agents even more so powerful. So we are doing exactly the same thing, which Steve Jobs actually told many, many years ago. And that has led us humans to use devices like smartphones and, smart technology and ease our tasks within the current enterprise. Next slide, please. So over here, I'd like to explain how this whole evolution towards tools actually started. Very simply put, we were actually looking at LLMs early on to look at two fundamental things, which is given an input as text and given an input as or a document, an LLM could be used to actually decide on what the output could be delivered for accomplishing a particular task. It's a very, very simple model, and the tool was very, very simple, where the tool would use the decisions made by the LLM to retrieve the answer and deliver it as output back to the user. Next slide. I think you skipped a slide. So, okay, that's okay. I can actually continue on. Can you go to the next slide, please? Okay, so in this one, what happens is this is a slightly more complex mechanism where the input could be both text and documents. LLM could be used and a tool could be used to deliver the right text and the right document back to the user as an output. And the database out there that's being shown is nothing but a vector database. And the vector database is telling exactly what kind of output, which is in the form of text, or what kind of output, which is in the form of documents that can be delivered back to the user. Next slide, Kiran. Kiran?
Yeah, could you please move?
I think you skipped a slide. Can you go back to slide number 13, please?
Okay, 13 slide.
Okay. So in this one, the concept of memory comes into place where the input could be your text, a document, image, or audio. you are still using the LLMs, and the LLMs in turn is using the tool is actually using the LLM and is actually storing some of the responses back into memory. It's still using the generation and retrieval mechanisms from a vector database, and then making a decision to say, what kind of output do I deliver back to the user in terms of the same media, which is text, docs, images, and audio. Next slide. You're skipping a slide. Can you go to slide 14, please?
Oh, the same slide.
It's not the same slide. It's slightly different. Yeah,
Yeah,
thank
this
you.
is perfect. Okay.
Thank you. So here you look at the expansion within the bigger box in the middle. And this is exactly what the agent state is today, where we put in inputs as text, documents, images, and audio. It goes into that agent body of work where the LLM is using a decision mechanism, saying, am I delivering the right response back to the user as output? And that entire decision mechanism is in a feedback loop. The tools are using the LLM, the memory is using the LLM, and the memory could be like of three different types. It could be short-term memory, it could be long-term memory, and it could be an episodic memory, which is what happened at a particular given time at that particular time. So in this particular case, you could be using like a vector database as before, or you could, and this is more enhanced because now you're using some kind of a semantic database where you're actually using a meaning to providing a meaning to the document, the text or the image or audio, and that particular reasoning or semantic meaning of that is getting stored in the short-term memory or a long-term memory. And that's what is delivered as output back to the user in the same media type as the input media type. Next slide, please. Now, this is where the whole agentic AI system works, which is multi-agents. You could have many, many different agents, and each fundamental agent actually follows the same process as the previous 3 or 4 different slides that I explained in the past, where it could be taking in structured and unstructured data, the same stuff, which is text, documents, images, audio, and so on and so forth. And each one of those agents could be taking those inputs. It could be working hand in hand with other agents. So you see the description of agent 1 through agent X, and each one of those agents could be using a particular LLM for itself, either a model 1, model 2, model 3, or model X, and making its own decisions. And each agent could be providing outputs, and the other agent could be taking other inputs, and they would all be working as in consolidation to provide the different goals and services back to the users. Now, if you translate this to like a business process or business process office or a BPO office in the back end of any kind of like organization, this is exactly what happens, which is somebody works on certain task, hands over the task and leaves the task for another task for some other human. And that other human takes the output task from human 1 and works on that output task, does his own thing and hands it off to somebody else. Now agents can do it for you. And that's essentially AI agentic systems. And all of these agents, agent 1, agent 2, agent 3, agent X, could be using tools in their backend to make sure that the tools is providing the backend interface for all of these agents to work hand in hand using the memory from each one of these agentic interactions, and using those memory to provide like better reasoning and better capability for making the entire system work. Are we there yet? Probably no. It will take some time, but we are actually making several steps right now to make sure that this kind of agentic system works in practice. And won't it be so much more helpful for all of us humans? Instead of doing too many tasks, we are doing directed tasks and using the AI agents for doing the tasks that we were doing for many, many years now. Next slide, please. And this slide, is just like a random slide that I put here to just show you the um, reason why all of these multi-agent, agentic systems could actually be helpful for us. No task today and no process today goes unmeasured. Similarly, AI agentic systems will be measured and will be observed, and the tools in the backend will actually help you and will actually provide you the measurement capability and the observability, which could be broadcasted up to your SaaS systems or to your monitoring systems or to your dashboards or to like a knock center or something saying, agent has done this, this is what the measurement has been done and delivered to you, so that you can monitor these agents and say that, are my agents actually working? Are my agents not working? Are they delivering the right responses? Are they not delivering the right responses? Are they doing the right reasoning? They're not doing the right reasoning. And you could actually empower the humans to say that, uh, should the agent be stopped? Should a human take over? And if the AI agentic workflow is actually working fine, what kind of ROI is it delivering for you? So some of these I'll just read out and explain like what these different tools and measurement capabilities actually provide. Latency per tool call. I mean, when an agent is actually calling like a tool, let's say an API, an iPaaS, or an RPA, does it take long time or does it take a short time? How much latency is there? It's very, very important, because if you are delayed in calling that particular API or delayed in getting a response back from the API, agent is probably not that useful for you. You could do it faster yourself as a human. So this parameter should be measured and this KPI should be provided to any kind of dashboard or any kind of like knock center that you are looking at. Similarly, the other thing that you could look at is LLM call error rate. This is actually evaluating the frequency of failures in model responses to address the issues like limits or misaligned prompts. If an LLM is not delivering the right result for you in order to accomplish a certain task, that should be actually measured to say that, is the LLM the right LLM that you are using, or should you use like a different LLM for accomplishing the same task? API call frequency. API calling frequency, meaning that how often do you call that API in order to accomplish a certain task? Cost per task. If it is getting costlier for you to accomplish a particular task, then you probably don't need an agent. Why do we need an agent when it's more costlier than a human? And that's a very fundamental criteria, because if the human is doing the task much faster than an agent, you certainly do not need an agent for doing the same task that a human is doing. Couple of other parameters that we would probably like monitor and look at is again mentioned in this particular slide, which is tool selection accuracy. I also mentioned in the previous slides that AI agent is actually figuring out which tool to use. Now, if the agent picks a wrong tool, then certainly you don't want to use that agent because it's picking a wrong tool all the time. I mean, if you're striking two stones to create a fire, and now your agent is actually saying, I'm going to use two pieces of wood to strike a fire or create fire. Suddenly, striking two pieces of wood is probably not the right tool to create fire. Using two pieces of stone is probably the right method to use for creating fire. Steps per task. So if the agent is taking lots of time to accomplish the task, certainly the agent is figuring out by itself that breaking down the tasks to the very minute tasks that it needs to use to accomplish that particular task. And certainly that agent, even though it's doing it methodically, is probably not the right agent for you to put into production or put into real life for accomplishing that particular task. So don't use that particular agent. Agent wait time. If the agent picks up and decides, after a long time that this is the agent that needs to be put into practice, certainly you have not done the right goal. So all of these different parameters should be kept in mind. There are many other parameters, KPIs, that you probably need to use. And certainly an observability system actually makes much better sense because it provides all the integral data and the internal data to help you decide which agent to use in practice. So I leave you all with this particular notion that agents, yes, we are living in an agentic world today. 2025 is the agentic year. All of these KPIs are very useful. So make a decision for using the right tool for the agents to make sure that you are using the right tool and empowering the agents to make the right decisions for yourself. I end this at this particular slide. If you have any questions and answers, feel free to email, and I'll be happy to answer your questions by email. Thanks a lot, and a pleasure to present this for HK conferences. Thank you, Kiran. Thank you all.
Yeah, thanks a lot for a great presentation, Mr. Balaji. Yeah, our next speaker is Dr. Uma Mahesh. Dr. Uma Mahesh is an associate professor at Acme College of Engineering, India. He has served as an assistant professor, guest lecturer, and lecturer for 8.5 years. He pursued his research in Vellore Institute of Technology, Chennai, and also qualified UGC and NET exam in December 2019. He obtained his master's degree in VLSI design and embedded systems in 2012 and bachelor's degree BE in electronics and communication engineering from Visvesvaraya Technological University, Karnataka, India in 2009. His current research interests are in the areas of digital holography, artificial intelligence, and machine learning. Please join me in welcoming our keynote speaker, Dr. Uma Mahesh. Yeah, Dr. Uma, we are not audible. Hello. Dr. Uma, please unmute your mic.
Hello.
Yeah, it's audible now.
Okay, thank you, sir. Thank you. Sorry for inconvenience. As sir told myself, Dr. Uma Mahesh Aryan, I am working as a faculty in Mysore in ATME College of Engineering, Karnataka. So my talk is about the topic called Deep Convolutional Neural Network for Three-Dimensional Application using Face-Only Digital Holographic Information. I'll tell how to construct the 3D object and how the hologram is recorded and how the face information is reconstructed. Then I will talk about the deep learning architecture, results and discussions, and then conclusion and references. So first of all, what is digital holography? So when I consider a three-dimensional object, I will be having both amplitude and phase information. When I capture the image of a three-dimensional object, I will be getting only the amplitude information. The phase information will be lost. So in order to obtain both phase information as well as intensity information, we will go for a digital holography technique. So what we will do in digital holography is on the three-dimensional object information, we will superimpose a plane reference wave and we will combine both object wave and reference wave in order to obtain a fringe pattern which contains both amplitude and phase information. So O is the amplitude of the object wave, phi is the phase of the object wave, R is the amplitude of the reference wave, delta is the phase angle of the reference wave. So in this manner, in holography, we can obtain both amplitude as well as phase information. This amplitude and phase information will be recorded in the form of interference fringe pattern, which will be recorded by the digital devices like CCD and CMOS sensors. That's why it is called as digital holography. So next thing is in digital holography, we will be using object wave as well as reference wave. We will combine both object wave as well as reference wave in order to generate the fringe pattern. That interference fringe pattern is called as hologram. So after recording the hologram, we will be using numerical reconstruction algorithm in order to obtain phase and amplitude information of the object wave. So here I have represented the holographic principle. We will be using coherent light source, that is a laser light source with a constant wavelength and constant phase difference of 0 degree. This laser light beam will be passed through the beam splitter, where some part of the light beam will be passed through the object and remaining part of the light beam will be passed through the another portion of the setup. So this is the experimental setup. Here the laser light source will be passed through the beam splitter. The object wave will be created through the object. The laser light beam will be passed through the object and it will create an object wave. And the remaining light beam will be passed through another mirror and it will create a reference wave. Both object wave and reference wave gets interfered in order to form interference fringe pattern. That interference fringe pattern is called as hologram. That hologram will be recorded by either digital devices, CCD and CMOS sensors, or either photographic plates. So here we will be using digital device in order to form the hologram. So O of x comma y represents the equation for the object wave. R of x comma y represents the equation for the reference wave. I of x comma y represents the intensity of the recorded hologram, which contains reference wave, object wave, and twin image wave. Twin image wave means it contains real image as well as virtual image. So the first term represents the amplitude of the reference wave. Second term represents the amplitude of the object wave. Third term represents only the object wave. Fourth term represents the conjugate of the object wave. So this is how we will form the hologram. This hologram will be formed and then it will be passed through the numerical reconstruction process, numerical reconstruction algorithm in order to generate the phase information. Next, we will be using deep learning in order to perform classification and other kinds of applications in deep learning. So next, I will be using three-dimensional object in order to form the data set. I have considered 4 three-dimensional objects in this particular experiment: triangle, square. I'll be using square in the front plane and a triangle in the back plane. The front plane and back plane is separated by a depth called d. So first, I will capture the information from the front plane. Then I will capture the information from the back plane. I will combine both front plane as well as back plane information at the charge coupled device in order to form object wave. Then I will be using reference wave, where the reference wave will be having at different phase angles. At 0 degree, I will be using one reference wave. At 90 degree, I will be using another reference wave. So at different phase angles, I will be using different plane reference waves, and I will be combining with object waves in order to form the fringe pattern. After recording the fringe pattern, I will be reconstructing it in order to obtain the phase information. I have constructed 4 three-dimensional objects like this: triangle, square, I have considered in one set; circle, square, circle I have considered in the front plane, square in the second plane, square in the first plane, triangle in the second plane, triangle in the first plane, circle in the second plane. Then I have formed the data set for 2880 images, where I have considered 75% for training, 15% for validation, 10% for testing. Training images and validation images. So here you can see the reconstructed phase image of one of the 3D objects, that is circle, square, that I have obtained using phase shifting digital holography technique. Next, I have used convolutional neural network architecture in order to perform the binary classification. So after reconstructing the phase image from the hologram, the reconstructed phase image will be of size 512 into 512. This 512 into 512 image will be passed through the first convolutional layer, where I have considered 8 kernels in the first convolutional layer, 16 kernels in the second convolutional layer, 32 kernels in the third convolutional layer, 64 kernels in the fourth convolutional layer. So this convolutional neural network contains 4 stages of convolutional layers and 4 stages of pooling layers. The output of the final pooling layer will be given to the classification layer to produce the final output. So this is the working of the convolutional neural network. Next, I have performed 2-dimensional convolution operation in the convolutional layer. If I consider 6x6 input and a 3x3 kernel, the 3x3 input will be multiplied with 3x3 kernel to obtain a single pixel in the output feature map. This convolutional output will be passed through the nonlinear activation function in the convolutional layer, where I have used rectified linear unit activation function. This rectified linear unit activation function will consider the values for the right side of the x-axis and discard the values for the left side of the x-axis. So after performing convolution operation in the convolutional layer, that convolutional layer output will be passed through the pooling layer. So pooling is also one of the dimensionality reduction techniques. I have performed max pooling technique in the convolutional neural network. So if I consider 4x4 input, max pooling 2D means in the two-dimensional matrix, it will consider the maximum pixel among the existing pixels. So for example, in 2x2 matrix, 1, 2, 2, 3, 3 will be considered because it is the maximum pixel. 3, 4, 4, 5, 5 will be considered. 3, 4, 4, 5, 5 will be considered. 5, 6, 6, 7, 7 will be considered. So this is the model summary of the CNN, which is have used for the binary classification. 512 into 512 into 8, I have used 8 kernels in the first convolutional layer, 16 kernels in the second convolutional layer. I have taken 5x5 kernel size, 32 kernels in the third convolutional layer, 64 kernels in the fourth convolutional layer, and I have performed dimensionality reduction for 4 stages. 4 times I have done convolution, 4 times I have done pooling. 50% of the feature map will be reduced. So how I will get the output? If you see the convolution operation, 6x6 input is reduced to 4x4. So similarly, 512 into 512 is reduced to 508 into 508 because I have taken kernel sizes 5x5. So n minus k plus 1. N is 512, k is 5, and plus 1 is bias. Similarly, this 508 will be reduced to 254. 254 will be reduced to 250 because I have used 5x5 kernel and 50% of the dimensionality reduction will take place. So like this, I will perform convolution and pooling operation for 4 stages. Finally, in the last pooling stage, I have considered 28 into 28 into 64. I have multiplied it and I have generated 50,176 neurons. Among 50,176 neurons, I have considered 64 neurons. Among 64 neurons, I have considered single neuron in the output layer to produce the output. Now I have shown the calculation for the number of parameters in the convolutional layer. In the first convolutional layer, I have taken 5x5 kernel, that is 25, and 8 is the number of kernel, 3 is the image size, 512 into 512 into 3. It is a 3-dimensional image, 3-channel image, plus 8. 25 into 8 into 3 plus 8 will give you the number of parameters. In the next convolutional layer, I have taken 16 kernels and 8 kernels in the previous convolutional layer. 16 into 8, 5x5 is the size of the kernel, plus 16 is the number of bias values. So after training this convolutional neural network on the face-only image dataset, I have generated the loss and accuracy plots. You can see the training loss and validation loss is decreasing, and the margin between training accuracy and validation accuracy is less. So the neural network is correctly converging and it is fitting well. Next, I have calculated the confusion matrix on the face-only image dataset, where 18 images are predicted as true negative, 2 images as true positive, 1 image as false negative, 0 image as false positive. I have calculated the evaluation matrix for the set 1 and set 2. 1 represents the set 1, not 1 represents set 2. I have calculated precision recall and F1 score by using the equations true positive plus true negative divided by true positive plus true negative plus false positive plus false negative for accuracy. For precision, true positive divided by true positive plus false positive. For recall, true positive divided by true positive plus false negative. Next, I have calculated the macro average by taking the average of precision and recall for both set 1 and set 2 classes. F1 score is calculated by taking the harmonic mean of precision and recall. Next, I have generated receiver operating characteristic and precision recall characteristic to indicate the performance of the binary classification task, where you can see the area under curve value is 100%, which means it is having very good performance on the true class or the set 1 compared to set 2. So in this manner, I can conclude that I can use deep learning neural networks to perform 3-dimensional object classification to obtain the results. These are the references. And if you have any questions, you can ask me. Hello.
Yeah, Dr. I think there is no questions, I think so. Are there any questions? Yeah, thank you very much for a great presentation, Dr. Uma.
Thank you, sir. Thank you for providing the opportunity.
Yeah. Our next speaker is Mr. Olivol Fagbohan. Mr. Olivol Fagbohan is the founder of Readerly, an artificial intelligence-driven platform for enhancing literacy in young readers. He has authored the TensorFlow Developer Certificate Guide, published by Packet Publishers, and is presently crafting his upcoming book, AI in Action, for Manning Publishers. Olivol has delivered keynote addresses at prominent academic symposiums in the UK and internationally, discussing the impact of AI on education and innovation. With over 7 years of experience in AI development and educational technology, Olivol is a Google certified TensorFlow developer and machine learning researcher with peer reviewed publications. His expertise lies in creating comprehensive AI solutions that boost learning outcomes. As an industry visionary, Olivol is devoted to employing state of the art AI to address literacy challenges and equip educators and parents with tools to deliver tailored, captivating learning experiences for children. Please join me in welcoming our keynote speaker, Mr. Oliver Fagbohan.
Yeah, thank you very much, and a good morning to everyone, and afternoon, depending on where you're listening from. Just one sec, let me share screen. Okay, Kiran, let me know if you can see my screen.
Yes, we can see your screen.
Okay, great. All right. Let me just move this away. Thank you, everyone. Today, I will be speaking on hidden persuasions, analyzing bias in international negotiation text with AI. My name is Oluwale Fagun. I'm the founder of Readly, and you're welcome again to the third webinar on AI and data science. And in this discourse, we will look at the introduction. We will talk about understanding bias in AI, bias in international negotiation texts. We would also look at the role of AI in analyzing negotiation text. We also then go further to look at a case study where AI is applied to diplomatic negotiations. We'll talk about the challenges and ethical considerations, future direction, and we'll close with a conclusion and a Q&A where you can ask me questions based on our discourse. Now, AI, as we know it, is being increasingly used in processing textual data, and diplomatic data, diplomatic negotiations are no different. We would look at understanding bias in these negotiations, which are crucial to ensure fairness in international negotiations and agreements. So our objective is to look at how AI-driven tools, especially large language models now, can detect and analyze bias in negotiation text. And we'll look at the ethical implications, regulatory landscape of bias in AI, particularly in terms of international policy making. A useful reference is to look at is, I think I've attached some references that would help if you want to further drill down into these discussions. So let's go further. Now, in terms of bias in AI bias refers to a systematic error that can result in unfair or prejudiced outcome, often reflecting societal inequalities. When we look at AI, bias can emanate from three different ways. One, data. Two, algorithm. Three, human. When it happens because of the data, it means because maybe perhaps we're training with a data that is not representative. So it's skewed towards a particular maybe country, organization, ethnic group, or race. When it comes to algorithmic bias, if we design models that are primed towards I think they're primed towards promoting or favoring one side, or especially when we talk about negotiation text, maybe favoring powerful nations due to reference to past treaties over developing countries. That can be a problem in itself. Then human bias can be introduced by either developers or everyday users, where we kind of where implicit cultural assumptions are embedded in AI-powered diplomatic tools. So if we use if we're humans interpret text, our bias can be emanating from where we come from, or based on also maybe perhaps our religious beliefs or traditional opinions, as it may be. Now, cognitive bias in negotiations. Some of the biases which have been found in international negotiation text have to do with things like, for example, framing effects. The way information is presented to you can impact on how you would perceive the information presented. cultural biases can also play a key role because there are differences in language and communication styles, which can also lead to misunderstanding. Then power asymmetry. Larger countries are more assertive in their discussions in these kind of international negotiations compared to smaller or developing countries who do not have the same kind of strength. Now, the impact of these biases is that it can distort perception. It can lead to unequal treaties or unfair trade deals. An example is when we use which we look at when we look at the case study is AI analysis of past negotiations has shown that developing countries concerns being downplayed. Their concerns are being downplayed in things like climate agreement. Like if you were familiar with maybe perhaps not COP28, where loss and damage was being discussed, and developing countries did not actually get the benefits of which they asked for because of the damages done by climate change to developing countries based on the actions of countries who were emitting more carbon. Now, the role of AI in analyzing negotiation text. AI has been able to, because of we have now more powerful models like LLMs, they're able to objectively extract insights from things like linguistic framing, hidden power dynamics, and rhetoric strategies which are used in negotiation text. NLP, when you use NLP techniques, you are able to apply methods like sentiment analysis, topic modeling, bias detection. Sentiment analysis can help you identify the tone, emotion, and bias in diplomatic discourse. Topic modeling can help you to aggregate group discussion themes, which we would see in the case study and how it would impact on the discourse and be able to help us to understand and extract bias that exists in this text. Then bias detection helps you to be able to find patterns in linguistic favoritism or hidden agendas which are being expressed in negotiation text or statements. Some of the key techniques that are being used now, transformer-based models can be applied, and aspect-based sentiments can help identify persuasive intent in speeches. A very good paper I also have attached here is Saville et al., which talks about conversational persuasiveness of large language models. It's a good paper to look at for further reading. Now, let's look at this. The case study we are looking at is going to talk about more of AI in diplomatic negotiations, and it will look at how we can use NLP techniques to be able to track persuasion techniques, and reveal hidden biases in international discourse. Now, diplomatic negotiations are quite different from everyday conversations because they do have inherent complex, and they also involve strategic linguistic framing. There is also the use of implicit persuasion tactics and power asymmetry between negotiating parties. Again, you would find that there is the application of subtle rhetoric techniques which could influence the outcome of these discussions. In this case study, we look at some of the historical diplomatic texts that were being analyzed, which includes the United Nations Resolution, World Trade Organization's trade negotiations, bilateral and multilateral treaties, climate agreements, peace negotiations, and conflict resolution documents. Now, AI-powered persuasion tracking can help with many things, which include one of them is framing effects. And framing effects is the way which an issue is being presented to shape your perception. So let's look at an example. When you look at negative framing, you would see, for example, a text could read like something like this. Developing countries are refusing to comply with fair trade regulations. Now, this statement is framed in a negative way, which portrays developing countries as obstructive in nature. On the flip side, we can also frame this statement to sound like this, where you say developing countries need more time to adapt to global trade standards. In this particular scenario, we are framing it in a positive way where it presents developing countries as countries that are in need of support. So negotiators can use either of these framing techniques depending on their power play and the strengths and what they try, their overall strategy that they want to use to achieve their goal in diplomatic negotiations. Next, there is the use of power language where you can either be assertive or they can either use hedging or assertive statements. Now, powerful nations usually would come from a point of using assertive language to impose their position, while weaker nations would prefer to use hedging statements to maintain a bit of flexibility. Hedging statements could look like something like this, where all nations must eliminate subsidies by 2026 to ensure fair competition. Now, this includes a strict deadline, and these are the kind of statements you would expect from major power players in trade negotiations. While on the flip side, developing countries could use statements like countries should gradually phase out subsidies where possible. This introduces some form of ambiguity, so that would also delay compliance. And this can also apply to things like climate conferences, where oil-producing countries would probably use more hedging statements, and those against oil-producing countries would use more assertive statements to be able to buttress their points and push their agenda forward. Another another use case you can find is strategic emotional appeal. And these references are made to historical injustice, moral arguments, ethical responsibilities. You would find negotiators use statements like this. For example, they may want to make a humanitarian appeal, where you can use statements like millions of displaced families need shelter. We cannot turn our backs on them in their time of greatest need. Now, the impact of this is basically to push forward an emotional argument that will most likely increase the increase public and political support for accepting refugees. Another tact that you can find when you use AI-powered persuasion tracking is repetition and reinforcement. Now, repeating a message increases the likelihood of acceptance and influence. So you would find in trade negotiation deals, which take place over a period of days, where a reinforcement strategy can look like this, where you can say maybe on day one, you would find that there's a free trade, statements like free trade leads to prosperity. Day three can have statements like history shows that free trade strengthens economies. And on day five, all studies confirm that free trade is the key to economic growth. So when we use techniques like topic modeling, we can extract these recurring patterns that can show that repetition and reinforcement would make it more acceptable to other negotiators, and that can cement the narrative to their counterparts' minds. Agenda setting and omission bias. So this is another technique that is being used by negotiators, so where negotiators can control an agenda by highlighting or ignoring issues. You would find, for example, in the EU migration talks, what was highlighted was we need to strengthen border security to ensure stability. And what was ignored was the root cause of migration, such as economic disparity and climate change. Now, the impact of this is negotiators are able to push forward the agenda while skipping or omitting other issues that they do not want to bring to the fore. So this is some of the issues that can be identified by when you use AI-powered negotiation tracking. Now, some of the key findings that was discovered in when we track negotiations in international, when we track linguistic hidden influences and linguistic shifts in negotiation text, is you would find that AI models are able to reveal several key insights which you would find in this text. And let's look at some of them right now. Power asymmetry and power dynamics and asymmetry, strategic positioning for demand, and language of cooperation and control. So the tone, you would find that AI is able to detect linguistic tone. So it can identify when a developed country is speaking versus when a developing country is speaking, because of the use of either assertive or non-assertive tones. So this is one of the ways that you can find, you can also, AI can detect the speaker or in a particular negotiation text. Now, strategic positioning, where negotiators are able to, because these negotiations, they're kind of very dynamic. So you may want to soften your position just so that you can appeal to others, where you can change, maybe perhaps instead of using compliance, you can change it to where you can make it an offer such that it can be appealing to the general public. Again, you can also look at things like language of cooperation rather than versus control. So major power players would look at international policies in ways that suggest that it's of mutual benefit to everyone. But what they skip to talk about is the fact that these policies are in favor of their own particular interest. An example will be when you look at things like climate negotiations. Countries with high emissions would like to push the agenda that technology sharing agreements rather than talk about carbon reduction commitments. Again, you can detect strategic linguistic shifts used to manipulate the discourse. So when you can soften resistance through technology change, sometimes when you look at these long-term or climate discussions, or even negotiation discussions across different diplomatic discourse, you will find that they might use rigid terminologies are replaced with a more subtle language, so that, for example, you could replace sanctions that often can be rebranded as economic adjustment mechanism, so that it will sound less punitive and more acceptable to their colleagues and the wider public. Then another tact that is found is gradual normalization of policy position. So when, for example, if a controversial policy is introduced in the early stage of negotiations, The fact that it's continuously repeated over time makes it more palatable, and when you combine that with softened resistance through the change of technologies, and that would actually make it more acceptable because of the fact that it's continuously being reinforced and is being reframed in a way that is more acceptable to their colleagues and the general public as well. Now, again, another part, something we could also look at is how these technologies are being portrayed. So if to both internal and external bodies, when they have internal discussions between stakeholders, it can be framed as negotiations where there's a back and forth, and both sides will have to make concessions. When it's being presented to external audiences, for example, the general public, it can be framed as economic partnership. So this would help to increase public acceptance of these policy changes, and it would reduce and also reduce adversary to these changes. One real-world example that was examined was the application of AI in AI models to analyze the EU's trade agreement, and you would find that it was predominantly you will find key terms predominant in these policy, in this trade agreements. Terms like partnership, cooperation, mutual benefits were used increasingly, and you would find that it toned down the use of things like trade concessions and tariffs. So these linguistic shifts helps government to justify their policy change to the public while minimizing resistance from the general public. Now, how can AI help negotiators to counter biased arguments? So the three key ways it can do that, which we've identified, is enhancing transparency, enabling real-time argument analysis, and helping weaker negotiators to recognize power plays. By transparency, you can use AI to highlight strategic language used to help negotiators identify hidden biases in arguments. So a country might claim a deal is fair, but when we use AI to analyze the deal, you can see that there's an uneven burden sharing by both parties in that particular agreement. Real-time argument analysis, you can use AI during live negotiations to evaluate the persuasiveness and the framing of statements. You can use AI to get instant feedback on whether a phrase is loaded with implicit bias or manipulative language, or even, you're leaving out some key information just to be able to promote a particular agenda or purpose. And it can also help smaller nations with fewer resources. We can use AI to be able to support their decision-making process. That can help them to counterbalance more powerful negotiators. So in this case study, we've looked at how AI can help to be able to uncover hidden persuasion tactics in international negotiations. It can help us to track and quantify these techniques like linguistic framing, bias in text, and strategic persuasions, which negotiators use to get a critical advantage, in ensuring a more fairer and more balanced agreement. So AI's role in diplomacy, it can be used to uncover hidden power asymmetries in negotiation. You could use it to track strategic language shifts that manipulate the discourse, quantify subtle persuasion tactics for improved transparency, and empower negotiators to counter biased arguments effectively. Now, Matz et al. Is a fantastic paper to be able to drill down further into this discourse and get more insights into the discussion we're having now. So some of the challenges and ethical consideration is, because of the nature of this discussion, sensitive negotiation data raises concerns of confidentiality. Again, algorithmic transparency is important. We need to understand how AI comes to a conclusion that maybe a text is biased or not. So explainability would help stakeholders to understand how AI thinks and presents its information forward to everyone. Some of the mitigation strategies we could consider is bias audits. There's a need for regular model evaluations to be able to ensure fairness, and also inclusive data practices, ensuring that our data that we are training our models with are diverse and balanced, so that can also promote fairness in terms of mitigation strategies as well. For future directions, I believe that developing more AI models that can interpret contextual and cultural nuance and also capture cultural nuances would really help to be able to improve how we are able to interpret international agreements. Policy implications, if we establish international AI governance framework to ensure fairer negotiation processes, this would also help both developed and developing countries to be able to pinpoint issues in international negotiation texts. So our key takeaways is that AI is able to reveal hidden biases in negotiation text, and this can lead to fairer diplomatic engagements, Ethical and legal AI governance frameworks are important to ensure the responsible use of AI. So my call to action today is basically that collaborators, there should be an increased collaboration between AI researchers, policymakers, diplomats to create an equitable AI-driven negotiation tool that would help to improve fairer and more balanced negotiations in international agreements. Thank you for listening to me. And if you have any questions, please feel free to ask me. Thank you for your time. Yes, please.
All right, thank you so much. In fact, I have my pen and paper and I've learned a whole lot and jotted down some things. So, and I want to believe that this is a recent development, and I love your call to action on this. It's just that sometimes some of the projects I work on, I don't have power over continuity. And I remember working on something like this in 2020, but just to ask if there's anything that has been done in this. So one of the on international negotiation, one of the challenges or one of the things we spotted out is on power dynamics mixed reading.
Yeah.
Because in international negotiation, who speaks first, pauses, or remains silent can indicate power positioning. So this particular project, we are working on a transcript, or we're trying to transcribe meetings, and it was between a Chinese delegate and an American delegate. And Chinese delegate, they'll deliberately remain silent after a proposal, and that is a common negotiation tactic to create pressure. Now, the AI text analysis that we built rather captures this as a behavioral reading and fails to recognize that silence as a strategic move and reports no major objection, which was one of our failures in that model. So now what I'm trying to ask is, based on the recent issue, can AI now accurately dictate and interpret cultural nuances, power dynamics, or unspoken strategies in international negotiation? Or will it always be limited by its training data and biases? Do we have anything else on that?
Yeah, I think that's a good question. And I'm happy that you're coming from a place of you've actually carried out some research on this as well. Now, if you look at the current models that are being made, and I think they're constantly being improved. So say, for example, your data will play a key role in all this, because if your data does not capture the way, for example, I'll use an example, the Chinese delegate, how the implication of their silence, because if it's not able to understand that when an argument is presented forward, again, I think I covered that as well, where you find out that some of the insights which are being presented are being skipped intentionally because they do not want to touch on those insights. They do not want to discuss that. So that in itself, if you use a model that is being trained to capture that cultural nuance, that to show that the Chinese delegation, they do not speak about these issues because they do not want to talk about it, and to continuously hold on to the power dynamics rather than to just, because if they present their opinion about it, that might lead to a broader or a further discussions and will not lead to an end to that agreement. So what they would do is basically skip that. So the models that are being used currently, if you use a model that is generally trained on maybe data that is developed in the West, it may not capture effectively how the reactions of the Chinese delegation. So you must use a more balanced model with diverse data set trained to imply that when the delegate from the Chinese government refuses to speak, it means that they want to withhold their own approach and ensure that you do not get the insights or the kind of answers that you require. So it's an approach and it's a tack that actually is being picked up, because silence does not necessarily mean acceptance. And LLMs now are able to pick that if you really train them correctly. I hope that helps in some way.
So do you have any GitHub account you can reference for me to try to look at that, where they've built in cultural nuances, or how to build
what we do, I think what we did is we applied unfortunately we've not published that the model is not open source. It's mixture of experts, so we basically use multiple models from trained on different data. So in terms of analyzing negotiations, so that what we've done is we use for developing countries like maybe the African continent and Nigeria and South Africa, use low resource models which have captured like the cultural essence and essence of the people. Then for developed countries, you use more open source, out of the box, open AI, GPT-4 and Cloud Sonnet. There's also a couple of models from the Asian continent that captures the Chinese and the Japanese way of presenting information. So when you combine all these experts, they are able to capture these different cultural nuances. Can it be better? Absolutely, yes. And I'm sure that I'm not right now, not aware if anyone has open source something like that, but I think we will do that where once we finish publishing our paper and presenting our insights, we definitely open source the model so people can see how they're able to interact with this text and how they're able to extract these various insights across various international discourse.
I mean, to be honest, if you have a waiting list, I don't mind being on the waiting list to read the paper and also to explore the model because I'm curious about how subtle and non-verbal negotiation tactics are captured in the model. Since you cited Chinese, for example, that you have that model, most of it we work with Chinese negotiations on a higher tactical level.
Yeah, we use it for the recent COP29. We collected about 30,000 data decision documents from COP29, and we've used that to be able to analyze that. So that was like the basis upon which this talk was developed, So, and that led to, okay, let's look at other international negotiation agreements and peace treaties, So yes, I would definitely keep you in the know as soon as we publish it and have the model available as well.
Okay, that's fine. I'll reach out to you again.
All right.
On that. Thank you.
Thank you very much. Any other questions? Okay, if there are no questions, you can connect with me using my LinkedIn and let's stay in touch. Thank you everyone for listening to me and yeah, that's it for me.
Thanks for your great presentation, Oliver. Yeah. Our next speaker is Mr. Samuel Akirili. Mr. Samuel is a seasoned cybersecurity professional and system administrator with over 10 years of experience in information technology and education. He brings a unique blend of technical expertise and instructional skill to every project. Throughout his career, he has collaborated with diverse teams of IT professionals, driving innovation in learning environments through cutting-edge technologies and data-centric solutions. As a dedicated member of the Microsoft Community Contributor Program and Black Cisco Academy, he is committed to continuous professional development and sharing knowledge within the tech community. His experience spans system administration, network management, troubleshooting, and delivering technical training, making him an adaptable and resourceful IT professional. Please join me in welcoming our speaker, Samuel Akirili.
Hello, everyone.
Yeah, hi.
Hello. Good afternoon, good morning, wherever you're hearing from. It's nice to be here once again. My name is Sakarili Samuel, and today I'll be speaking on modern. I hope you can hear me, please.
Yes, we can hear you.
Okay, please. I'll be speaking on modern deep learning approach for malware detection and classification. Before we go ahead, I would like us to look at the overview of what I have for us today, which is the background. We'll be covering the motivation and the background, overview of malware detection techniques, deep learning architecture, and data representation. Also, key academic contribution and current trend, case study, experimental result, and challenges, and limitation. All right. In this talk, we're going to explore modern deep learning approach for malware detection and classification, and also emphasizing on the method that can integrate both automated features, learning, and domain-specific insight. Okay, so we're also going to cover recent innovation in transfer learning and assembly modeling that feature enhanced detection accuracy while reducing the reliance on extensive man feature engineering. Okay, excuse me. Okay, the overview, motivation and background. All right, the current threat landscape. So malware is becoming increasingly sophisticated and prevalent, but with zero attack posing a significant threat, And there's also need for advanced techniques, which is the traditional method. Now the traditional method struggles to keep pace with evolving threat, requiring scalable and automated solutions. So why deep learning? Deep learning excel at learning complex patterns from raw data. Raw data offering a powerful approach to malware detection. Now, the overview of malware detection approach. Now, this is very critical in the aspect of cybersecurity. Now, we have the traditional approach and machine learning approach and the deep learning approach. For the traditional approach, signature-based and heuristic method rely on known data, known pattern rather, and rules, often lagging behind new threat. Signature-based detection. This approach depends on a database of unknown malware signature. That is, when a piece of software matches a signature in the database, it flags it as malicious. All right, the machine learning approach also, machine learning techniques require manual feature engineering, limiting the adaptability to a malware variant. Now, in this case, there's a support vector machine, which is a powerful and versatile machine learning algorithm, which is sometimes used for classification and regression tasks. Here, we also have the random forest. Is a kind of machine that is a kind of machine learning algorithm that is known for its robustness and accuracy. The deep learning, unlike the traditional approach, unlike the traditional machine model, deep learning learn representation directly from raw data. This approach has been highly effective in malware detection due to the ability to handle vast amount of data. My next slide. Now, the deep learning architecture for malware detection. Here we have the convolutional neural network. I call it the CNN, the recurrent neural network, and the graph neural network. The CNN processes malware binaries as images, capturing scatter pattern and effective detection. The CNN convert binary to grayscale images to capture spatial pattern for effective detection. In this case, it optimized CNN. The accuracy of optimized CNN is actually 99%. Now, under the current neural network also, these are type of artificial neural network. They are designed to undo sequential data. And the key feature in this network are memory, sequential processing. We have memory, we have shared memory, and also we have the autoencoder. The autoencoder are used for supervised learning. I believe my other colleagues spoke about the supervised learning. And in this case, there are two major components of this autoencoder. We have the encoder and the decoder. The work of the encoder is to compress input data into a lower dimensional representation, while the decoder restructure the original input from compressed representation. The graphic neural network models relationship between system cores or file structure element, providing a comprehensive view of malware activity. Now, the graph actually calls for a file structure. It calls for a file structure element, providing a comprehensive view of more activities there. All right, my next slide, which is data representation in malware detection. Now, here we have the binary to image conversion. How we can convert binary to image. We have the sequential representation and the dynamic behavior data. For binary to image conversion, the malware binaries are converted into images, thereby allowing the CNN to analyze their visual pattern. Malware binaries are converted into images, allowing the CNN to analyze the visual pattern. Now, most times, the binary images are converted into transforming of binary data into a visual image format. For example, the PNG, the JPG, and the BMP. This process is often used in data visualization. Now, for the sequential representation, the API calls sequential and opcode logs are used as input for RNN and the LSTMB, capturing temporal dependency. It is a concept widely used in mathematics, computer science, and also most times in data analysis and other fields. Now, this particularly is used for modeling other data like the serial, text, and DNA sequences. The dynamic data behavior collect sandbox on runtime analysis environment and provide insight into malware behavior. My next slide, which is, so I have some key academic papers and contributions. You may want to take a look at these key papers probably after the event. I can just, you can connect with me through my LinkedIn and other social media handle, so I can email this. So we have the academic paper and contributions so far. Now, looking at the current trend and innovation, there's a transfer learning and also ensemble method. We have the explainable AI, right? Now, the transfer learning predefined model, the leverage for malware detection, reducing data requirement and training time. Now, in this case, model developed for one task is actually reused as a strong point for a model on a second task. Now, this approach is particularly useful when the second has limited data, and in doing so, it allows model to leverage knowledge knowledge that is learned from the first, which is data rich. And the assemble method, this method, multiple deep learning method models are combined to improve robustness and reduce bias. Now, the idea is that by aggregating the prediction of several models, the ensemble achieve better accuracy than robustness than any other single model alone. All right, explainable AI, which is XIAA. The XAI frameworks are being integrated to make deep learning models more transparent and understandable. It is actually a system where it's a system that provides human understandable for that provides human understandable for their decision, or it could be prediction or behavior. And the essence of this XAI is to make AI model more transparent and interpretable, especially in the critical applications like the cybersecurity, healthcare system, and finance. Now that takes us to the case study and other experimental results. Now, leveraging LSTM and GNA for modeling detection, and the goal of this study is to was to develop a hybrid deep learning model that combines LSTM for sequences learning and GNA for synthetic data generation. We also have the train model on visual train the model on the visual shared dataset, which contains over 1 million unique malware sample. And also, the aim of this is also to compare the proposed method, which is traditional machine learning, and standalone deep model. There's also the methodology used in this case. The methodology follows a multiple-step pipeline. We have the data preparation, data model training and evaluation, LSTM model for data detection, and also the GNA for synthetic data augmentation. For the data preparation, the data set is to prepare is pre-processed rather using tokenization and feature extraction. And in this case, API call sequence from executable files are used as input feature. Now, for data representation, all right, now getting your data ready is a cornerstone for any data-driven task. Now, here is a quick run for how the data preparation is processed. We have the data collection process, the data cleaning, data transformation, data integration, and data reduction, also data splitting. For data collection, in this case, information, it gathers all the data you need from various sources, such as a database, your web scraping, API, and even manual entries. Data cleaning involves the removal of correcting and any error in the data. This can also include dealing with missing values, outlier, and inconsistency. And I also mentioned the data transformation. The data transformation converts the data into a suitable format or structure for analysis. This involves normalization, scaling, or encoding. Yeah, for the train model and evaluation, the model are trained using Adam optimizer, which cross entropy loss function, and evaluation metrics include accuracy, precision, recall, and FAI call. Right? For training and evaluation model are actually very key steps in machine learning, and they actually have a higher level overview. The train model, it chooses for the training for model training, it chooses the model it chooses a model depending on the problem, right? Depending on the problem, probably regression, classification, and clustering. You need to select a suitable machine learning algorithm. It also trains test split. It divides the database, the data set into training and testing set. And commonly about 70 to 80% for training and about 20 to 30 for testing. For the model evaluation, for the evaluation aspect of it, it validates set. If you have a large enough data set, it further split the training data into training and validation set to tune your model. I also have the LSTM model for malware detection. In this case, LSTM network process sequential API call data to learn temporary dependency. And most time, this model captures patterns in how malware behaves over time. The GN synthetic data augmentation. A GN is trained to generate realistic synthetic malware samples, and also the generated samples are added to the training set. Now, there's some key findings that can justify this. Actually, model accuracy precision API call. We have the standalone, and we have the GNA generated sample improved robustness, and also the real world impact. For the real world impact, it improves security. That is the real world impact of these findings. It actually improves security, and this approach provides a scalable and an adaptive malware. Actually, the detect system. It can also be impactful in the aspect of adversarial defense. In this aspect, the model is more robust to evolve malware techniques and also enterprise application. It can also be deployed in the real-time data threat detection system like Google Play Store. So this is kind of useful. Now, furthermore, there are some challenges and limitations of this study. Actually, we have the adversary attack and computational resources. Adversary attack, computational resources, and also we have model interpretation, right? Model interpretability, we have the data limitation, and also response strategy. Now, for the adversary attack, the DL model can be vulnerable to careful crafted adversary examples. Take, for example, adversary attack. These attackers measure their concerns in the field of AI, particularly in the application where security and reliability are crucial, such as autonomous driving, facial recognition, malware detection, and some attacks in the adversary aspect are evasion attacks. We have the poisoning attack and also Trojan or modern extraction. Right? The computational resources, high training and interference costs, particularly for deep network. Also, we have the model interpretability. Black box nature makes it harder to explain decisions to cybersecurity practitioners, and also data limitation. You have the data limitation, and also which is a scarcity of labeled data and the need for standard benchmark. Now, response to strategies. Response to strategies, incorporation of explainable AI and model fusion, actually. Future direction of this study, we have in example of real-time and on-device detection. So developing model can separate in the resources constrained environment, e.g. your mobile phones. In the case of cross-platform detection too, it extends solution to cover Windows, Linux, Android, and most operating system, and also the imagine of Internet of Things devices. Now, it improves explainability. All right. So integration XAI framework for greater transparency and trust is automated decision, and also in the aspect of robustness to adversary attack. Now, research into defense mechanism and reliance model architecture, also standardization and benchmarking. This is establishing model data set and evaluation protocol for fair comparison techniques. Now, my takeaway for this is this. In summary, rather, deep learning has revolutionized malware detection, and by automating feature extraction and handling complex data representation. And my key message for this study is transfer learning and adversary defense, explainable AI holds significant promise for future advancement. Now, my final thought is that we need to continue to do research, collaborate between academia and industry are crucial. It's important we continue research. We need to keep doing our research. Don't stop researching because there's a long way to go about this. Also, collaboration between academia and industry are crucial to address the evolving trend landscape. All right. Thank you everyone for listening to this short brief. I'll be ready to take any question. You can connect with me on my social media handle, McKinsey, and also my LinkedIn. Thank you. Over to you, Sonny, please.
Yeah, thank you so much for a great presentation, Mr. Samuel. Yeah, Mr. Samuel, there is a question for you from Sebastian.
Well, thank you so much, Mr. Samuel, for this insight. I mean, you are totally spot on that we need to research and keep researching. But I was just looking at the methodology or the result of the experiments. I'm not really sure I understood the accuracy model there. If you can share your screen, for me to make a decision if LSTM standalone seems to be the best, or the GANs, the assembly model of the GANs plus the LSTM that you use. I'm not sure I got that. I'm not sure I understood that accuracy results that was on the screen. And again, for LSTM model, was it just the API call sequence that gave that?
Yeah, he lost his connection. Just now he sent me, just now he pinged me in WhatsApp. He will join in 1 minute, 1 or 2 minutes, okay?
Okay.
Yeah, he has lost his connection. He told me to connect him in LinkedIn. Hello.
Okay, no problem. I'll reach out to him on LinkedIn. Thanks.
Thank you. Yeah, now we will be having a break for 30 minutes, okay? We will join after 30 minutes. Yes, we are back. Yeah. Our next
Yeah,
speaker
yeah.
is Professor Hind Lamharhar. Professor Hind Lamharhar is a professor of artificial intelligence, specializing in knowledge-based systems, machine learning, deep learning, natural language processing, and large language models. With over 2 decades of experience spanning higher education industry, she has developed robust theoretical and practical expertise. She has co-advised doctoral students and taught diverse profiles, including masters and engineering graduates, at renowned institutes such as INSEE, Institute of Statistics and Applied Economics, High-Tech School of Engineering and Management, Muhammadiyah School of Engineering and Muhammad V University. Her teaching combines traditional, online, and hybrid methods, often with custom designed course materials. As a senior data and NLP engineering at Morocco Ministry of Economy and Finance, Hind drives AI initiatives in fraud detection, business intelligence, data analytics, and MLOps. She develops and deploys advanced ML, DL, NLP, and LLM models to enhance fraud detection in customs declarations. Hind plays a pivotal role in the decision support system team, contributing to projects in risk management, selectivity, foreign trade, and custom economic regimes. She oversees the full data pipeline from extraction and pre-processing to model development, deployment, and production monitoring, delivering actionable insights for decision making. Her unique blend of academic and industry expertise enhances her teaching and research, equipping students with hands-on AI and ML or LLM OPS skills. Recognized for her innovative contributions, Hind's work has been featured in publications, conferences, and applied AI projects, establishing her as a leader in AI education and implementation. Please join me in welcoming our speaker, Professor Hind Lamharhar.
Thank you too much for this presentation. I will share my screen. So can you see my screen?
As we can see.
Okay. So as I already presented by Kiran, thank you, Kiran, for this invitation to this prestigious conference. And I will expose today. It's not about a presentation, theoretical or practical sometimes, but it's about the sharing my experience and my journey of working on AI application from my PhD until now. So today I have a lot to discuss about AI, but today I will focus on how we can enterprise AI and apply this enterprise AI in governments or any enterprise. I will take just custom administration as a pilot and the approach that I will share with you, I prefer to share with you and have some feedback from you. It's for the objective is for balancing between privacy, budget, or optimization. So it's pleasure to share my journey and experience how I work with AI. I started working with AI during my PhD in 2010. At that time, I focused on creating ontologies to build a knowledge base for governments, what we call cognitive AI. The idea was to make data more expressive, which would improve decision making. In 2012, I worked with agents that could orchestrate various tasks. I combined agents with a knowledge-based system, and that was my approach to AI. While this idea was new and innovative, it was difficult to industrialize. People didn't understand it, and implementing a knowledge management systems require a lot of resources, experts, and time. This made it challenging to continue my work in that direction. In 2016, I tried something similar, but focused on Arabic language, which was an even bigger challenge. I had many questions at that time, like, what value does this bring? And why would anyone use it? I didn't have answers to these questions and focused mainly on the technology. I thought my technical expertise is the most important to develop an efficient AI applications. Starting from 2018, I shifted to working on more practical projects to answer this question, applying machine learning and deep learning to customs fraud detection. And I already presented in the first webinar in the same conference. I focused on the technology and the best practice, but in 2024, I realized that integrating AI into existing systems required more than just technology. The key questions were, why should we use AI? What will we gain? How does AI fit into existing systems? These were questions from others, not just myself. To motivate the adoption of AI application, I had to answer these questions. So, how to align artificial intelligence with enterprise architecture. Integrating AI into an existing system was not just about building a perfect model with a high accuracy. It's about understanding how to make AI work within the larger system. It's about seeing the bigger picture, how AI fits into the existing system and how it can be integrated in a way that benefits the organization. AI transform all enterprises. I have developed a set of applications, but I ended by various AI application. When I come to integrate it in the existing system, I found a lot of problems of the operational silos. Because I'm from the software engineering, I see that I have to follow a methodology. I have to know some frameworks to apply it for developing and integrating and deploy any AI application efficiently in an existing system. So the scope of our application was a pilot administration, that is customs administration. From the perspective of government, this administration is very important. Why? Because this pilot, it's an exemplifies the challenges and opportunities of AI integration. It operates at the intersection of government and enterprises policies, making it a rich environment for this project. Custom legacy system presents both challenges and opportunities. Our goal is to bridge the gap using AI while preserving core functionality. So, enterprise architecture ensures that the understanding of the existing system gives us a vision for how to align AI with an enterprise architecture and integrate AI system smoothly in this existing system. So to do that, I remember I was working in software engineering as architect before, and I remember a framework that I use frequently to identify I'm working on what. This framework called Zachman framework. It's enabled to answer a lot of questions about the implementation of any new system. It's enabled to structure this project, and it is the cornerstone that we can use in any development of application independently of its AI system or another system. So this approach breaks down enterprise architecture into 6 perspectives. This method allows us to address every facet of AI integration, from business strategy to technology deployment. For example, in fraud detection, the what perspective helped us to identify the data required to build a robust model. The how perspective clarified the processes and workflows, while the who perspective defined the rules and the responsibility of agents involved. By mapping out this layer, I was able to see how fraud detection integrates into the existing system and identify the gaps or inefficiencies. The Zachman framework also guided us in replacing a control-based system for fraud detection by an ML or machine learning AI-based system. For instance, in custom administration, the technology perspective enables us to design a new system that integrates seamlessly with existing workflows. This approach ensures that the new system not only meets current needs, but it's also scalable for future requirements. So how we apply this framework, or how this framework guides us to analyze the existing enterprise architecture. As you know, any enterprise architecture composed of 4 layers. For example, in the business layer using this framework of Zachman align AI initiative with strategic objective. Key use cases in custom include fraud detection, for example, automated risk assessments, and compliance and monitoring. We can identify all the process, and we can see which process is concerned by AI application. The application layer, it's enabled to focus on how AI interacts with existing system. It's enabled to include and integrate any AI models through API, for example. Data layers is the heart of AI. We must establish governance policies to protect privacy while ensuring data quality and accessibility for AI training and inference. The last layer, technology layer, addresses infrastructure needs, balancing cloud scalability with on-premise solutions for sensitive data, for example. So, applying enterprise architecture with analysis using this framework. So fraud detections enable us to understand the existing system, how it operates. The second layer enable us to understand how transaction is classified, for example, in form of a set of rules that represent patterns for machine learning models. Data layer enable us to see what data to collect, what privacy issues we have pay attention to them. And technology perspective enable us what technology will be compatible with the existing technology used for the existing approaches. I have a second example is about, for example, developing agents RAG system based on large language models. Also, enterprise architecture analysis enable us to identify where we can add some AI, generative AI-based application, and how to integrate them, or the enterprise architecture has some application in this direction. If not, we have to develop something from scratch, adapt the enterprise architecture, and then develop our, for example, agents. So here, the Zachman framework helped us to understand the task stakeholders, workflow involved. For example, I analyze how external users, stakeholders, like those outside of the organization, will use the system. This allowed us to identify key requirements, such as where to integrate the new system and how to ensure supports decision making. From technology perspective, the framework enables us in this use case to design the system as an API to integrate seamlessly with any part of the system, existing system. This API can be used for business, for example, BI intelligence, to analyze and to make some decision, to detect fraud, and so on, with the respect of regulations and so on. But this to successful this implementation of this technology, we have to define the scope. As you know, in this framework here, we have something perspective called scope. So we have to make some scope for this to define the good scope, or what I call awareness, context awareness, or to define what kind of data around this context. It's about the data quality. So we have used domain-driven design to improve the data quality, to prepare data, to be sensitive to the domains, and to be a context awareness. So domain-driven design, it enables us to prepare high-quality data set for fraud detection, for example, and the risk assessment by focusing on the core domain and its subdomains. Domain-driven design helped us to structure and organize data in a way to align with real-world process. For example, in machine learning system, it enables us to collect very good data. So we don't have a lot of tasks of cleaning. It helps us to, for example, prepare some patterns and make this pattern, the detection patterns by these models of machine learning very easy, and it helps us. And another aspect is about the AI explainability, because the process of, for example, fraud detection is not just about the scoring and, for example, select the first one or the 10 one. It's about to explain why it's a fraud, based on regulation that or litigious regulation that govern this process. We can't say, for example, this is a fraud and that's all. We have to explain it. To explain it, we have to use data from regulations to know why this system detect that is fraudulent, from transparency, and for example, have a good decision making. So we arrive to the steps of how we can implement this approach. How can this approach direct us or oriented us toward implemented or good AI systems. So combining AI, enterprise architecture analysis using Zachman grid and domain-driven design, it enables us to identify steps to make the development of AI systems efficient for an existing system. The first step is about analyze the existing system. We start by analyzing the current system using AI analysis and the Zachman as explained before. This helps us understand the organization, structures, processes, and data flow. It also identifies gaps and inefficiencies of the AI can address. As explained before in the second, I think, presentation, sometimes why we need to develop agents if human can, for example, achieve this task more efficiently than agents. We don't need AI. If, for example, we have privacy problems, we have to see if AI it's important in this case. We have to explain, we have to motivate this system. And the second step is define AI rule and use case. For knowing which use case needs an AI application, we have to decompose the system. To decompose the system on subdomains. Here we use domain-driven design to identify any use cases in the existing system and to identify what data around the use case. The third step is applying domain-driven design for context awareness. It's important here. For example, in case of customs administration, we have a lot of domains. We have domain about declaration clearance. We have domain about risk management. We have domains about legislation and so on. So each one has a context different from the other one. So how we can limit this context and be awareness to this context. So, for example, for machine learning, for fraud detection, use, for example, the domain of litige or regulations. So here we have to integrate the both machine learning and an agent that can express what the litigious or regulations behind these fraudulent cases. The first step is about the defining the data with a good quality for AI models. Of course, we have a lot of privacy issues here. We have to care about them. And this fifth steps is about implementations of AI architecture. And here come, when we develop an AI, it will be standalone, it will be an API, or a new system that will be integrated after in a process among this process of enterprise. We have to reflect how to integrate efficiently in this application. And sixth step is about monitoring and improve AI models. So here we establish monitoring mechanism to track AI performance and continuously refine models based on new data and business needs. And the previous presentation is talk about a lot of metrics that I found very, very interesting to work with them to monitor any AI application after deployment. So what are the challenges has been addressed by this approach? The most critical challenge we faced was about data privacy and security. I'm so sorry, it's data privacy and security, especially given the strict legal constraints governments must adhere to. For example, for data collection, transaction data is encrypted using TLS, for example, and collected from trusted sources. Data processing, personal identifier are pseudonymous, and access is restricted to authorized fraud analysis. Data storage, for example, here we have to encrypted database and compliance. The system adhere with internal and external laws for example, to audit and ensure compliance with the existing laws. That's from the perspective of security and privacy. For example, for interoperability, so in the part of interoperability, we also address through scalable infrastructure. So here we have a scalable infrastructure and technology compatibility, ensuring the new system works seamlessly with existing system. For data management, for example, handling the vast amount of data required, it enables because we know which data we will integrate in such application, X application, Y application, and so Y applications. From the perspective of resource leveraging, we know by the question of who integrates in, the people integrate in such, for example, process, we know we have to make some skills gaps or talent acquisition or collaboration with external providers and so on. The budget issues. So in the budget issues here, what we have the problem, for example, here of finding some balancing. And here, for example, in development of fraud detection application, we face significant challenges. Collecting and processing large amounts of data requires substantial storage. So we have here to choose to do on-premise solution or cloud solution. However, governments often resist cloud solution due to privacy concern, pushing us toward on-premise infrastructure, which comes with a high upfront costs and ongoing expensive. Additionally, building and optimizing AI models demand high-skilled experts, which further increase costs, while partner, for example, with external providers can offer ready-made solution. It raises concern about data privacy and control. To balance this factor, we use a cost, what we call, for example, a cost-benefit analysis. This helps us decide between options, weighting the trade-offs between costs, privacy, and performance. For instance, we evaluate whether to invest in on-premise infrastructure or partner with trusted provider, ensuring compliance with privacy laws while optimizing the budget, for example, and so on. And this is just the first version of our guide toward developing a comprehensive AI enterprise guide, but is not yet finished. So just I want to share that we start with identify strategic alignment. Start by identify the goals and value added to the existing system. What problem are we solving? For example, in fraud detection, the goal may be to reduce false positive while maintaining high accuracy. Decompose complexity, break down complex processes into smaller manageable subdomains or sub-processes. For instance, in custom administration, we can separate clearance, declaration, risk assessment, and compliance checks into distinct workflow. Define use cases, clearly outline the use case for the enterprise. For example, in fraud detections, we have the use case may include real-time transaction, monitoring, anomaly detection, and case prioritization for investigator, for example. We have 3 processes here integrated in this machine learning, for example, application. Conducts assessment and feasibility study. Analyze the existing system, data availability, and compatibility with current technology. Ensure the solution complies with international and internal laws. Select the appropriate model. For example, for machine learning, we have used a lot of models, but not any models can work efficiently. Ensure the model aligns with the data. We will feed it. Quality, quantity, and the relevant integration and deployment. Plan how to new system will integrate with or replace. For example, we will replace an existing system, or we will integrate a new API into the system. It be standalone application also, or will it communicate with legacy system via APIs? For example, in fraud detection, system may replace an outdated rule-based system. So, continuous development and deployment. Here, implement a robust process for continuous improvement. This is from the Agile application from software engineering. And in our case, we have, according to this approach, so I will, to be honest with you, in our first work, we started just without this approach, just from the technical stuff of AI. We want to discover what AI can bring to this, to our work. So I start working in the first work about building a knowledge base using, for example, large language model with a lot of models, trying them for a lot of use cases. I ended by a Cyrus application that I can integrate them. And we work also in fraud detection project using a lot of models. And the both works, I already presented them in the same conference, in this conference, the first webinar and the second webinar. So, but the problem here was really related in the last step, how I can integrate the both projects. And they were very big projects, ended by a project based on agents. So here I decide to define a framework and to develop any application based on AI. And when I make this framework, I make some test bed or in the pilot application, fraud detections and RAG-based system and the RAG-based system. So in this use case, for example, for fraud detection, we addressed the challenge of detecting fraud in legacy custom system with structured trade data using machine learning, and we built an anomaly detection system that identify unusual patterns in this transaction, track behaviors, and assign a risk score. The system integrates seamlessly into the existing custom workflow in real-time API. But the real power lies in adaptability. The system continues to, for example, to evolve, and new fraud pattern can be detected. The second use case, it was the first use. The second and the first use case in this the second pilot was about custom question and answer about products classification. So here we develop a chatbot that can be used in any parts of the existing system. So that was our bot approach, where we have applied the approach of aligning this AI application with the existing systems. So here my conclusion, so integrating AI or developing AI for an existing system is not very easy. We have to have an overview of the big picture existing system, and then to identify the scope of, or identify the context in which we want to develop a specific or application. Then we have to think how, for example, to make some balance about using, for example, models, because models require a lot of resources. If we want to use a very optimization, for example, or very efficient models, we have to pay more. If, for example, the use case need, for example, for fraud detection, it needs some investment, it needs some budget. But for a RAG system, we don't need, for example, a big budget. We can find some balance between, for example, on premise or on cloud. We can decide is the data it's private, so where we can't make something, because government in general doesn't trust cloud solutions. So here we can develop on premise. We can optimize the resources what we will use, and then I hope this approach and this framework can help any enterprise to study and to analyze before the existing system, and to see how to integrate AI in them to find some balancing between budget and optimization, and also for privacy. Thank you for your attention, and I wish I present, because it was because my presentation was before, so I don't.
Yeah. Are there any questions? Thank you very much for a great presentation, Professor Hind.
Thank you, Kiran. Thank you. If you have any question, you can send me email or send me in my LinkedIn.
Yeah, I will send you a mail and your LinkedIn profile, okay, for them.
Thank
Okay,
you.
if they have any
Thank you,
questions.
Kiran.
Our next speaker is Mr. Eric Thompson. Mr. Eric has dedicated his career to addressing some of AI's toughest paradigm level problems in multidimensionality, ontology, adaptive AI, and logic. He is a world authority in multidimensional information systems, an internationally recognized expert in the application of logic to information systems, and a well-known paradigm-level innovator in neurosymbolic AI and in ontologically grounded approaches to world modeling. He recently designed a neurosymbolic controller to improve the performance of ML applications, selected as an exemplar of advanced AI algorithms by the DoD's Joint Center for AI, and has won over $5 in government grants for the use of ontological grammars to solve through AI problems. Please join me in welcoming our keynote speaker, Mr. Eric Thompson.
Thank you, Kiran.
Hi, Doctor. How are you?
Yeah, so good.
Yeah.
Good. Roads are sheer ice over here in Cambridge, Mass. We had snow, the usual snow, some rain, and now a hard freeze. So it's just like an ice skating rink. Am I sharing slides? How
Yeah, you
does
can
it
share
wish
your
to work?
slide. Okay.
Yeah, okay.
If you face any difficulties, I will share on behalf of you. Okay.
Yeah, no worries. I can do that. So just this takes a second though. Okay.
Yeah, no problem.
All right, so I'm just going to slideshow mode. All right. Do you see the title slide?
Yes, we can see.
Perfect. So, all right. If anyone still goes to the bank, to take out cash, how many people double check that the machine gave you however much you take out, 10, 20s, or whatever currency you're using, whether euros or dollars or bonds or whatnot, right? Who with the cash register, when we go to the store and there's a total, and you actually still pay the cash, which is not that common anymore, double checks that the computing system on the other side gave you the right change. Who checks things like weights and measurements? We just trust that machines can do a good job of certain things. But are we there when it comes to more sophisticated, what we like to think of as AI, which isn't really a new planet, it's just an extension of things that we've been doing for a long time? And I think the short answer is no. Would you trust your life or a friend's life with a judgment call made by an AI? No. And yet at the same time, we are looking to these systems to do more and more critical tasks with less and less human supervision. So this talk is all about not just trust, but warranted trust, which is to say trust that's been deserved. And I'll explain that term in a little bit in AI-driven systems. So I'm going to spend a few minutes going through some key concepts, by way of introduction, not some generic, the importance of AI, but just a few illustrations of the kinds of things we kind of count on or depend on, because that goes part and parcel with the more we depend on stuff, the more we really ought to trust it. And so what are some examples of where we clearly can't trust? Everyone's heard of hallucinations, but there's all kinds of, examples of AI output that, leaves you scratching your head asking, no human would have made that kind of mistake. So what's going on? And then I'm going to introduce something called neurosymbolic computing and a particular variant I call multi-channel neurosymbolic computing as an approach to resolving what are some of these fundamental issues around trust, and then kind of wrap it up and hopefully have a good little discussion going at the end. So no further ado. All right, so I'm just getting some basic concepts down, right? Information, right? We all talk about data, we talk about knowledge, we talk about facts. It doesn't really matter. We've got declarative and or procedural expressions capable of truth testing. Now, declarative ones, it's easy enough to say, right? Can we truth test the temperature? Can we truth test, a long lag coordination? Can we truth test a multiplicative, product? For procedural expression, we're really testing is that the procedure, when properly executed, achieved the claimed result, right? So if someone tells me to close the door and I leave the door open, I did not truthfully execute that command. Something happened. So we can have that notion of testing applied to either declarative or procedural expression, which is important because a lot of what we're looking at in the AI space are procedures. Did it do the right thing? Computational reasoning, calculating deduced and or inferred, quote unquote, output information given a collection of quote unquote input information. For example, we may sum a whole bunch of inputs, right? We may take the least squares, of a whole bunch of XY coordinates. We may look for the centroid of a whole bunch of XY coordinates. We may look for the most invariant relation, right? That links a whole bunch of XY pairs together, right? Which is the essence of what we're doing when we're using machine learning to come up with functions, which we then use to do something. So in that sense, machine learning is really a kind of computational reasoning that computes invariance from information, i.e. from training, that can be used to infer other information, which is what happens in deployment. So we take a bunch of paired images and names, a bunch could be 100, a bunch could be 100 million, right? And now we're going to go off and we're going to give it a new image and we're going to figure out what the name was, right? We have a whole bunch of numeric data, we find a central tendency. We've trained on word sequences and parts of speech. We're now, of course, with with transformers and all their fancy architectures, we can go from word sequences to word sequences. But at the end of the day, you need a trained algorithm. This whole just mind-bogglingly explosive world of Gen AI is still coming out of the same paradigm as the AI/ML of the last 15 to 20 years. It's way more powerful. It's way more parallelized. It's taking advantage of GPUs in a way that was not possible 20 years ago, but it's the same trained algorithm. We're just kind of doing it in reverse. The IML says, hey, give me a new X. We've calculated the F, and now I'm going to tell you what the Y is, or I'm going to tell you that name. And with a Gen AI, what you're really saying is, spit me out an X, right, a new X, that given my Fs would have been given this Y. So for all of the impressiveness, we're still in this world of statistical classification. What about AI, right? AI is really capabilities built with ML and information. And information is important because an ML algorithm, right? Take your favorite, MassCore, CNN, or whatever, absent information is pretty inert. Not much going on, right? It's the combination of massive amounts of training data with these algorithms to provide a highly trained algorithms that's actually useful for doing things, whether it's facial recognition, forecasting, intruder detection, or now in this world of the Gen AI, code translation, parsing, program writing, paragraph writing. I've actually been playing around in, some of these new LLMs, they're pretty much like solid college undergrad, which is pretty impressive, if you think about it. So what about trust? Well, trust is really the willingness to act on that output without further verification. If you need to further verify it, you don't trust it. So that all that is going back decades, trust but verify, that doesn't really make sense. That's like saying, go left but go right. No, trust is not verified. Otherwise, and there's all kinds of cases where we need trust, right? You walk into an elevator, you trust that it's going to work. You walk into a skyscraper, you trust it's not going to collapse. You're driving your car, you trust the brakes are going to work. If we were constantly testing all of these bits of machinery, we would never do anything. So, in fact, we think people are mentally unstable if they don't trust everything. So trust is part and parcel with just being human and acting in this fairly complex world. So you can't punt on trust. And what about warranted trust in an AI system? Well, that's trust in the information output based on knowledge of how that output was produced and the attributes of the output itself. That's kind of like statistical process control, So if you go back to the aftermath of World War II and the rise of folks like Deming and Juran, who were looking at manufacturing processes at the industrial scale, they figured out that it's not that efficient to just keep testing the output to kind of do random product sampling, but to actually test the process. And if you have confidence in the process, then that confidence extends to the output. So we basically, to warrant a trust in the AI system, is we know how it works, right? We know the mechanisms. We trust that that's going to produce an output that warrants our trust. All right. Importance of AI, right? Let's take a look at success in visual recognition, right? We have an image on the left, and we're running MassCore CNN, it's been identified to be trained to identify people, running on a security camera, identifying pixels tagged as people, showing true positive. Classic, center of the bullseye, that really seems to work. Right? Go and you say, hey, let me find boys, and amazing job pulling up boys, find toothbrushes. This stuff works. At least it seems to work. Right? So we build all kinds of applications, right? We could build an intruder application. So the little POR is an ontology term, means portion of reality. So a little chunk of reality, there's a person. And our sensors are picking up, certain pixels that are being classified as person, I'm not, do you see my cursor? All right. So being classified as person, and in this very simple world, we're in a space where there's not supposed to be any people. It's after hours. There's just no one's supposed to be there. So all people are classified as intruders. So the person is recognized, classified as intruder. That sends a signal to security. Security comes and checks it out. Very simple intruder detection application based on image recognition. All right. Without trust. Well, we got that boy and we got toothbrush. When you query for boy with toothbrush, you can get really different results. Things that no one who understands what boy is or who understands what toothbrush is would ever put these images as boy with toothbrush. So someone could come back and say, well, obviously the algorithm wasn't trained to recognize boy with toothbrush images. But that's the issue. That compositionality that humans automatically have isn't something innate. I'm not saying there aren't algorithms now that haven't been trained that way, but it doesn't come innate. Someone's got to come in ex post facto and say, that's important. Let's not miss that. Let's go add that to the training. Let's make sure that works. But it doesn't natively think that way. It looked at pixels. This is a very real example. I live in Cambridge, Massachusetts, but I go to a little home up in the mountains to get away, and pretty much reliably every weekend. And so I go to the local, gasoline station, buy some gas, head up, and about every 6 months, that gasoline purchase is called a fraud. The credit card is stopped. I'm dealing with the credit card agency. I'm like, guys, is anybody looking at my past history? Is anybody reconciling this one estimate that this could be a fraudulent transaction with 5 years of historical records? No human in their right mind would classify that response as likely fraud. It's at the same gas station for about the same amount on the same frequency. It's crazy, but this happens. This kind of thing happens all the time. Buying plane tickets, right? Buy a plane ticket to whatever, to let's just say to Athens, and buy a plane ticket from Athens to Hania on Crete, and then a hotel in Crete. That's suddenly now considered to be fraudulent, but it just accepted all the transactions before. It doesn't make any sense. It's statistics. It's not how we think. So am I going to trust that output blindly? I don't think so. Let's go back to the mask RCNN. So now we have a cell phone on a blanket. 94% confidence, mask RCNN, trained on a very large volume of data, thought the blanket is a person. That's not a little mistake. No human would ever make that mistake. So how can you trust a machine running at scale when these kinds of mistakes can happen? And I'm sure most of you, have heard, if not seen, there's all kinds of stuff going on. You can take it, if someone can reverse engineer the training data that went into a visual classifier, you can sprinkle noise into data such that a human wouldn't notice the difference and a machine is no longer capable of recognizing what's going on. So that's a problem. That's not particularly robust. So where's this coming from? Like, what's the cause? So let's just start off with how does ML look at a person? What's a person to ML? It's a set of pixels similar to training data with the same tag. Right? So these are all just images here of, things that have been tagged as people. Okay. Is that how we think? No. For humans, right? Human view of a person is a large two-legged mammal with a rich set of attributes, right? So anything that is true of mammals or living things is going to be true of people. If it's a person, it's got to have a head if it's alive. certainly typically has, appendages and torsos, and there's some, statistical there. Someone could lose a hand or a foot. I mean, yes, there are differences, but on the whole, people have got body parts. People do things, parenting or purchasing or working, breathing, and so forth. And we have relations with other objects. We live or exist inside a building. We wear clothes. We drive cars. We use products. We are bigger than a toaster oven, and so forth. All of that is taken into account somehow by people when we're looking at something and saying, is that a person? So for people, first thing is that data, whether it's visual data or audio data, or olfactory data, or sometimes tactile data, but least of all that, is about the world, right? That image I'm looking at, even with my eyes, forget it on a picture, is about the world. That's what we have. That's what we talk about mirages, right? Or things that fool the eye. In French, it's trompe l'œil. It's just there's all kinds of expressions for that. And AI data is the world. That chunk of data is what's being analyzed. It is not fundamentally a proxy for the world. It is the world. That is a huge difference. Confidence in the statistical sense is confidence that the pattern currently being classified is similar to a similar pattern seen in training data. But even if it's visual, man, the world's a lot more complicated than that. So that's a big difference. Second, humans, we extract meaningful features with every sense, right? This world of deep learning it's a mixed bag. For all of the incredibly powerful ability to squeeze associations out of the data, there's also the risk of extracting meaningless features, spurious features that only make sense in that particular data set. Old-fashioned statisticians had a good word for it. It's called overfitting. Now, the response these days is more like, well, as long as we can have every possible observation in the universe, we're never going to get beyond our data. The data will be everything. But that's, of course, never really the case. We're getting closer, but that'll never be the case. So you're always going to have that word, that there were 43 gray pixels in the top left part of the image every time a speeding car was seen in all of my training images. And the machine learned that. It doesn't know what a meaningless feature is. It's just a feature. Third, humans cross-check multiple senses for consistent outputs. We cross-check what our eyes are showing us, with what our ears are hearing, with our nose smells, with what I know from my life's prior experience, from what my buddy told me, from what I read last night in a book. We cross-check multiple senses, what I call channels. There's no real cross-checking. I mean, there can be in an ad hoc way, within the bowels of an algorithm. Of course there is. But there's no principled cross-checking. And there's no principled cross-checking across the features that are within different ML models performed by an external entity. And finally, humans are actually really good at comparing, analyzing, communicating preliminary findings. So you can have people collaborate to solve a problem. That's harder. If you had 4 independently trained ML models, there's no collaboration except in the output. All right. So what about multi-channel neurosymbolic AI? Where's that taking us? Well, again, humans are multi-channel sense makers. So what would that mean for ML? Well, it might mean that you may have differently trained versions of an algorithm combined with different algorithms. So, let's say 2 differently trained versions of mask-RCNN. You could have now OpenPose, which is another algorithm that looks for joints in the human body. You can compare that with your company's own analytics store. You can compare that with what employees think. There's no limit to that. The question is, you want to reconcile different channels. Any channel that has a kind of an independent view of what could be true should be brought to bear. So channel logic really is the expression that there are many channels that produce representations of this world. There are sensory channels, motor channels, knowledge channels, give them different names. And the ML output from any one channel needs to reconcile with the data or ML output from all relevant channels. So if channel 1 says, that looks like a person, and channel 2 says, that is on top of a toaster oven, there needs to be a conclusion that says that is likely a figurine of a person and not an actual person. So there's, certainly this is, you can see all kinds of stuff coming out of, DARPA. There's, a lot of places where this kind of thinking is happening. But if we just kind of look at it in the larger framework, from this, from the 1700s through to today, it's statistics. That's really what's going on, right? And for the last 60 years now, it's hard to imagine it's been that long. We have a whole bunch of other stuff, kind of MIS, EIS, management information systems, executive information systems, decision support systems, business intelligence, analytics, all meaning the same thing, right? Just different words for the same thing. Enterprise analytics architectures. We've got rule-based expert systems, which still live, right? And then we had MDDBs, and data mining became AIML and Gen AI. And now, of course, we got these LLMs, which are really just an extension of Gen AI, which is still an extension of the ML, which is an extension of statistical classifiers. And in the world of, big waves of AI, this is still Gen 2. It's still statistics. It's still probabilistic. We're moving on to Gen 3. And so there's a lot of work going on in this area. I put in the word adaptive, but neurosymbolic computing architectures more generally, whether it's just for representation, reasoning, or the whole AGI, whatever you want to call it. But now you're combining kind of the certainty, the exactitude of symbolic reasoning with the probabilistic aspects of kind of the bottom-up statistical classifier. So you're really going bottom up and top down. And if you think about it, just like an analogy, like when the corporate budgeting is really a reconciliation process where everyone at the bottom says how much they want for next year. And then corporate says how much we got. And they push back and say, you can't have that much. And then say, well, if I can't have that much, then I'm going to only do this. And it's a bottom up, top down, multi-step or multi-cycle reconciliation process. So it feels good. There's a lot of research going on in this space, so there are many, many articles, but we're already now at the survey world. If you take a look at these ones to the right? Neurosymbolic AI's taxonomy, a survey towards data knowledge of an AI survey. So there's enough neurosymbolic stuff out there that there's already surveys on it. So it's worth being, aware of these various trends. I think that solutions to trust are really coming out of here. And that world, I've done stuff with my little company. We have a new company now called SensePoint. Blender isn't really operating anymore, but we've been in this space for a while and focusing really on trust. So, for example, if you cross-check MassGar CNN, which had found a person, and we cross-check that with OpenPose, which is looking for people parts, then we say, we don't think that's a person because we didn't find anything that looks like a person in that. Very basic. Or you can now say the MassGar CNN plus OpenPose using spatial fusion running on a security camera is fooled into thinking that a TV image is a person. Why? Because it sees the outline of a person. That's the masked part of the MassGar CNN. All the little dots are OpenPose finding particular joints between the parts of a body, so and features, so eyes and ears and elbows and wrists and so forth. So all of this, we go, wow, I've got the shape of a person. I got all these people parts. Surely I'm dealing with a person. Not quite. Right? So if you are also looking and you see a household appliance like a TV, and you see that this image seems to be inside of the TV, then you can make perhaps the more educated conclusion that that's probably a TV image of a person. I think if you were to, you can see a core score, person not real. So core score was something we gave to our cross-checked output. So we can now take this these days. We're doing a lot of stuff with autonomous systems. You can do that for just all kinds of industrial purposes and other purposes for doing it. So autonomous systems to date, seems very super advanced, but it's not quite as advanced as you might think. So motion control, we've got a great job of, right? So self-driving cars, right, or self-driving boats or self-driving planes, we're much, much closer to autonomous device control, obstacle avoidance. So give me an address, give me a viable roadmap, give me the rules of the road, and now we have a car that can, on average, get us from point A to point B. That's great. So now that you can move, you can also ask the question, what about if I want to learn something? So the question isn't, can you get me to address X? It's, where should I go and why? And so we're in the world of embodied knowledge acquisition, where you're tasking an autonomous device to go off and learn something. Survey the coast, compare it with prior maps, see if there's any damage to the bridges. Are there any damages to underwater pipes? What's a typical pattern of traffic in this harbor? Anything that involves what I call embodied, because it's a real device, right? Out in the world, acquiring knowledge. And so that basically now is a third layer that interacts with the device control layer. So it sucks in communications, it sucks in telemetry, it sucks in sense data. And if we're dealing with boats, it spits out waypoints. Waypoint is a spot that you're telling the boat to go to. And sensor commands, which may mean, hey, rotate that camera, or send out a request, So the kind of things that you've got to do, right? You got to unify sense data, and you have to locate detected objects in the world. Not on my, so that's a big thing, right? A classifier detected a pattern as being, a sailboat. But what you first get back is a bounding box telling you where that sailboat image is in your larger image frame. I don't care about that. I want to know, where's that boat in the world? Is that 5 feet in front of me? Is that 5 miles in front of me? Where's the boat? Is that even possible, right? So we have to go from that concept of training data more to reconciling things with the world. And then you have to reconcile what the sensors are telling you with what you think is true. That's that pending observations with prior knowledge to kind of come up with some sense of warranted trust. And you got to be able to take a look at that and analyze that and realize maybe what we thought we knew about boats was wrong, and so forth. So it's not a deterministic system, but it's based on really trying to figure out how many channels can you reconcile to improve this warranted trust. So goals of these can be, improve the warranted trust, right, in our classifications by reconciling with prior knowledge, by moving oneself, get a better look on it, right? By changing your sensors or by getting others to modify where they are. All right, in conclusion, AI is increasingly relied upon for providing information and performing tasks whose correctness we need to trust. Warranted trust comes from having transparently reconciled across multiple independent channels of information. Current generation AI architectures lacks a principled notion of information channel and therefore lacks warranted trust. To solve this problem, new AI architectures based on third generation neurosymbolic computing paradigms will need to be deployed. Thank you.
Are there any questions? Thank you very much for your great presentation, Mr. Eric.
You're welcome. Thank you.
Our next speaker is Professor Richard Larson. Professor Richard Larson's career has focused his operations research and system expertise on a wide variety of problems in both public and private sectors. He is author, co-author, or editor of 6 books, and author or co-author of over 175 scientific articles, primarily in the fields of urban services systems, especially emergency response systems, disaster planning, pandemics, queuing, logistics, technology-enabled education, smart energy houses, and workforce planning. His first book, Urban Police Patrol Analysis, was published by MIT Press in 1972 and was awarded the Lanchester Prize of the Operations Research Society of America. He is a co-author with Amedeo Odoni of the widely used Urban Operations Research, Prentice Hall 1987, over 1,000 citations. Professor Larson's research on cues has not only resulted in new computational, but has also been covered extensively in national and international media. Two recent papers co-authored with his students have won Best Paper of the Year awards. Professor Larson served as a president of ORSA from 1993 to 1994. He is a past president of Informs in 2005 and Institute for Operations Research and Management Services. Professor Larson served as co-director of the MIT Operations Research Center over 15 years in that post. Dr. Larson has served on many government boards. For example, with the Institute of Medicine, he has served as an invited member of the board on health sciences policy from 2008 to 2010 and on the Standing Committee on Emergency Management and Medical Response Integration from 2009 to 2015. He is a member of the National Academy of Engineering and is an Informs Founding Fellow. He has been honored with the Informs President's Award and the Kimball Medal. In 2017, he was given the first ever Lifetime Achievement Daniel Begg Medal for making significant contributions to technology innovation, service systems, and strategic decision making in New Delhi, India. From 1995 to mid-2003, Professor Larson served as the director of MIT CIOs Center for Advanced Educational Services. His position at CIOs focused on bringing technology-enabled learning to students living on the traditional campus and to those living and working far from the university. Perhaps on different continents, he was founding director of LINC Learning International Networks Consortium, an MIT-based international project that has held 8 international symposia. Currently, Professor Larson is a principal investigator of the MIT Blossoms initiative. He continues to be actively engaged in research, especially on how operations research can provide insights in the monitoring and control of COVID-19 and analyzing proposed major structural changes in the US education system. Please join me in welcoming our plenary speaker, Professor Richard Larson.
Thank you, Kieran. Thank you. Can you hear me?
Yes, we can hear you, Professor.
Okay, good. Now I have to figure out how to share the screen. So I go down here where it says share. Okay. And I'll pick those and pick those. Now, can you see those?
Yes, we can.
Excellent. Okay. Well, good morning or good evening, wherever you are in the world. It's a holiday here in the United States. It used to be called Washington's birthday. Now it's just called President's Day to honor all the former presidents and I guess the current president of the United States. And and thank you so much for inviting me to participate today. This is an honor, and I'm thrilled to do that. So today we're talking about a little bit about my new book, Model Thinking for Everyday Life. I'm holding it up here. By the way, if you think I'm trying to make money doing this, I get no royalties from this. I tried to get the price of the book as low as possible. It's below $20, so that I get no royalties. That's supposed to be a joke, but it's not. I get no royalties. And this is published by Informs. It's the first book they've ever published. That's the Institute for Operations Research and the Management Sciences. So some others are saying nice things about this. Now, on my display here, the right-hand side is being cut off. Is it being cut off by you, to you also? No. Okay. So as Professor Pinker of Harvard saying this, Professor Mark Daskin of the University of Michigan, really liked the book, and he thinks it should be required reading for any operations research industrial engineering undergraduate program. Michael Horn, very famous author, he says learning requires effort, but rare is the book that weaves active learning into its text. Larson's new book does this help us each become somebody who can learn new things each and every day. Sanjay Sarma, another well-known person. Larson's book is a fresh and innovative journey that awakens that faculty both playfully and effectively. And okay, so it's gotten some good reviews. And basically today, I'll just do a little tour of the kind of thinking that's in model thinking. Okay, and basically the adjective model here has two meanings. So it was chosen deliberately. One is exemplary thinking, thinking to be emulated. And the second meaning is conceptual models, sometimes mathematical models. So, so there's some, in these systems we look at on an everyday basis with operations research, I love things which appear to be paradoxes. Like in some logistical systems, you can speed service by deliberately inserting delays. Or in choosing the optimal locations for wind turbines to get the most electricity out, choosing the sites, a site that has the highest average wind speed is not necessarily the optimal site. I'll let you reflect on that for a while. Two baseball players, Tom and Dick. Tom has a higher batting average in each of two successive seasons. But when the two seasons are combined into one macro season, Dick has the higher batting average. How is that possible? But it's possible, and it's happened. Or you have some chronically ill patients in Ward A and Ward B of a hospital. Okay, and if the people in Ward A are the less sick and the people in Ward B have a higher average sickness, turns out that you moving some ill patients from Ward A to Ward B can increase the life expectancies of both groups with zero medical intervention. My nickname is Dr. Q, Q-U-E-U-E for waiting line. If you do a Google search on Dr. Q, my name pops up right away. But it turns out that in most service systems, the duration of the wait is not the most important part of customer satisfaction. The actual duration of the wait is not the most important thing. So in the book, Model Thinking for Everyday Life, we ask the reader to take a mind shift from everyday thinking, and the answer to our problems might be a little bit different than we thought. So we try to develop critical thinking skills in this book. The book is not an audiobook. It's not on the internet. It requires you buy a paper copy, paperback. And actually, when you read it, I suggest shut off your computer and get out some sharpened pencils and lots of pieces of white paper. So in the book, we start with a little, not start, but we have early on an instructive allegory. It turns out that a bunch of visitors in Italy, in southern Italy, would walk through a garden associated with a church every day at 3 o'clock. And when the sun was out, when they go to the garden, they notice something very strange. The hot part of this ball was on the bottom, and the cool part of the ball was on the top. And one guy said to the other, let's check this again tomorrow, and the next day after. It's the same thing. When the sun was out, the hot part was on the bottom and the cool part was on top. So they skipped a few days, and the scientist of the group said, I'm going to develop a theory for this. I'm going to develop a theory as to why the sun would heat the bottom rather than the top. So after about a week, he developed that theory, and said, I'm so excited. Let's go back. I have to go back at 1 o'clock rather than 3 o'clock because I want to share it with everybody at the church. Well, they got back 2 hours earlier than they've ever visited before. And what did they find? They found the priest rotating rotating the ball 180 degrees so it wouldn't get too hot on top and putting the hotness on the bottom. So there goes the theory. Boots on the ground. You really need to understand what's going on in practice. B.B. King, very famous blues artist. Any day I don't learn something is a wasted day. I think that's the way we should all feel. So we have sharpened pencils, lots of sheets of blank paper, and in the book, every 2 to 3 pages, I asked the reader to pause, and I asked some questions. I said, on your blank sheet of paper, work through some of your answers to these things. These are not exam questions. These are conceptual relationship kind of questions, and just to get the reader to plug in. So active learning with pencil and paper, no heavy math, and the idea is to see the world around you in terms of models. For me personally, every day I model. The first thing I do is send an email to myself after with the first cup of coffee, and I model the day. I have an agenda of what I think is going to happen during the course of the day. One of them always is 3 different walks with my golden retriever Maisie in the parks and the forests, but also the shopping or visiting the library or whatever. So that's a model of the day. But models are all around us. So here we have an example. It's raining. Daughter's in the car. Her mom's driving. Mom, she says, Mom, how come it always rains faster when you drive faster? How come it always rains faster when you drive faster? Now, why would she say that? Well, she would say that because as the mom drives faster, more raindrops per second are seem to hit the windshield, and mom has to go from a slow windshield wiper speed to a fast windshield wiper speed as she's driving faster. So we think about this, get out the pencil and paper, do this and this and this, blah, 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 sharpen pencil, think a little bit, blah, 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 think some more. And then in the book, mom has a conversation with her daughter as to whether they think through the question of raindrops on the windshield. And even if mom knows the answer, she pretends that she doesn't because she wants to orchestrate what I call a discovery learning discussion. Discovery learning, so they can discover it as a result of their conversation. And this key to learning goes back to Ben Franklin for making it widely known. And in the book's appendix, we have a full mathematical treatment of raindrops falling, what the terminal speed is, and blah 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 blah. And we solve this whole thing mathematically, but conceptually, it just requires a discovery learning conversation, and you can figure out what's going on. So Ben Franklin said, "Tell me and I forget. Teach me and I remember. Involve me and I learn." Unfortunately, today, this is like a one-way street. So I guess all I can do is maybe I can not only tell you, but maybe I could teach you a few things. So maybe you can remember, but we don't have an active learning set up here, so I can't involve you directly. So there's a special case, the Model T Ford, in which if you look at the design of that, it can kind of tell you the origin of the word windshield. Windshield is a shield from the wind, and that's what it was in the first Model T Ford, totally vertical. So no raindrops would hit that if there's no wind and the raindrops are falling straight down. No raindrops would hit that windshield if the car is stationary. But as the car starts moving forward, more and more raindrops hit the windshield. But that's a special case. Any windshield I know in a modern car is sloped. So the slope of the windshield means it's a two-dimensional analysis you've got to do, or a three-dimensional analysis. Then we have in the book something called flaws of averages. You've all heard of laws of averages. Well, there are lots of flaws of averages. The famous radio comedian, Garrison Keillor, used to say, and that's the news from Lake Wobegon, where all the women are strong, all the men are good looking, and all the children are above average. Now, you might scratch your head and say, that's odd, but that's impossible. You can't have all the children above average. But yes, you can, and I'll let you think about that. Yes, you can. It's possible for all the children of Lake Wobegon to be above average. I'll let you think about that. Now, flaws of averages. Sometimes maybe the MBTA bus system in Boston would say, okay, here's the average inter-arrival time of our buses, 10 minutes. And you might jump to the conclusion, if the average inter-arrival time between buses is 10 minutes and there's no published schedule, so if I arrive at a random time, I arrive kind of statistically in the middle of the 10 minutes, so I can expect on average, I can expect to wait 5 minutes. And so you might ask, is that a logical way of thinking about it? And the answer is no, because of the natural dynamics of urban buses. Natural dynamics of urban buses. If the picture you see here, you see 3 buses in a row. 3 buses in a row. Well, bus clumping. The physics of bus systems is such that they will clump together. And the reason is, maybe they're all spaced 10 minutes apart, and then the first bus encounters a stop with 6 more people than average. So it takes a little bit longer to load the bus at that stop, and so that bus maybe is delayed a minute or 2 behind its usual schedule. So then when the second bus arrives, next bus arrives at that place, statistically there'll be fewer than average customers there than there would ordinarily be, because the time since the last bus is only 8 minutes rather than 10. And so therefore that bus loading time on average is less than average, and it can speed up and go ahead of schedule. And eventually the second bus clumps together with the first bus, and we get that going on over the whole system. Now that's a very simplistic thing. You can model this with Monte Carlo simulation in the computer and see how that's operating. Now, also the flaws of averages. If you say that the average distance, the average time is maybe 10 minutes between buses, well, suppose the actual thing is 20 minutes between 2 buses, and then the next one is 2 minutes. So it alternates 20 minutes, 2 minutes, 20 minutes, 2 minutes. Well, and then imagine your conceptualization of hitting the timeline is like flying onto the timeline and landing at a random point. You're much more likely to land in the large gap of 20 minutes than you are in the small gap of 2 minutes. So you have a built-in structural bias to experience longer than usual delays for the bus if the buses are clumping, or if they have non-even gap times between them. So and on this slide here we have the actual calculation, and I won't bore you with that calculation. Okay, other things that flaws of averages. Shocker, half of all marriages end in divorce. This is a statistical fact in the United States. Other countries could be different, up or down. Second headline for the next day. Only 1 in 8 current marriages will end in divorce. Both headlines are true. They sound like they're in contradiction. They are not, and I'll let you contemplate on that. I'll let you contemplate. There's flows and there's levels. Flows and levels. And both statements are true. Final example of model thinking for everyday life. A.K. Erlang, Danish telephone engineer, 1919 in Copenhagen, Denmark. He was the inventor of queuing theory. Don't you love that word, queuing? because the second E can be put in there. The second E is optional. Excuse me. But I like to put it in because then it's an English language word with 5 vowels in a row. I'm not aware of any other word that has 5 vowels in a row. Anyway, in 1919, the telephone used to be you'd have to hang a wire from your house to your neighbor's house to talk to your neighbor by telephone. And then they invented the central telephone switch. And usually there were female operators that would connect caller A to caller Z, et cetera, et cetera. And but there was a modern central telephone switch that allowed anyone with a telephone to call anyone else with a telephone. But that switch required an analysis of what its capacity should be, how many calls can it. We should design it so how many calls can it handle simultaneously, and also how many human operators do you need to operate this thing? Because as the volume level of calls goes up, the number of operators you need to handle all these calls would also go up. So Erlang invented queuing theory, and basically Erlang's equations, which were created 106 years ago, are still the key equations that are used today in analyzing queuing systems. Now, if you really need to study a queuing system deeply, and it has all these nuances and wrinkles, then Erlang's equations are an aggregate approximation, and you might want to use Monte Carlo simulation. So Lily Tomlin Ernestine was a 1950s a telephone operator, and that was on Saturday Night Live. So 911 operation. So in the U.S., if you have an emergency, police, fire, or ambulance, you call 911, and the operators. There's some operators right there, and basically with queuing theory and Erlang's equations, it shows you what the average waiting time will be. And the vertical axis here in terms of the mean service times. So let's say your conversation time on the phone once you get into, so you can talk to the operator, will be 60 seconds, 1 minute. So your mean service time is 1 minute. Well, here on the bottom shows the Greek letter rho, the fraction of time that the server is busy. So if the server is busy less than half the time, 0.5, the amount of delay you have, waiting time until the phone is answered, is pretty small. But as the fraction of time busy goes up, let's say to 0.7, if it's a single server queue, you might have to wait 3 minutes to have your 1 minute conversation. If it's a 0.8, if the server's busy 80% of the time, you might have to wait 5 minutes to get answered. So you see that blue line on the top goes up very rapidly. The yellow line or the mustard color line in the bottom also goes up very rapidly, but more slowly, because there you have 10 servers, and so with 10 servers you need to hit maybe 0.8 or even 0.9 busyness before you have an explosive growth. So I call there's like a line on the right hand side which I call the wall of death. The wall of death happens when the required service exceeds the available capacity, and then the queues grow without bound. So you see these queuing delay formulas are showing explosive growth to infinity, and that's what happens if you hit the wall of death. The wall of death means if you have a 911 emergency and you have a life-threatening situation, you might be facing the ultimate sacrifice here. Okay, so over my career, I've done not only published original models, but not Erlang's equations. Erlang 106 years ago, he did that. But I've also had boots on the ground and worked in actual systems. When I was a doctoral student at MIT, I spent a lot of time as a consultant, and I worked in New York City's 911 system. And New York City's 911 system, which came out in the late 1970s, it used to be in New York City, if you had an emergency call for police, there were 2 numbers in Manhattan, 2 numbers in Brooklyn, and 1 number each of the other 3 boroughs. And that was just for police. And there were other special numbers for fire and ambulance. So there were like 20 some odd numbers for emergencies in New York City. And that was way too many. So basically what they did, they erased all those 7-digit numbers and combined it all into 911. And that 911 system then became a national model for the entire country. So for the entire country now, to the best of my knowledge, if you have a medical emergency or police emergency, a fire emergency, you can call 911 and the local emergency people will answer the phone. Anyway, so I worked there because of, as a doctoral student, because in the New York Times, I started reading. Started reading these letters to the editor. Dear New York Times, I called the mayor's new 911 system last Saturday night. I let the phone ring for 18 minutes and there was no answer. I called back. I let it ring for 20 minutes. And then they said, police emergency, may I help you? After a 20-minute delay. So anyway, I was called down to Southern Manhattan to work with 2 lieutenants. And I basically lived there in the facility for, he's lived there in quotes, for a whole month, collecting data, observing what's going on, and observing. So we got data on each by day of week and hour of the day, how many calls came in, how many operators were allocated, and what the delays were. And what this shows, particularly on a Saturday, the orange dotted line that goes way up at 1900 to midnight shows that 30-second calls that were delayed for 15 seconds, and below that there's calls that were delayed for 30 seconds. A lot of calls were experiencing big delays. The blue semi-solid line on the bottom was the police department's attempt to juggle the allocation of police officers over the 24 hours. And they said, well, between maybe 3 a.m. and 7 a.m., we know that the call rate is low, so we'll allow them to take 2-hour naps then, and there's no nap time otherwise. And so the only adjustment of the scheduling of personnel was 3 a.m. to 7 a.m. And you can see it there in blue. They reduced the number of operators by 50%, more or less. Other than that, the number of operators were constant. And this is not at all a reflection of the hugely time varying nature of calls for service. So I went in there. I lived with the 2 lieutenants for a month. And we basically solved the problem. They worked on all the human training aspects, and I worked on the math queuing aspects. And we implemented it with 8 different tour schedules, and that was implemented within 1 week after we presented it to the chief of police. I remember I was kind of shaking in my boots because this New York chief of police was known to be a really tough guy. So I was a little bit shaking when I presented this to him and a whole group of top leaders in the New York City Police Department, along with these 2 lieutenants who I worked with. And after about a minute of my talking, the police commissioner, who will go unnamed, said, "Wait a minute, hold on, everything, so son, whatever." He said, "Lieutenants, are these Easter Bunny charts correct, or what's really going on here?" And he referred to my charts as Easter Bunny charts because I had different colors for different days of the week and different hours of the day. And the 2 lieutenants gulped and said, "Yes, sir, everything he's presenting is correct." And then the police chief said, the commissioner said, "All right, I'm going to focus on this." And he implemented in 7 days all of our recommendations. That's the fastest to my whole career, including up to now. That's the fastest total implementation of any study I've ever done. After that, we created something called the hypercube queuing model. And that's a queuing model that also includes the geography of what's going on and the intensity of calls for service. And I don't have time today to go into that, but that was a major thing. I spent 2 years working full time on myself, programming it myself in the C language, and that's been published in a number of journals. So our focus is on model-informed critical thinking, and critical thinker is swayed by facts, not emotions, not politics. And a critical thinker is also aware of the pitfalls of human intuition, as we've shown with many examples. You know, and my intuition, I think, is pretty good, but it's also quite wrong. When I first look at something, I say, "Wow, how can that possibly be?" So you have to use these mathematical models, and usually just pencil and paper models are good enough to clarify your intuition. So a life example of models is what I call deferred maintenance. Here's an advertisement from 1972, the famous Fram oil filter commercial. And this is replayed a number of times. Most recently, I got this picture in 2012. And the Fram oil filter guy says, "You pay me now or you pay me later?" And I think the Fram oil filter at the time was maybe $8. You pay me $8 now, or you pay me $500 later for a new engine or engine replacement. And this deferred maintenance is something that we all need to think about in terms of model-based thinking. So in the book, we have a whole section toward the end of the book on deferred maintenance. So what are we all guilty of in deferred maintenance? We're all guilty of deferred maintenance. MIT admit, my home university, Massachusetts Institute of Technology, admits to a deferred maintenance on infrastructure in their grounds and buildings and systems of $1 billion. They admit to a deferred maintenance of $1 billion. I wonder what the true thing is. And probably most organizations have deferred maintenance, and most individuals. Your car might have this in deferred maintenance, your house, chimney, fire alarms, yourself, health-wise, your friendships. So deferred maintenance is something that we discuss at length in the last part of the book. Now, my last slide here is something that was published in Science magazine. And basically this was published in 2018. And when I turned 71, I was still a full chaired professor at MIT. And I started reflecting on this. I said, you know, and I worked with a student. I said, you know, when I joined MIT's faculty, first of all, I was stunned that I got invited to join the faculty, and then I got tenure. I was told that you must retire at age 65. That was the mandatory retirement age. And then they changed it to 75. And then a Supreme Court decision said, no, you can't have any mandatory retirement age because that's age discrimination. So I said, here I'm 71. Yeah, if I should be lucky enough to live to 100, under the current new rules, I could fill a tenured slot here at MIT until I die at age 100. I said, that doesn't seem fair. And so we actually wrote an article. It was published in Science magazine to figure out how this Supreme Court decision was affecting the inflow of potentially new assistant professors. And us old timers beyond 65 who are still filling tenured slots were reducing by 18% or so the inflow of new assistant professor slots. And we didn't think that was very fair. So we wrote that up, and that was published in Science magazine. That's it. That's all, folks. I have time for questions, if there can be any questions. Thank you very much for your attention. I appreciate it.
Are there any questions? Thank you very much for your great presentation, Professor Richard.
Thank you very much. Thank you very much. I enjoyed it.
Yeah.
Take care now. Bye-bye.
Bye-bye. Our next speaker is Professor Francesco Aialuri. Professor Francesco Aialuri is a visionary and facilitator who has been at the forefront of driving digital transformation in organizations since the 1990s, leveraging extensive technological expertise with nearly 30 years of global experience in sales, strategic planning, and business development, spanning various industries, including major players in the global information technology, finance, media, and mobile operator sectors. Constantly driven by a passion for learning and sharing knowledge, always willing to adopt and educate. A skilled organizer and team player renowned for identifying and capitalizing on emerging business opportunities. Possesses in-depth knowledge of potential new products and services, both from a business and technological perspective. Excels as an empathetic storyteller, captivating audiences in keynote speeches and academic institutions, instilling a hunger for knowledge that resonates with the essence of our world and its continual improvement. A visionary who constantly seeks metaphors and paradigms, exploring the depths of our existence. Passionate about the practical applications of science in our everyday lives, with a keen interest in music, arts, painting, and various forms of human expression. Offers valuable advisory services to investors and multinational companies venturing into new geographic markets, including Europe, USA, and Africa. Actively collaborates with the United Nations in efforts to uplift developing countries. Additionally, holds roles as an independent journalist, sought after keynote speaker at international events, columnist, and esteemed university lecturer. Please join me in welcoming our plenary speaker, Professor Francisco Ayaluri.
Okay, thank you, Kieran, for the presentation, and I will share my screen and I will start my presentation. I'm sorry, I'm a bit sick, so my voice could be when go and return, so go away for a bit because I'm coughing. But by the way, I will try to succeed to make the presentation. Hopefully, you are hearing me. So if nobody told me nothing, so
Yes, we can hear you.
Okay, perfect. So let me see, where is the share button? Here it is. Okay, allow. Okay, I just remove a lot of button here. Okay, okay, let's start. My presentation today, it's about
yeah, you can click on
how.
slideshow.
Yeah, okay, better.
It's better now.
Okay. No, it's better because I need also to show you some other things, but I be back in another modality when I need to. Okay, what is happening now? It's everybody speaks about AI is revolutioning anything on business side, but also how the profession is changing and moving. But we are focusing. This is my phone ringing. We are focusing more on creative industry and profession on this presentation, and we will see. Sorry, I have some phone ringing. Okay. So this is the place where I spare most of my time when I was 18 and also teenagers in a radio. So speaking with playing records on devices like this that does not exist anymore, and play tapes in other devices that does not exist anymore with mixer and so forth. So I was a passionate of technology, and as soon as I went to university, I started to play with other things. It was late 90s, and my first job was on computer, even if I didn't take the degree yet, but I programmed with the VAX Ultrix from Digital Corporation, and we ported the Unix on the systems. That was the Berkeley system 4.2, if I remember well. But the idea was to transform the technology, and the technology transformed the human, and how the human use the technology. That was the idea. Then arrived at the Mac, and we made a lot of movement, and I also worked in Silicon Valley, of course, for four years from 96 to 2000. And in reality, I was in this place, but with the old logo that was that one behind the Facebook logo. It's the site was in Menlo Park. It was owned by Sun Microsystem. This to say that, sorry, in my story, I started with passion of technology. Then I became a computer scientist because I took the degree, and then I started as technology evangelist. Then I became a technology advisor, business developer, and then now I'm focusing my mind and my effort and my work. One is I will share you with a link with some research that I have made in this on social data science. That means AI application not only in the company but also in common people, and how they can interact with technology within humans, and between the things that normally human do. Which is the relation, which is the artificial intelligence and the heart. Of course, the heart is a reflection of the research of the humanity for knowledge, the creativity, and understand each other, or also understand ourselves. So a self-understanding about how we are able to do, which could be the thing that we can make with our hand and our brain. And of course, AI is reshaping this way, and we can see that it's changing a lot of job. We will see some example later. But the idea is that even if in a specific place of the world, this is, for instance, is wood painting, woodwork in Japan or in China, that is an artisan way to work. I am from Italy. Also in Italy, we have a lot of example of this. But even if in this specific area, we can have some work jointly with artificial intelligence, that of course is not a replacement, but is a sort of aid. The first man that is trying to understand which could be the rules that the body has within the nature, and understand which is the principle that can realize a data set. Of course, I'm speaking about word that at the time that was 15th century, there was not pronounced because was not ready, available for the public speaker opinion. But the idea of Leonardo was to study the proportion and quantity, because if we are able to understand what the human can do, we can also replicate the human, but also can make the idea how we can improve. And the idea of Leonardo is try to give some weapon, but also capability to the human body that normally human body doesn't or haven't. Like, for instance, the possibility to fly or possibility to make other stuff, and they can. He founded with the Codice da Vinci, with Leonardo Code, a lot of machine that can enlarge and optimize and improve the human capability. Again, also some other Italian, it's Michelangelo in Sistine Chapel. This is a picture of the creation of Adamo, where the god tried to transfer something to the human, to the Adam. In this picture, there was intelligence, because the human respect of the other animals has an intelligence, but the concept of AI is the same. We try to breathe life in the machine, and also we can also think about that the fears that many times we have is that probably we transmit everything to the machine that probably we have no more to transmit, and the machine is smarter than us. This is important because we are trying to create something in our own imagination, but this will be in our control or not. This is also another idea. This is I don't know if you know this. This is a mechanical Turk. It's an invention of an Austrian person. It's Philips James the Lattenborg that travel around the court for many queens and castle in Europe to present a robot that was represented as a Turk that was able to play chess. And not only to play chess, but also to make some specific action, like move the horse in the chessboard in any square, in any cell of the chessboard, without to jump in the same cell until to cover all the cell of the chessboard. It was an incredible invention, but in reality there was not invention. There was just an hoax, because there was a small guy closed in this box that we can see the box, but normally the box was closed with a roof, with a chessboard, and the impression was that without human intervention, the robot was able to play and also to win some games. The idea is that AI probably has a lot of information that probably is not pure, but is not very true, and can mimic, can replicate some action, but it's difficult to think about AI. At least now that we are speaking about now AI, not a general AI, to speak about something that is able to compete with the human brain. Just to let you know that AI, a group of French guy working in university, try to make a picture realized by AI. So they trained the AI with a lot of pictures, a lot of masterpiece from Parisian museum like Musée d'Orsay or Louvre, and from there they started to ask to the AI to make a picture with the same idea. They try to put on sale this kind of picture, and they say we will see that probably we'll gain 10,000, 20,000 euro, but this was opened by in auction for the number is there. It's $432,000. So that's idea. But question remain: can AI truly create, or is it merely remixing of existing human expression? This is the idea that we need to think about. Let's go on creativity more. So the idea that AI and creativity can work together. This is a representation of a mythology figures that it's Minotaur is a half horse, half human. That many times when we speak about cooperation between the two worlds, we speak about these figures, because it represents how they can work together. If we look the specific work that World Economic Forum made because of Davos in January, we will see which can be the profession, the work that will be aided by the artificial intelligence. We can see that there is a lot of job that is growing due to AI, and we see big data, of course, fintech, and the machine learning, but also software and application developer, because they are working jointly with artificial intelligence, and then can improve the way that they work and also the speed how they work. There is also some obsolete words like data warehouse, and now everybody speaks about data lake, but I am older and I can explain also data warehouse, and that it's a way where we put all the data coming from different sources in a unique place, a lake. And this is going to be bigger and bigger than before due to AI. So AI is not destroying any job, and it's not only created new job, but it's only improved the job. If you see the picture, we think that in the next 5 years, the big data specialist, that probably was something that we will see, it's big data is not anymore fashion, is not sexy as was 3-4 years before. But this is not true, because the big data specialist is the thing where all the work will be concentrated in the near future. This because there is a lot of work on datafication and about what it's possible to do with data, and there is a specific branch of the social data science that speaks about datafication. It's also important. We can see that things like UI UX is still in the middle, and there is data analyst and scientist that 2 years ago was the most increasing job. Nowadays, not anymore. Is a sort of thing that we will see also in a company, because the question is that you can have a data scientist that know computer, know STEM, maths, or any kind of thing about technology, but they don't know the company. So taking the people just exit from university to put the data that don't know anything about them, because they are not elder enough, or with 10 years or 20 years in a company is difficult. So they are decreasing. Of course, there is a counterpart that many job is declining. It's the clerks' job, so postal service clerks, bartender clerks, cashier, antique clerks. All these clerks is decreasing because they are out automatically, and also legal secretaries or telemarketers will be substituted by the advent of AI. This is a LinkedIn research of the hill of this year, and we can see also where AI is participating to the growth of the specific industry. Of course, technology, information, and media is the most important one, but also education and professional services, it's gaining a momentum, as you can see. The slide will be available, so I can skip. You can. We concentrate now. Let me see, which is the timing. Okay, 56. The future of the profession. So how will be the future profession? I put here a book that was very fundamental for me, from Richard Susskind. Has been written also with his son Daniel, and it's about how the profession will change in the future. Not only creativity, but general, all the profession. We have two possibilities to see this change. One is that sorry, I need to drink some water. So one is the more efficient version of what we have already. For instance, we have barrister, we have lawyers, we have doctors, we have consultant, advisor. That will remain the same, but we will be stronger and will be more defined and more reactive, and so forth. There is another idea that it's my idea also, that expertise and professional will be available to the public and to the society in a different way. What is the idea about profession? today. We can take a single profession like let me say barristers, lawyer, let me say, and we can say that they gave some services to the public, and there is a bargain. They call in the book a bargain. A bargain for me, it's just a business, it's an affair, but can be translated in a sort of agreement, license, a mandate, a claim, or regulation. Can be several things, but the idea is that there is a profession and the professionals, of course, that give some services in a sort of arrangement to provide the services. But if we look in the category that we have at the moment, we see that they have, of course, a specialist knowledge on the subject. So barrister need to know about lawyer, consultant need to be on consultant, doctor should know about medicine and health in general. But the most important is their mission depends on credential many times. Their activities are regulated, and also they are bound to a common set of value, like Hippocrates' laws for medicine and so forth. But let me think about the admission depends on credential, because if we look some specific research that has been done, we discover that in the United Kingdom, for example, 75% of the senior judges or 43% of barristers went to independent or fee-paying school, which educate only 7% of school children in UK. This is the first. If you speak about newspaper columnists, that everybody went to the Oxford or Cambridge. And in 2011, among undergraduates accepted for medical school, 55 or 60, almost 60% were from the highest 3 socioeconomic group in UK, and 7% were from lowest 3. So the idea is that there is a specific path that you need to follow. And if you follow this path, specifically in UK and also in US, you reach some place where you can give some advice or some service to the public, to the society. So, which is the grand bargain? The grand bargain is the social contract that there is between profession and society. And historically, these people had exclusive right and autonomy to exchange their expertise, reliability, and ethical content. The increasing role of challenges and the necessity of professional monopolies, rising cost of professional and other staff, is giving them in a sort of prison, so they cannot exit from where they are, and they can start to maintain the same role and increase more and more and more the money. The future will be different, because due to AI, the future involve more democratized distribution of expertise. Technology will enable broader access to professional knowledge without rely on gatekeeper that is no more available now because it's too many traditional. I have a paper that I'll give to you where you can see the long story, but the idea of this specific domain in an artistic domain where this could be very strong impact is in editorial, so newspaper, columnist, and so forth, graphic design, programming, editing, of course, but for sure also will came all the activity that will be interdisciplinary, like psychology, technology, or creative practice will be involved, because they have some emotional or cognitive aspect that now is not very well addressed, but also this will be available. This is, for example, here that you can see also in a paper that is there. and it's a paper that it's a long one, but you can take time to read it. And I made some example about which could be some tradition and economies rooted in originality that has been improved and not replaced by the AI. One is the Leather Shop podcast in Florence about leather. One is ceramic that they, of course, probably it's too small. They adopted a design technology to explore innovative forms and design while honoring traditional motif and the synergy. Advanced technology century attracts younger generation to ensuring the continuity of this thing. So just to be back to the slide and to be back to the presentation. There is, for example, in ceramic, wine, how we can improve your wine, not only in a specific formula to put some chemical at all in the wine that of course should be, but also which is the right time to take the grapes from the vineyard, or which is the time to put more water or to make some specific action due to forecasting AI and so forth. So leathers, but also wood blocking in Japan or China. There is an example where the creativity is the main job of the story. It's for sure in the movie, in the movie business, in the cinema business. The artistic work is the main work. And yesterday there was the BAFTA for the actors in UK. That was a good ceremony about winners, red carpet, and so on. But we saw in last year in November a strike from actors, singers, and voiceover artists against AI, because they say that an actor cannot be paid for all the movie because a director or production can shot several scene or several condition many times, also with the green screen behind, and can reuse this shot, asking to AI to move the actor. Of course, you can decrease the amount of money that the actors perceive, but also other people in the chain. This is important to understand, that movie business is not only a business that involves actors and directors, because involve also location, restaurant, hotel, and travel, transportation. The actors that need to shoot something in Arizona need to take a flight from New York to Phoenix to shoot a movie, but need to sleep and rest somewhere, need to eat in a restaurant. So there is a global business that can collapse because of AI. So that's why they make this strike. And also AI in this creativity works has a lot of resistance. But I think because many people has a fear that they became obsolete. So the stem for fears from obsolescence, it's very hard. Sorry, I'm difficult to speak. Sorry. So case study reveal instead that while AI has efficiency, it's often introduce new challenges that need to be prepared to fight against. Okay. Now there is a link to the doc here that you can find in this presentation, because since I started with the passion out of technology, but I'm still a computer scientist in the heart, in the nucleus of my body, of my brain. I try to understand where is possible to measure what is happening on the net, and I try to go to several places on Twitter to understand the discussion about AI and creativity. But Twitter, that now is X, is not possible, at least for free or for few money, to discover things. And the Mastodon and Blue Sky, that is distinct below, is not so good because there's few people in there. So I examined on 3 or 4 video on YouTube, and also the comment of the comment of these things. Then I went to the Steam to understand what the people that develop games think about. And I made the same on Reddit and Quora. I selected these two think of source of information like YouTube and Reddit. And I started to understand when there is information about people searching about AI and creativity. The first thing, this is Google Trend, and we will see some start of discussion 2002, probably November 2002, probably with the first release of ChatGPT, and then the story start to be strong around again October 24. No, it's May 24. So this is the idea where I don't see. Okay, it's better now. It's around this period in 2024. They are starting to search query about creativity, and we can see that the query is AI, ChatGPT, can AI have creativity? So I understood which is the period and the region of the planet where they are discussing about this topic. It's not strange that China is the most country where they are discussing, and there is the other things. The work that has been done on Reddit, we take some thread, and I try to zoom because I don't think you are able to see something. And on Reddit, we take. I take because I make the work, and I take some thread like this one, AI impact on creative industry, and I examined all the comment. This one has only 54 comments, and we used Python to examine the things. And this is the code. Of course, there is no my key, but there is the idea how to extract information from Reddit, and I made the same from why doesn't go on? Okay, let me see. Okay, I made the same with YouTube. We took a discussion that I don't remember the journalist made to two people. One is an artist from Florida University that is using AI to improve his art class, and also there is another person that works in a cinema, in a movie industry, that in reality is a computer scientist. She's a computer scientist, and they have a different vision about AI. There is a link to the video, by the way, this one and this one. And there is also some other TEDs. So I take all this information, and we put this information in a graph, and I projected the very well-known word cloud, and we see that that in the cloud there is terms like right, humanity, need, think, but the most important is people, human and artist. It's more social than technology, and if we can see the emotion and the sentiment analysis that we made on this, everybody is more negative than positive. Of course, there is a lot of neutral, but if you look the sentiment or the emotion that inspire, we can see. I use the model that is trained by specific Reddit and and YouTube, and we will see that people seems admire this kind of stuff, but also there is probably some annoyance and amusement about this topic. This to say that I think this is my conclusion, that we start to say how we as a human, we started to understood the world, and we start with Leonardo that try to figure out which could be the rules that can improve how the human being can live in a planet, in an earth with other people. And then we try to use the mechanic or the hooks like mechanic Turk to present something that probably could be imagined like something special that is able to demonstrate to us something that does not exist because probably is in hooks. And then we reach the power to realize LLM or very important system that is able to speak with us like a human. I made my thesis in computer science, University Pisa, in Pisa University in 98, last century, in artificial intelligence. My reference system was MySyn, and I changed to other route because there was not possible to continue on that area, because the machine that I worked on, like Common Lisp from Lucid Corporation, didn't have so much space. But in the last 5 years, company like NVIDIA or other DeepSeek in China, they are using a new hardware to make possible the algorithm and statistic that was not possible 30 years before. But examining past masterpiece and with the lens of AI, so what we can do with technology now, we can have a deeper insight about our future, a specific how the profession can be dismantled. Because when a new hire join a company, is not looking anymore for people that stay 10 years, 20 years in that company, that explain to he or to she, to her, to him or to her, how to approach a customer, how to make, because they know everything. As we can see in the picture, there is no clerk anymore. So you need to understand the knowledge, how to live in a company, how to live in a society that nobody tell to you anymore. That is the problem, because AI is becoming now the new religion, the new mentor, instead of your family, instead of your teacher, or your priest or anything. So this is most important to understand, and understand that the integration of AI in specific context will ensure for sure the traditional method and artistic value that will remain and will be not overshadowed by automation. Business chain value is often greater than it appears. So this is my reference, and I finalized my presentation. That was a very hard for me, for my condition, but I hope that I transmitted to you something, and I can stop my share if there is any question. So hopefully you follow all the information. Again, if Kieran we share the presentation somewhere, there is a link to the work that I have done in my personal webpage. Kieran, I'm done.
Yes. Okay, Professor. Are there any questions? Yeah, Professor, there is a question for you from Sebastian.
Okay, go ahead, Sebastian.
Hi, Prof. Always a pleasure to hear you speak. Nice to see you again, and wish you quick recovery.
Yeah. Sorry.
No problem, Prof.
Go ahead.
Prof, I was a little bit rattled with the graph you showed as regards to jobs in demand, and getting to know that big data specialist is the top of the list is is something I don't envisage. So, I mean, is there any reason why that is so? Because I was thinking AI expert as AI is taking over the world, sort of. Prof, I can't hear you. I think you are. Yeah, this. Prof, you need to unmute.
Sorry, I was on mute. Sorry.
Great.
Okay, so the question is why UI UX is here, or do you want a comment again on this chart?
I mean, the big data specialist seems to be the top on the list as one of the
Yes.
fastest growing job. Is
Yeah.
there any reason why it's so? Because I would think AI specialist or machine learning should be at the top of the list.
Okay, if you would like to have a longer explanation, I suggest you to download the report that is free of charge from World Economic Forum. If you put World Economic Forum jobs report of the job of the 2025, because they make this report every couple of years, and you have a longer explanation. My explanation that big data now is not only big data that was 2 or 3 years ago. We started to think about IoT. IoT is something about 5 years from now. Then big data, because they need to process data coming from sensors. And then we started to go on AI and machine learning. But now there is a lot of study on datification. So which is the rule that need to be put on place to examine all the data that arrives coming from cameras, individuals that move. And there is a lot of information about datification. So not only technology or IT person is working on big data now, but also sociologist and psychologist is moving on this, and is now big data is a center of a multidisciplinary study, not only big data. So if you mean big data as was 4 or 5 years ago, is not in that place, should be not there. But since now there is the name is datification. There is a lot of book on this. If you Google datafication, and you can see there is a lot of information that how the government need to treat the information that arrives from sensor. That's why it's in the top, because it's a most demanding, at least in Europe, because of regulation and because a lot of AI on this topic. So this is the way why big data is on the top. Fintech is obvious because there is money around. Hope I answered you somehow.
Wow, thank you so much. Really makes sense. I really appreciate it. Thank you, Prof.
Okay, send to me information by my email so I can answer you personally, just in case.
Okay, Prof. Okay,
And
Prof.
write you where is the PDF.
Thank you, Prof.
Yeah, thank you very much for a great presentation, Professor Francisco. Yeah, our next speaker is Mr. Ogidan Toluwaleki. Mr. Ogidan is a data engineer recognized for his expertise in data analytics, machine learning, and for fostering youth empowerment through technology. He holds an MSc in Applied Data Science in Engineering with distinction. Tolu has made a significant contributions to advancing technology and supporting communities. He is the recipient of the prestigious Nelson Mandela Leadership Award of Excellence in Integrity and the West African Youth Role Model Award, honoring his impactful volunteer efforts and outstanding achievements in academia and career. Please join me in welcoming our speaker, Mr. Ogidan Toluwaleki.
Good day, everyone. Thank you for having me. Going to share my screen now. Okay. Can you all see my screen?
Yes.
Okay. So once again, I'm happy to be on the same stage with different reputable speakers. And this afternoon, in UK, this afternoon here in UK, I'll be
Please click
speaking.
on slideshow.
Okay, hold on. Okay, is it okay now?
Perfect now.
All right. Okay, so it's the afternoon in UK, and I'll be speaking on this topic: enhancing stability in machine learning explanations with S-Line. And so this is the overview of everything I'll be talking about. I'll be giving a brief description of the topic and the objectives and a few analyses I conducted on the topic and the conclusion. So talking about the topic, enhancing stability in machine learning explanations with S-Line. The first thing I'll be talking about is why machine learning explanations to start with. And so much has been talked about different machine learning algorithms that have been used to make predictions in different industries. As of now, there are several advanced machine learning algorithms that exist: neural network, gradient boosting, regression models. And these models have been found to be accurate. They've been found to make accurate predictions. But then there is a trade-off between the accuracy of advanced machine learning algorithms and the explainability or transparency of these models. When we look back at simpler models like linear models, even though it's easy to understand how they make their predictions, it's easy to identify the variables that they use to make predictions, but then though it's more explainable, they are simpler models, but then they are not really accurate when it comes to fitting into much more complex data sets that we have these days. But then when we apply advanced machine learning algorithms that captures more complexity of the modern data that we have in this era, but then it also sacrifices transparency. And this is an issue in safety critical industries like the aviation industry, also in the medical industry, because it's difficult to implement certain models that stakeholders, especially non-technical stakeholders, find opaque or find non-transparent. And this is the reason why we call such kind of model black box. We call them black box because even though we can easily like identify with the accuracy in the output that it generates after carrying out predictions, it's difficult to understand which variables is being used to make the predictions. So, and this is the problem with the black box models. First is difficulty in validating model decisions. So it's difficult for non-technical stakeholders to understand or to really to understand if there's any bias in the decision that has been made by this model. And this is an issue also in the finance industry where, for instance, models maybe are used to predict the creditworthiness of their customers. But then depending on how this model is being trained, sometimes there may be bias based on variables like race, variables like age, for instance, and this is sort of an issue for non-technical stakeholders, the non-transparency, and that is the essence of explaining black box models. That's the essence of that is the reason why a lot of research is going into different research methodologies or different methods that can be used to really make black model transparent, make non-technical stakeholders have much more confidence in implementing these models in safety critical industries. So the essence of explaining black models includes the transparency, increasing trust and accountability across board, fairness and bias mitigation to ensure that these models, aside the accuracy, are not biased in the predictions that are made. So my research objective in trying to validate the use of one of the uh, um, explanation method called LIME. The first thing I did was to develop and train one of such black box model on an aircraft engine data set, and also evaluate the predictive accuracy of the model, then use LIME, which I'm going to be explaining in detail about, to explain the decision-making process of this machine learning model, then also validate the hypothesis of the instability of the method, then also implement a way of stabilizing the method. So I'll be explaining LIME as an explanation method. So LIME stands for local interpretable model agnostic explanations, and the meaning of LIME is in the acronym itself. So why is it referred to as local? So if I have a data set of several rows and predictions is being made, I might not necessarily want to explain the predictions made across the data sets. My interest might lie in just identifying or explaining the prediction made on an instance of the data set. So LIME as a method is being designed to explain just an instance of a data set, not the whole data set across board. So say for instance, maybe in medicine, for instance, I have a data set that is comprised of different patients. Maybe different patients are being represented by different rows of a data set, and there is a prediction made on a diagnostic. So I might be interested on the prediction made for a particular patient. Maybe I want to explain how the model is able to predict to make diagnostic on one particular patient. LIME is a method that has been designed to do that, to explain the explanation on an instance. Then interpretable. Why is LIME referred to as interpretable? It's referred to as interpretable because inherently is being designed to interpret a much more complex model called a black box model. But then how does it do that? It does this by fitting a much more simpler model into the instance that is being predicted, and that is why it's being referred to as interpretable. Then it's being referred to as model agnostic because it can be applied to any model. It's not selective on the kind of model it can explain. Then the explanation itself is in form of feature ranking, which I'm going to show in the result of my experiment. So how does LIME really does this? How does it carry out the explanation of the prediction on an instance of the data set? So the first thing that definitely is going to be done is to select the instance I want to explain. I have a prediction that has been done on my data set across board, and I want to select an instance. So let's assume this instance to be this dot here. And now the black box model has made the prediction across for this instance. So what LIME does is it creates random points very close to that instance. That means it generates its own artificial data, but in close proximity, in close value to the point that has been selected, and that makes it a local method. So it's calculate the weights based on the distance from the chosen point to make sure that all the points are in close proximity. So the next thing it does is to make the prediction again using the black box on the new point that's been generated. Then it fits a linear model, a simpler model, across the new point that's been generated. Then it calculates a new weight for the features in the order of importance for the prediction for the new prediction that is being generated from the linear model. So is this feature rank is this weight calculation that forms the feature ranking that really explains the features that are more important in in deciding a particular prediction. But then, despite the advantage of LIME being an explainability method for explaining black box model, it has its own drawbacks as well. And one of the drawbacks that I found during my experiment is instability of the results. So I found out that if I implement LIME on a particular instance of a data set, the result I get is different when I implement it over several iterations. So I carry out multiple iterations to see if I'll get the same set of feature ranking that decides on or that influences the prediction of a particular instance of a data set. So LIME has been found out to be unstable, and this has been written in different and in different papers. The limited scope of explanation, of course, LIME as design is meant to explain just an instance of a data set, not the entire data set. So is in that way is limited, sensitive to hyperparameters, and the causes of the instability of LIME is the selection of features, the model selection, and the sampling variability. And the effect of instability of this method is reduced accountability. If I'm creating a method like LIME just to increase accountability, to increase trust among non-technical stakeholders, and the result itself is now unstable, then it's not solving the problem that is being actually designed for. And that is the essence of my research, to find a way to stabilize the result of this method so that it can be trusted in use in critical sectors like the aviation sector. So in carrying out my experiment, this is the methodology. I got a sample data set, which is like an aviation data set. I pre-processed it, splitted the data set, applied a black box model, carry out LIME explanation, and validate the instability before carrying out the weight aggregation to stabilize the method or the result. So this is how the data set looks like, what I used. So we have different variables, operational settings, several sensor measurements that actually predict the remaining useful life of an engine. And I splitted the data set into the training data and the test data. So the black box model of choice for me for this experiment is the graded boosting regression model, which has been found to have high accuracy. And I fitted my data set into the model, and I recorded high accurate result for that. But having high accurate result is not the essence of the experiment. The essence of the experiment is to explain the prediction of the remaining useful life that is being made on the data sets. So what I did with the LIME method for my aircraft engine data set was to select an instance of the data set, which is one of the engine that the remaining useful life has been predicted. I selected one instance. I fitted my LIME Python, so I don't have the code here, but this is what the result looks like. So I fitted one instance of this prediction of the remaining useful life of the engine. I fitted it into the LIME result to know what variables actually contributed to the prediction of the remaining useful life of this engine. And the result of the LIME is that, although definitely time is a constant factor, because as we use the engine over time, it wears off, then the remaining useful life reduces. But then there are some other factors or variables that actually speed up the reduction in the remaining useful life of an engine, which are though I didn't give detail of what the sensor means, but let's just take it as sensor measurement numbers. So we see sensor measurement 15 being the highest contributor to the prediction of the remaining useful life of this particular engine. And for the engine I selected, this is the remaining useful life, 175 cycles. So this is the ranking results generated from this line method, and that is how it explains the black box prediction of this particular engine. But then, to validate the instability of Lime as a method for explaining black box model, I carry out 5 different iterations on the same instance of engine that I'm trying to explain the result. And what I discovered was the ranking actually, there's a marginal change in the ranking that was being produced. So for the first iteration I carried out, I discovered that sensor 15, 11, 4, 13, 3 contributed to the remaining useful life. Then I say sensor measurement 14 have a positive contribution, 8 has a negative contribution. But then for the second iteration carried out, though the first 5 sensors were constant, but there's a marginal change. Sensor 12, there's raised head here, so there's a new sensor that came up in the ranking, and in the third iteration, there's a difference as well, same as well as the fourth and the fifth iteration. So if I'm going to be presenting this to the stakeholders, what I'm telling them is that this line method is not really reliable to explain the black box model. They can't rely on this feature ranking to explain the features that actually influences the black box model prediction. So what I did to solve this was the different iterations I carried out, the weights that is being used for the ranking, I averaged them out. Though before I go into that, this is a summary of the feature ranking. So these are the sensors that were constant across the 5 different iterations: sensor 15, 11, 4, 13. They had the same rank across the 5 iterations. But then these other sensors came up, which shows that this method is truly unstable, because over different iterations, it generates different results, which is not reliable, which doesn't facilitate trust in the black box model. So what I did was to aggregate the weight across multiple iterations such that all the features that are not really important and are coming up in the feature ranking will be averaged out. And once it is averaged out, only the ones that are consistent will show up in a new aggregated feature ranking. And when I carried out, when I wrote an algorithm for this new aggregated feature ranking, I did 2 iterations to test it out. And what I observe is it is more stable. Over these 2 iterations, I could reliably see the features that truly contribute to the prediction of this black box model. And the features are time, which is a constant already, sensor measurement 15, 11, 4, 13, 3, 7, 2, 17, and 8. Same thing for the second iteration I carried out. Same set of feature ranking where came up in the result, and which is much more presentable to non-technical stakeholders as an explanation for how the black box model make the prediction on that particular engine that I selected. So the summary, these 2 plots represent 2 iterations of the S-line method, and it brings about the stability in the explanation of Lime as a method. And what is the significance of this experiment I carried out? And the significance is that the introduction of the weight aggregation as a technique actually boosts the acceptance of Lime as an explanation method to make black box model more trustworthy. The research also demonstrated that the S-Lime, which is the significant improvements in Lime as a method, improves the stability of explanation over the traditional Lime when explaining complex model. By introducing this method, it improves the trustworthiness of model explanation, and also adoption of this black box model in critical domain sectors like the aviation sectors and the medical sector, even sometimes even also in the finance sector as well, where transparency of black box model is really needed among technical stakeholders to make critical decisions. And that is all for my presentation. Thank you very much.
Are there any questions? Yeah, hi. We have a question from Sebastian.
Okay.
Well, thank you so much. I've not used Lime before, but I mean, it sounds interesting to explore it and see it from explainability parts. Just at the top of my head, I'm just trying to understand. So I'm not sure if you mentioned it or maybe I missed it. How does Lime compute the feature importance, and how reliable are its ranking, most especially when it's in a high dimensional data set?
Okay. I'm trying to go back to. So this is how it works again. So after the instance of the dataset has been selected, so what Lime does is Lime generates random datasets that is close to in close value to the instance that has been selected. Then it has its own inbuilt algorithm that is used to like calculate weights of weight based on the distance of the generated data set to the instance selected. Then it makes new prediction based on the new perturbed data set. Then it fits a linear model. So how it generates the feature ranking is through this linear model that has been fitted. So the linear model is trying to mimic the behavior of the black box model, but around that particular, not across the whole data set. So that's the essence of Lime itself. So if you look at the data set as a whole, it might look so complex, the prediction that's been made. But once we narrow it down to a particular instance of the data set, so Lime just tried to mimic the behavior of the black box model, which is a complex algorithm, across that local instance selected on the data set. Then it fits a linear model, and the linear model we know is easier to generate a feature ranking based on a linear model. I want to understand the features that actually contribute to the prediction than trying to like figure this out with black box model directly. So Lime just tried to use a linear model, a simpler model, more understandable model to make the feature ranking, and that is what is being done here in the last step, which it calculates automatically the features based on a linear model, the new feature of the weights, new weights of the features, and it uses these weights to generate the feature ranking.
And wow, thank you.
So,
And regardless of the dimensionality of the data set, right?
but yeah, I understand when the data set becomes highly dimensional, when that's one, I feel that's one of the drawback of Lime itself. So when it becomes a problem also when the data set become too highly dimensional, when it has too many variables as a contributor to the prediction. So that's where I feel there's a lot of progress to be made also in explainability as a branch of machine learning.
Machine learning. Wow.
And Lime itself has a Python method. So all these has been abstracted already within a Python method for Lime.
Okay. Wow. Thank you for introducing Lime to me today. I really appreciate it. Thank you.
You're welcome.
Yeah, thank you very much for a great presentation, Mr. Ugidan.
Thank you very much.
Our next speaker is Mr. Landre Shitu. Mr. Landre is a skilled civil engineer with a distinguished academic background, holding an MSc in Applied Artificial Intelligence and Data Analytics. His expertise lies in harnessing the power of data to develop innovative, practical solutions that address real-world changes. He is passionate about technology and its potential to create positive change. Landry is dedicated to advancing cutting-edge solutions while supporting and empowering communities. Please join me in welcoming our speaker, Mr. Landry.
Sorry, I'm coming.
Yeah, hi Landry. Could you please share your screen?
Oh, yes, yes, I'm coming. Just bear with me, please.
Yeah, okay.
I don't know if anyone can hear me.
Yes, we can hear you.
Can anyone hear me? Okay, okay. So just bear with me, please. Just bear with me, please. Just bear with me. It's almost up. Share screen. Share screen. My system is a bit slow. Just bear with me, please.
Okay.
I don't know if it's sharing from there.
Yeah, just now you have shared your screen.
Oh, it's sharing already. Okay, just bear with me, please.
Waiting for the image to be loaded. Yeah.
Okay, still loading. Okay. Okay, just bear with me.
Yeah, it's okay. Now.
Okay.
Yeah, please click on slideshow.
Okay. I just don't know. My system is a bit slow from here. Just bear with me, please.
Yeah, shall we share it? Hello.
Yes, yes.
Hello.
I'm with you. Just bear with me. Hello. Yes, I can hear you. Can you hear me?
Yeah, I can hear you. Can I share
Hello.
from my end? Hello.
Yes.
Yeah, please be online.
I'm actually sharing. Yes, I'm actually sharing. It's just that my system is a bit slow, and I just don't know why it's like that. Okay. So can we see?
No, not yet.
I don't know why my system is a bit
Yeah,
slow.
it's
This
okay
has to
now.
do.
Perfect now.
I just don't know. Okay, okay, okay. Sorry. Okay. Good morning, good afternoon, good evening, anywhere we are. It's a pleasure to be here today at the third global webinar on artificial intelligence and data science. But just before I proceed, just want to confirm if my video is showing. I put on my video, but I just don't know what's going on. My system is just a bit slow this afternoon. So
Yeah, we are able to
hello.
see the screen.
Okay, 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 okay. Okay, so my name is Larry Shitu, and I'm excited to share insights on a topic that is shaping the future of the construction industry, the future of concrete testing, machine learning approach. Just bear with me. Okay, so. Okay, so this is actually overview of what I'll be discussing during this presentation. And my next slide. Okay, so concrete is actually the most essential and commonly utilized material in civil engineering, such as construction of buildings, bridges, tunnels, dams, and other related civil structures. Concrete actually has numerous properties like tensile strength, compressive strength, durability, and so on. However, the traditional way of actually evaluating these properties are often time consuming, labor intensive, costly. But with the involvement of AI, we can actually analyze and improve the testing of concrete strength faster, more accurately, and at a lower cost. So, next slide. Okay, just bear with me, please. Okay, so the traditional way of testing concrete actually refers to established method used to assess concrete properties, and most of the times, these methods actually involve destructive or semi-destructive process that actually lead to wastage of materials and errors in measurement at times, time consuming and tedious and costly also. So there are different properties of concrete assessed traditionally, but the ones considered in this study are actually compressive strength of concrete, concrete durability, and image processing in concrete. So starting from the compressive concrete, starting from the compressive strength assessment, so this actually rely on the concrete crushing tests, which are actually destructive, time consuming, tedious, and costly. Then also talking about the concrete durability, this actually evaluate the long-term performance and resistance of concrete to environmental and mechanical stresses, ensuring structural integrity and longevity. This method as well are slow, costly as well, and tedious to carry out. And the last one, which is image processing in concrete. So this process is to actually detect cracks, void, and reinforcement issues in concrete, which is prone to errors. Also tedious and time consuming. The next slide. Okay, sorry if these images look horrible. So this is like 10 years ago. I don't know if this is showing over there. Hello?
Yeah, it's not visible.
Hello?
Hello?
Can anyone hear me? Oh, yes, yes. So I'm actually showing some images. So I don't know if you can see those images from there. Hello?
Yeah, hello. Am I audible?
Yes, so I said, yes, yes, yes. So I said I'm sharing some images. So just want to confirm if they are visible from there.
Yeah, it's visible now.
All right, okay, okay, so that's fine. So these images look horrible. Sorry about that, but this was around 10 years ago when I was working as a civil engineer on a construction site back in my country, Nigeria. So as we know, construction of buildings are actually done in stages to completion. And for instance, we start from the foundation, from there to ground floor slab, which is what we know as a German floor, and so on to completion stage. And at every stage of this construction, we actually carry out tests to actually ascertain the structural integrity of these structural elements. So here in these images are some of the samples of structural elements to be tested in the laboratory. So I'm actually, here we have samples, these are just some of the samples we actually take to lab to test. So we can see how many they are, and each of them actually weighs up to 50 kg. They're actually very heavy. So let's say we want to test the compressive strength of columns, which is what we know as pillars. We actually start from sample preparation by mixing cement, water, sand, and stones together. and these samples are actually casted into different shapes, which could be in cubes or cylinders. And after preparation of the samples, then we actually subject them under what we call curing, that is keeping them in a big storage tank under water, moisture, and temperature, just to make sure that they achieve their strength, which could take up to 7, 14, 21 to 28 days. So, and after that period, we actually assume that the concrete samples have actually acquired the strength, and we then take them to the laboratory to actually test them. So when we take these samples to the laboratory, as we can see here, so we actually put them under this machine here to actually crush them. So this machine actually applies pressure to actually crush those samples. And when we are done, we actually record the measurements. So just for us to get the compressive strength of a single column, right? We actually perform up to like 3 samples, and we actually find the average of those results, which we actually get. So this also another machine we actually use to actually crush those samples, and um, achieving just a compressive strength, right? It's just like I said, it actually involves preparing and crushing up to 3 samples, and we find the average of all of these. And so imagine if we want to repeat this process for like 200 columns, that is 200 pillars, and the high-rise building, for instance, can have thousands of these pillars in them. And these pillars are just one element in the building, because we still have other structural elements such as the beams and the slabs, So just imagine that we have to perform all of these tests for each of these elements. So it's really a lot of work to be done. And these machines, which we are seeing here, just the one here, and this small one here, and the ones we have here, they're actually very expensive to actually set up, and only few laboratories can actually afford these machines, to the extent that engineers actually often travel several miles just to complete this process of testing in the laboratories. So we can see that the traditional method is destructive, as it requires physical samples to be crushed doing testing, and time consuming, costly, tedious, and prone to errors as well. Next slide. Okay, so aside the compressive testing of concrete, so the other testing we have is actually durability testing of concrete. This actually involves sample preparation, which I've discussed earlier on, then curing, which I've also discussed earlier on, then testing. But in this case, under durability testing of concrete, it involves more than one test. The previous one was just a compressive testing, but this one has a chloride penetration test. There's a carbonation depth, there's a freeze-thaw resistance, and there's a abrasion resistance. So this process is tedious as well for durability testing of concrete. It also comes with human error, time consuming as well, and so. And just like I said, because there are several steps that are involved, it makes this process tedious, and it raises safety concerns. And next slide. These pictures, I don't know if you can see these pictures as well. The pictures are taking time to load. I don't know why. Sorry, are those pictures showing from your hand, please? Just to confirm before I proceed. Kiran?
not visible. It's not visible.
Okay, I think it's because it's still loading. Just my system is just too slow.
Yeah, got it.
Um, Sorry about that. My system is just too slow. I just don't know what's going on. So this is not how it is. It's because it's actually slow in loading.
Yeah, it's
So
perfect now.
okay, yeah. So sorry about that. So these pictures here show myself with some fellow engineers some years back, trying to perform various tasks related to concrete testing for durability and structural assessments. So sorry if these pictures look horrible as well. So they're actually taken from horrible camera. So just bear with me, please. So this actually involved testing with a rebound hammer. So what I'm holding here is actually a rebound hammer. I don't know if you can see what I'm doing. So this is a rebound hammer and this is a drilling machine here. So what we are trying to do is to use this drilling machine to actually drill out a sample of this concrete slab here. Then also we have this person climbing on a ladder trying to test a portion of the building, and here is me here as well trying to test this portion of this building, and all of this setup, this equipment setup, as small as they are or as they look, they're actually very expensive. And during the process, there's high tendency for errors to occur during the measurements. And as we can see, this part of the building were actually chiseled out, just before we're able to test this part of the building. So there are some destruction in place as well, and it raises safety concern as this person on this ladder, there's risk of falling for that's for this person climbing on the ladder. So when we look at all of these things, so we can see that it's really a tedious task, so which actually gives reason for a better ways of getting all of these things done. So next slide. Uh, uh, okay, I think it's up now.
Yeah, it's okay.
Okay. I'm so sorry. Is my system is extremely slow from here. So sorry about that. So from all of this, there has been a great need for faster, cheaper, less stressful, more accurate and sustainable concrete testing method in the construction industry. And with the advancement of AI, concrete testing process has actually been optimized, addressing most of the shortcomings from the traditional ways. And several machine learning techniques, including gradient boosting regression, extreme gradient boosting, support vector machines, artificial neural networks, and lots more have demonstrated over the years superior performance in predicting concrete mechanical properties. So let me next this slide from here. This is just too slow. So sorry about that.
Yeah, Mr. Landry, can I share from my end?
Okay, so let me just send you what I have here. Sorry, just bear with me, please. Just bear with me. Because what I have here is not what you have there. Just bear with me while I share what I have here, please. Just bear with me, please.
Okay.
Just bear with me. Or do I just go ahead with what I have on the screen now?
Yeah, it's okay. It's visible.
Okay. So sorry, my system is just acting this way. So sorry, please. Okay, so starting from predicting compressive strength of concrete with machine learning approach, over the years, several researchers have actually utilized this technology to determine strength of concrete, and starting from Gunimat et al. So they actually performed an experiment where they predicted the compressive concrete strengths with random forest regression and k-nearest neighbor. So they found that random forest regression actually predicted best with correlation coefficient of 0.973, and that's high enough. And secondly, an experiment performed by Wu et al. So they predicted strength of concrete as well, but this time around using the logistic regression, multiple linear regression, and k-nearest neighbor, support vector machine, decision tree, and random forest regression, and also backpropagation neural network. And in this case, it was observed that k-nearest neighbor actually predicted best with correlation coefficient of 0.998, and followed by the third experiment by Wang et al. So in this case, they actually predicted the compressive strength of concrete containing ground granulated blast furnace slag by using random forest regression as well, extreme gradient boosting, support vector machine. And in this case, they observed that support vector machine actually predicted best with R square equals to 0.86. And likewise, an experiment performed by Grigri et al. They also assessed the concrete strengths with Gaussian process regression and support vector machine. And from here, we can see that support vector machine performed better than Gaussian process regression. And lastly, an experiment performed by Sharma et al. In 2022, they also predicted compressive strength of concrete with some machine learning models using random forest regression tree, genetic programming support vector machine, adaptive neural fuzzy inference system, and artificial neural network to predict the strength of concrete. And they actually found that ANN, which is artificial neural network, actually predicted best this time around with R square equals to 0.914. So these are all of the past researches, using a machine learning approach to determine compressive strength of concrete. So I'm trying to next my slide from here. I hope this is okay. So I have another table here before me. I don't know if that is showing over there.
Yeah, it
So
was
I've
showing.
sorry, is that what?
Yeah, it's visible.
All right, thank you so much. So, so this table actually, it was from a research conducted by me. So in this research, I actually utilized random forest regression, support vector machine, and a k-nearest neighbor to predict the compressive strength of admixture mixed concrete on a 1,030 data sets. So this table illustrates the performance of the three machine learning models, evaluated, employing correlation coefficients and the root mean squared error and the mean absolute error. As we can see, it was observed that random forest, which is this, so this random forest actually demonstrated the best performance, achieving the highest correlation coefficient of 0.99 against 0.8 for k-nearest neighbor and against 0.57 from support vector machine. And also this random forest had the lowest mean absolute error of 1.30 against 5.61 for k-nearest neighbor and against 8.15 for support vector machine. And also random forest has the lowest value for root mean squared error, which is a 1.96 against 7.54 for k-nearest neighbor and against 11.10 for 11.1 for support vector machine. So this research that was conducted by me simply means that random forest was a good machine learning model to actually use to predict compressive strength of admixture mixed concrete. So next. So I'll just next the slide.
Yeah, it's visible.
Okay, it's visible. All right, thank you. So, assessing the durability of concrete is actually a major requirement in construction industry. For instance, degradation due to corrosion in concrete structures is actually it's a significant global issue, costing billions annually in repairs and maintenance. Western Europe alone spends like around I think 5 billion euro yearly on rust related damage, making repairs costly, time intensive. But this traditional approach of assessing the durability of concrete, just as we can see, is expensive, time consuming as well, and tedious. Just like I have on the screen here, these are the research. Sorry, the researches that have been conducted over the years in utilizing machine learning approach in determining concrete durability. So this first one is Zhang et al., which actually employed support vector machine to estimate the rate of chloride ingress in reinforced concrete. And we also have Nunes and Nedi, which actually use the gradient boosting regression tree to predict depth of carbonation. And this big picture here we have was actually conducted by Tafis in 2017, which actually employed this approach in determining the durability and service life of reinforced concrete. So all of this setup that we actually see, the aim is to actually determine the durability and service life of reinforced concrete. So let me next my slide.
It's visible.
All right, thank you. Okay, so this actually talks about image processing in concrete using machine learning approach. Non-destructive testing techniques are actually uh, indispensable tools for evaluating concrete structures without causing damage, which is a good one. But this method actually struggle to process effectively. Machine learning approach enhance this traditional way by analyzing the large data sets to detect hidden defects, cracks, and other structural anomalies in concrete to actually save time, stress, and this is actually cheap to conduct. So from this, uh, Yokoyama in 2017 was able to conduct an assessment of cracks, just as we can see in concrete with CNN, and also Ryuta in 2018 employed artificial neural networks and support vector machines and support vector regression to evaluate concrete failure surface. At the end of the experiments, support vector regression produced the best results in comparison with the other two models. So that is for this. Let me next my slide.
It's visible.
All right, thank you. So, so here is how the traditional ways of concrete testing is being compared to machine learning approach. So when it comes to techniques used, the traditional way actually, just as we can see, it involves a physical and chemical test, destructive strength test, and the manual NDT image analysis, while the machine learning based approach involves predicting modeling. These AI driven image processing and sorry, okay, so let me let me go to the next one. So as for time efficiency, the traditional way actually takes time to complete, just as we can see in days, and at times this process takes weeks, it takes months, but the machine learning approach is actually fast. And for material wastage, from the images I shared, the traditional ways actually involve physical samples, to be destroyed. Why this is not so in the case of a machine learning approach. And in terms of accuracy and cost, the traditional way, they're actually prone to errors and costly, why reverse is the case when it comes to machine learning approach. And then lastly, as for automation and scalability, the traditional ways actually requires manual input, and it depends on expert availability, while the machine learning approach is actually automated and easily scalable. Next slide.
It's visible.
All right, thank you. Thank you. Thank you. Okay, so this talks about challenges and the future directions in the challenges of machine learning based concrete testing method. Sorry. Okay, yes. Okay, so the challenges using this approach. The first one here, as you can see, is limited historical data. Just like the research I conducted myself, it was based on 1,030 data sets, which is not enough. That is too little. So this actually gives rise to reason why future research, to be focused on developing a large scale and a high quality concrete testing data set. And also model generalization difficulty. So machine learning models trained on specific data sets may actually struggle to generalize to new or diverse conditions such as different types of concrete or environmental factors or testing scenarios. Then also lack of standardized data collection. So the absence of standardized method for collecting and labeling data can lead to inconsistency in data sets, reducing the reliability and accuracy of machine learning models. And when it comes to high computational requirements, training and deploying advanced machine learning models, especially deep learning models, require significant computational resources, which can be costly and time consuming. And data security and privacy risk. So the use of sensitive or proprietary data in machine learning models actually raises concern about data security and privacy, particularly when sharing data across organizations or platforms. So for future directions in using this machine learning approach, well, the first one, okay, I think I've talked about the first one. So for the second one, which is improving model generation across diverse conditions. So enhancing the ability of this approach to generalize by incorporating diverse data sets and advanced techniques like transfer learning. So this will actually make them to be more reliable in real-world applications. And for the third one, which is standardizing data collection and quality control, establishing standardized protocols for data collection and quality control will actually ensure consistency and reliability in dataset, leading to better model performance. And the fourth one, which is addressing high computational cost for machine learning models, optimizing algorithms and leveraging cloud computing or edge computing can reduce computational costs associated with training and deploying machine learning models. And the last one, which is enhancing data security and privacy in AI-driven concrete testing, implementing robust data encryption, securing secure sharing protocols and privacy preserving techniques. For instance, federated learning, we actually address concerns about data security and privacy. So, okay. Okay. Is that showing as well? Sorry, Kiran.
It's visible. It's visible.
Is all right. Thank you. So, as we have seen so far, that machine learning approach is actually revolutionizing the field of concrete testing by introducing innovative advancement that actually address the limitation of traditional method. So, this cutting-edge technology are actually enabling faster, more cost-effective, and environmentally sustainable approaches to actually evaluating the quality and durability of concrete. As machine learning technology actually continues to actually advance, their potential to reshape this construction landscape becomes increasingly evident by integrating predictive modeling, artificial intelligence, and advanced data analytics. These methods are enhancing the safety and efficiency of concrete structures. And furthermore, the ability of this approach to process large data sets and identify hidden patterns actually ensures that concrete testing is not only more reliable but also scalable to meet the demands of modern infrastructure projects. And so all we can say in conclusion is that this approach, this machine learning approach, is not just transforming the way concrete is tested. It is paving the way for a new era of smart infrastructure development by addressing the challenges of traditional methods and unlocking new possibilities. And this approach are actually enhancing the safety, the efficiency, and sustainability of concrete structures. As the construction industry continues to embrace these advancements, the future of concrete testing looks brighter with the promise of smarter, more resilient, and environmentally friendly infrastructure. Okay, so this is the reference. And okay, so thank you all for your time and attention during my presentation. I hope you found the insight valuable, and I would like to open the floor for any question or comments you may have. Also, in case you love to stay connected or continue the conversation beyond the session, you can find me on LinkedIn by scanning the QR code, which I have shared, or by searching for my name, Larry Shitu. Thank you.
Are there any questions? Yeah, thank you very much for a great presentation, Mr. Landry.
Yeah, thank you. Thank you.
Our next speaker is Dr. Venkata Duvuri. Dr. Venkat is the founder of Serious Mindshare, a AI apps research company, and recently a director of data science at Oracle Corporation. He results in oriented data science, business, web and marketing analytics leader with over 12 years of experience in data science, business analytics, digital media analytics, and web marketing optimization with leading internationally recognized corporations. Additionally, 10 years of experience in software engineering, a top business school MBA. He has experience in management of onshore and offshore teams, as well as leadership experience ranging from director to manager at Fortune 100 companies, including marketing agencies. He is a cross-functional leader and subject matter expert in machine learning. He has improved ad performance to the tune of $10 million at Unity Technologies and $7 million at Oracle leveraging deep learning, Spark, MLIB, and TensorFlow operating on big data. He has driven improvements in business and online marketing outcomes to the tunes of several $1 million at eBay, that is Triad Retail Media, and Conservant, that is Alliance Data, and AT&T Cricket Wireless, and crunched several terabytes of data at Apple Corporation. He holds a master's in computer science from University of Massachusetts and a MBA from the University of California, Davis. Additionally, he has a doctorate at Purdue University. Finally, he serves on the advisory alumni board at Graduate School of Management at UC Davis. Please join me in welcoming our speaker, Dr. Venkata Duvuri.
Hello, welcome everybody. Let me share my screen. Okay, hopefully everybody can see the screen, right?
Yes, we can.
I'm going to talk about my PhD thesis or doctorate thesis, which I just finished last year. I'm glad to be here, and my talk is on lift and shift of model code using machine learning microservices in SaaS applications. So the study basically has been done for the period of four years, and so SaaS applications have increasingly been increasingly developed a need for machine learning frameworks, and this has been quoted in the literature by Philip Rao and others recently. And the importance of machine learning in SaaS applications and AI in SaaS applications has tripled or quadrupled in the past year, with several of them adopting such AI assistant tools. Additionally, there is also another need which is increasingly important to discuss, which is the porting or the lift and shift of models from one application to another application. This lift and shift of models is something new because several models are being built in recent times, and the effort is to lift and shift these models to nearby sister applications or related applications at ease. So the study has two subjects. One is machine learning frameworks, and second is how they can help lift and shift of ML model code in enterprise applications. So we devised a framework called Minerva, and the next generation called Contain in Serious Mindshare Labs. And the idea is to make this porting of ML models and quicker, which means ultimately innovation is quicker. This need has also been identified by Vidya Lakshmi and Kumar in recent times. And this need to innovate quickly has quadrupled with the advent of generative AI in recent years. So with the help of this open source framework that we have in GitHub called Contain, people can make avail of portable ML microservices and innovate quickly. But since it's a research objective, we are not stopping at just devising the framework. We are studying, or I have studied how it accelerates innovation, how it accelerates deployment of ML models, how it accelerates porting of ML models. And what we are talking of in this mechanism is porting of ML code, which is different from transfer learning. We are talking of porting of ML code itself to a new application. And the framework that has been designed called Minerva or Contain the Next Generation supports all the necessary ingredients that we discussed or challenges in recent times for SaaS applications. In particular, one additional benefit of this new framework is that it can coexist in on-premise and cloud. There are a lot of legacy applications still. About, I would say, 50% of the applications are still on legacy infrastructure, and our framework actually works with them without them migrating to cloud. So that's one new novel benefit, which is only served by Acumos, which is another framework devised in past 5 years. And the other novelty is, which nobody addresses, is that We have studied the portability of ML models across applications, and this framework helps accelerate that, which nobody else does. So the research methodology has been to study efficiencies. And efficiency we study by measuring speed of development, speed of deployment, speed of porting, and also to make sure that this framework that is devised is real life purpose. We use variety of load tests on it to make sure it scales properly. The data that has been used to fuel this study has been developed from real life use cases. It's called purposeful sampling as described by ML et al. In 2013 in their book. This purposeful sampling means you devise samples from real life use cases and not simulations. So we have used these data sets to devise our experiments. The first experiment is whether microservices means ultimately having a modular or independent ML service that can be separated out from the rest of the system to serve ML needs and SaaS applications. Whether that addition of that ML microservice benefits SaaS application in terms of portability, deployment, and other efficiencies. That's one ablation study. The second ablation study is on top of this ML microservice, if we include something called the data layer, can we port ML model from one application to another? And these are sister applications, right? They might be things like MailChimp and Constant Contact, which are sister applications, SaaS applications, or there might be things like in the olden times, Responses and Eloqua. And there could be several other sister applications which are quite close by. And so the idea is to study whether the porting of the models between these related applications increases in speed with the inclusion of a data layer in the ML microservice layer. And then we also study different contexts. It is well known that most of the enterprise applications have in the same company have related applications, but can we do a study and can this microservice work across different companies' SaaS applications that are still related? Because of the competition, free competition, there is always another version of the same application somewhere else that needs the same ML model code. Can it be ported across such applications when it is permitted? And then, of course, we do load testing of the devised microservice. And it's called ML microservice because it can, and also AI microservice because it can pretty much be built and develop any ML model or AI model. This is how a typical enterprise application is. There's a data layer in the middle, which consists of data processing, orchestrations, etc., and transformations. There is the application layer on the top, which is the UI platform of the application and other things at the top. And at the bottom, we are saying there is a ML microservice layer, which interacts with all the upper two layers to achieve ML or AI models into the application. And the device solution called Minerva or Contain, the next generation, has 3 layers: core, stub layer, and application layer, apps layer. Apps are basically another synonym for ML model in our language, in our paper. This microservice that we devised has REST APIs, multiprocessing, job tracking, train and predicts, online and batch, and security related concerns are addressed through various secure protocols like HTTPS. There is Dockerization of the whole solution, which is why it works between legacy and on-premise without a problem. The abstractions are at the middle. These abstractions are for things like versioning, storing other models, and exceptions and things like that. And the apps, which is the model layers, you can pretty much devise any ML models as well as any ML or AI code by implementing the interfaces provided by the abstraction layer. So this is the solution or a high code. So because of the need for porting, we have devised 3 porting mechanisms: high code, low code, and no code. High code is when somebody actually writes hundreds of lines of ML model code and rewrites them, and the study evaluates how long it takes to rewrite them manually. That is like the baseline, and it's high code solution. And of course, this is a ML service, so this is the API interface for that ML service. Then the no-code solution, which means that to shift models, lift and shift is our terminology that we coined. This lift and shift can be done through JSON configurations, which are listed in the table. These no-code solutions help to achieve minor changes needed when you move models from A to B. And then we have a low-code solution. Now, this low-code solution means it is become possible recently because there is LLMs and chat GPTs and other solutions which can now write code automatically. And we have studied how long it takes to write the new code, to devise small experiments to port models, ML model code, using mappers from generative AI, and the speed which this can be done with. Now, the results of this speed or efficiency evaluations, the first finding is that just by introducing a microservice, you have significant improvement, or you basically double your speed of building ML models just by introducing a microservice layer or high code solution. Even the deployment is generally deployment activities are independent of the underlying complexity of the code. So deployment, there is not much significant lift in the efficiency. Now, the no-code solutions also has a 2x improvement, but it's not significant because our experiments were meant for realistic small models, and these small models have lesser lines of code. So the no-code solution did not significantly give a lift or statistical significance. Now, when we introduce the data layer, so earlier studies was just for the microservices. Now, the next experiment is to introduce the data layer to achieve porting of the code. And the porting of the code has a strongly significant lift due to introduction of a data layer. Now, the data layer is something which can be automated through generative AI, which is our next result. The generative AI, when you automate the data layer, the results are not significant lift over the previous optimizations. Now, several companies they have thousands of engineers. They have already been optimizing for them. These big companies that are really at their game. For them, they might not see a significant lift with small models when you introduce generative AI, but for traditional companies or traditional IT organizations, when you introduce generative AI, when it compares with their original mechanism of in building ML models, generative AI can significantly accelerate porting of ML model code from one application to another. That is a corollary and a common knowledge base as well, that generative AI will significantly improve when you are starting from scratch. And the experiments for load testing said that this system that we devised is capable of about 10 RPS, requests per second, and can serve online requests quite reasonably. In conclusion, there can be a 1.15 to 2x faster adoption innovation. Now, when models are being adopted by some other applications, the innovation is spreading. So this innovation can be 1.15 to 2x faster. And the layer design, which is introducing microservices, then introducing data layer, then introducing generative AI, this kind of layered service can help structure your innovation as well as structure your organizations, development groups, or AI organizations. The open source contain ML framework, which is a derivative and a smaller version of the original solution, is a big step forward in the strategy to build any AI ML model and port it. That lift and shift that we call and port it with 1.15 to 2x faster speed. And lastly, generative AI in the past 2-3 years has been a great phenomena which helps this porting of ML model code. And finally, our solution or the proposed innovation or research says that the device solution actually is compatible with both legacy applications, which are about 50% at least in the world, and the new breed cloud applications, which are the rest of the 50. So that's in short my talk, I thank my Oracle team. I see one of my team members here, as well as the Serious Mindshare team that devised that the lab I had and I founded. The engineers helped me a bit in building this again. So I thank them and open up for questions.
Are there any questions? Thank you very much for a great presentation, Dr. Venkata.
Thank you. Bye-bye.
Yeah, Professor Francesco, do you have anything to say?
Yes, just the closing remarks. And I would like to say good evening to everyone, at least in Europe is evening. And it has been an honor to stand before you today as we bring the day one of the global webinar on artificial intelligence and data science to a close. Today we have a shared insight explored innovative ideas, and built valuable connection that will undoubtedly shape our future endeavors. First and foremost, I would like to express my deepest gratitude to our esteemed speaker, panelists, and moderators for their invaluable contribution. Your expertise and dedication have made this conference a rich and enlightening experience. An heartfelt thank also to organizing committee, volunteers, and sponsors. Without your hard work, commitment, and generosity, this event would not have been possible. And of course, a sincere appreciation to each and every participant for your engagement, enthusiasm, and willingness to collaborate. As we conclude today's works, let us now view this not as an ending, but rather as a new beginning. This knowledge we have gained, the connection we have fostered, and the ideas we have generated should serve as a catalyst for positive change. Let us take what we have learned and apply it in our respective fields, organization, and communities. I encourage each of you to stay connected, continue the conversation, and collaborate beyond this event. The impact of our discussion here should extend far beyond these walls. See you tomorrow for the next day of this conference, and have a great evening. So nothing more, Kiran. I hope that it's enough.
Right. Thank you, Professor.
Thank you. Thank you.
Yeah,
See you
thank you,
tomorrow.
Sebastian. Thank you, Tolwold. Thank you, Professor Hind. Thank you, Mr. Landry, and everyone on the call. Okay. Bye-bye.
Okay. Bye. See you tomorrow.
Bye-bye.